there? Are we just waiting for like other judges now?
Yeah, so Chantel is sick. She's gonna try to watch remotely if I can make the camera work, but we might have to take a loss on that.
Okay.
And who else is on your docket? I forget.
What was the name?
So I'm just gonna keep puttering for a minute or two to see if I can get this video going for Chantel.
I have to listen to this one.
Does anybody know how YouTube works?
YouTube?
Yeah.
You mean to upload something?
Yeah, so if I think that I'm live streaming something, how do I find out what I'm live streaming?
Okay.
I guess you have a channel, right? Are you logged in?
Yeah. Oh, there we go.
Okay. Great.
Fast food.
Alright. You said
Doesn't really matter.
okay.
Wherever you're going to be comfortable all day.
Okay.
Okay, so I just sent a link to Chantel. I can see it streaming here, like on this computer, going through all the other computers. So let me just get the angle on this guy, adjust it slightly. Okay, do you want to say something? Like, talk like you're presenting.
Roll one.
That you're gonna talk louder when you present.
Okay. Like way louder, like this. Testing.
There's a time delay, so
Okay. Test.
yeah, okay. So I think our microphone is using the camera mic instead of the mic over there. So just talk loud, and I'll try to shut up. All right.
Hi, we're Team Degree Compass, and we developed a web application that provides rapid degree audits for students. And our solution is currently available on degreecompassuw.com. So here's an overview of the topics we'll be covering today. So to start off, the main motivation behind our project was the fact that currently verifying degree requirement satisfaction as a student is time-consuming and error-prone. And this is because degree requirements are often complex and difficult to understand. So with this in mind, we developed a solution with two main components: a front-end web UI built with HTML5 and JavaScript, as well as a back-end solver built with Python. And the main user flow that we wanted to achieve with our solution was simply 1, select a program, 2, specify a list of courses, and 3, see whether that list of courses satisfies the degree requirements for the program selected with minimal delay. So one of the main design choices and principles that we used to build our solution around was to make it student-friendly. And the main way that we did this was by developing a web UI to facilitate student usage. And as a consequence of this, we also had to make our backend solver deliver results as quickly as possible in order to improve the user experience. And this is one of the main reasons why we decided to go with a fresh start as opposed to extending the existing work done by past FYDP groups such as Degree Audit, because we felt like their solution was too comprehensive for our use case. And also their solver took too long to provide a responsive web experience.
So the reason that in general solving the problem of whether a student's taking courses satisfy all of their requirements can take a very long time is that they fall into the NP complete category. And this can be shown by a reduction to subset sum, and Maestoso also showed a reduction to the 0-1 knapsack problem, as well as the set packing problem. In general, to solve these types of problems, a SAT solver can be used, such as the one that was responsible for scheduling today's presentations, which is MIT Alloy. And the basic algorithm used is DPLL, which is a SAT solver that works on SAT problems in the conjunctive normal form. And what the solver does is it progressively assigns each variable in the SAT, either true or false, and then tries to move down the decision tree and assign all variables some value that allows all of the statements in the conjunctive normal form to become true. If at any step this is not possible, it will backtrack, assign false, and try again. And at the very end, if we have a solution, then that is the solution to the SAT. Or if there's no solution, then we say that there's no solution. Modern improvements, such as COD, which is used by MIT's Alloy, perform optimization steps prior to the actual main part of the DPLL algorithm. And what it does is it looks at things like symmetries in the SAT, which are similar variables where they have a pattern such that you only really need to check one of them, and you don't need to check assignments for all of them. They also do things like look at the raw and/or tree, which is a tree representation of the conjunctions and disjunctions in a SAT. And what it can do is it can look at the structure as well as look for shapes that it knows how to optimize. And they came out with a very lengthy and great paper that was 96 pages long. And that provides a lot more detail if you're looking for additional information about how it works. So the difference in our approach is that we wanted to remain within the domain of courses and requirements. And what this allows us to do is it allows us to avoid having to translate our requirements into a SAT problem, pass it to an off-the-shelf SAT solver, get it back, and translate it back into the language of courses and requirements. But outside of that, our solution is actually very similar to DPLL in the sense that what DPLL is doing is it has a decision tree of Boolean variables that it's trying to assign, whereas we have a decision tree of requirements, and what we're trying to assign to the requirements is not a true or false value, but we're trying to assign a set of courses to them. So the way that we end up doing this is we start off with a set of courses that the student has taken, and then each requirement in our tree of requirements will attempt to find satisfactory sets of solutions. And each time it finds a satisfactory set of solutions, it will take out the used courses, and then it will pass down the remaining set of courses to its children. And the primary difference in our approach in terms of our previous implementations, not referring to degree audit, but with what we did in SE490, is that we switched to a Python coroutine model, and this helps us save a lot on the memory consumption of actually passing down a ton of information, and we never even need to compute additional solutions if they're not used. And so you can expect that our solver would have these three object types. A course represents a course and has everything you would expect a course to have. So it has a faculty, it has a course number, it has an optional suffix, for example, in the case of ECE 457A. It also can store prerequisites, anti-requisites, as well as a credit count. A solution is the interim object that requirements pass to each other and contains a set of remaining courses, as well as a mapping of courses to requirements that have been used to satisfy requirements. So the solution object is our primary way of keeping track of where we are in the solution and what we have to use. Requirements then are any kind of requirement that you'll see on a program. So that could be you need exactly ECE 105, but it can also be more complicated things. Like it can be a range. It can be you need anything from CS 100 to 199. It can get even more complicated with ands and ors and minuses, and it can get to the point where you have requirements that are almost not readable. But we try to support a good set of them, and one of the ones that we managed to get done fairly simply by staying within the domain of courses and requirements are the CS depth requirements. So the chain of 3 prerequisites, as well as the subject depth requirement of having 3 courses from the same faculty with 1/300 level. Those are all things that we can support with our model. And I'll go a bit more into detail about how we do that in a bit. In addition to just the objects, we also need to know what the programs are and what courses the student has taken. So to do this, we have a program file and we have a taken courses file. A program file is a file that just specifies what the requirements are, and a taken courses file is a basic description of a student's transcript. It contains their program, it contains a list of courses that they've taken, and it also contains any overrides that they may have, which was one thing that we planned. And these files are all in the standard YAML format, which is fully compatible with JSON. And we made this a conscious decision because we wanted to be able to have very quick adaptability to a web interface. So on the left is an example of the SE 2017 program, which is the program that all 5 of us are currently on. And so the degree component, the degree and the component requirement types are just aliases to the all of. So the degree SE 2017 requires all of these components. So the first component is the 1A component, and it requires all of the 6 courses that we have to take in the 1A semester. Here is a science elective component, and it requires 2 of science elective items, where science elective items is just another requirement that we defined earlier in the file. So one thing that we consciously wanted to also do was to allow for importing and referring to existing requirements. So you can see in our taken file, where we specify that we are taking SE 2017, here we have overrides. And in the overrides section, we see that we are able to replace science electives, which were defined here, with a 2 count of any advanced technical elective, which is just another list of courses that was defined in the program file. And so the way that our algorithm works is that it starts with the taken file. The taken file defines a program. So we go and we fetch that program file, and our application will generate a tree of requirements, such as the one you see over there. And then it will also, at that point, apply any overrides that you have. And because we're able to have domain understanding of what a course and a requirement is in our application, we are able to just tell a requirement you are being overridden by something else. And that allows us to simplify that process greatly. So then, after that, the taken file will also cause the generation of the initial solution object, which contains an empty satisfactions mapping, because nothing has been satisfied yet, and a list of remaining courses, which is just the initial list of courses that the student has taken. The solutions object is passed to the first requirement, and because a degree is the same as an all of requirement, it has to recursively check its children, and it will pass it to all of, and that all of will then pass it to the exact. And suppose that that exact is the exact ECE 105 that I mentioned before, then what can happen is you have a satisfaction there that's generated. The exact requirement knows to check the remaining list of courses to see if that course is found. And if it is found, it will remove that course from the solution's remaining courses, and then it will also add a satisfaction that says that the ECE 105 course was used to satisfy the exact ECE 105 requirement. And then it will pass back a modified solution. And we do this because if we ever have to backtrack, we want to be able to have the original solution, and we can make modifications on that. So this is repeated since the all of needs to check all of its children, and at each stage, we see that it passes back a new solution. And once this is done, the all of is able to report that it has completed, and it will pass the solution object back to the degree, and that will pass it to the sum of. So I won't go through all of it, but for example, the way that the sum of requirement implements its solver is it will go through its requirements, and it will ask, hey, all of, do you satisfy? Or it will pass the requirement set to all of, and if it returns a success, then we say that it has satisfied one of the 3 sum of required, and we just do that 3 times to make sure that the 3 requirements are satisfied. So I was mentioning that we were able to solve for more complex requirements like the chain of requisites, as well as the subject depth requirements, and that's because each solver or each requirement implements its own solve function. So it knows about all the courses that are there, and it's able to actually just look at the courses. So for example, for our 3 courses from the same faculty, at least one of level 300 or higher, the solver for that starts off by just finding all the courses that are at least level 300, and then it looks at the faculty of that course and tries to find 2 more. And that's how requirements like that are implemented. We also support things like anti-requisites. And the way that anti-requisites work is anytime we use a course in a satisfaction, we check that course's anti-requisites. And if any of the anti-requisites were found in the set of remaining courses, we just take it out and we say that that was removed because of an anti-rec. So there are, of course, many features that we don't yet support. But because we are within the domain of courses and requirements, these are things that we expect should be fairly easy to implement if needed. So this includes things like requesting multiple program components from the user instead of just the one program name. It includes things like triple count prevention, which you can do by keeping track of courses that have already been used twice in the solutions object. And we can also implement a grade requirement for courses, but we don't currently take that information in. And with regard to the triple count prevention specifically, we have a mechanism that allows a requirement to not actually use up the courses that were used in its satisfaction, so that courses can be used to double count. Say if you have 2 components, you can flag each component to not consume the courses that were used to satisfy it, and that allows both components to share courses. So, of course, as with any project like this, there are going to be limitations, and I'll pass it to Guangzi to handle this.
So, regarding the first limitation, one thing about these program files is that we need to write them down by hand and then optimize them by hand as well. I'll go into that detail a bit later. And then Calvin will talk about the issue we have with parsing prereq and anti-requisite data. And lastly, this is related to our design decisions. We try really hard to veer on the side of caution, which is why we decided to avoid false positives strongly. And because of this, then the false negatives are unavoidable. They're rare, but we cannot guarantee that there's no false negatives. The issue we did this is, if a student sends in the transcript and then gets back a result saying they can pass, when in fact, in actuality, they could not, that is that's a worse outcome than compared to they could have passed, but they didn't. And our web UI, as you'll see later, just suggested them that, hey, we weren't sure if you could graduate, check with your advisor. So this way, we're trying to veer on the side of caution. And that is kind of related as well to the difficulty we have with parsing prereqs and anti-prereqs. So regarding the first limitation we have, the manual optimization, the example we have here is for a Bachelor of Computer Science degree. Usually, there's 2 requirements here where we need 5 credits of any non-math elective and 4 credits of any elective. And that translates to basically there's usually after we fulfill all the CS, math, and all these other requirements, we have about 18 courses left. And the phenomenon we notice is that if our solver tries to satisfy the 4.0 credits of any elective first, and then tries to go into the 5, and then try to satisfy the 5 credits of any non-math elective, there's a higher chance that the 5.0 credits will not be fulfilled, because it's very probable that for the 8 courses used to satisfy any elective, they took some of the non-math electives. So by forcing our solver to satisfy the 5.0 credits of any of non-math electives first, instead of the 4.0 credits of any elective, we drastically reduce our runtime. Because say in the first case where we try to satisfy 4.0 credits of any elective, we can represent it as 18 permute 8, which could result in 1.8 billion backtracks in the worst case. However, by making it fulfill the 5.0 credits of any non-math electives, that is basically it's all eliminated. So and I'll pass to Calvin to talk about the prereqs and anti-req parsing.
Great. So unlike program files, actually, this process of parsing prerequisites and anti-requisites is actually not manual, but at the same time, it's not necessarily trivial and somewhat limited. As Guangzi said, the idea we had in mind is we want to sort of prevent false positives, so we want to be sort of restrictive in that sense. So this meant for us, when it comes to parsing anti-reqs, we would unconditionally take in courses that we see in the description. And if we ever fail to parse out a description that that then gets checked in a transcript, we would immediately fill that transcript. But otherwise, our current process actually involves 2 steps. So within a description, we lex the description to 3 tokens of type faculty, course numbers. This includes course suffixes, and any other tokens that we see in the description that we sort of deem as irrelevant. And then in the second step, we would use a finite state machine on those tokens to dictate how we want to build up our courses or how we want to change the faculty within while we're parsing the description. So the current process that we have for anti-reqs, at the very least, it actually manages to parse out almost all the descriptions. And just to give an idea of some of the things that we actually do support, it includes stuff like optional text, section numbers that would look like course numbers, varying uses of slashes, and I guess the misuse of spaces. But some of the things that we actually don't support would include semantic descriptions of courses. So this would include stuff like high school German and any university 300 or 400 level Bible course. And of course, we don't really accommodate spelling really well, so English department spelled wrong, and thus we don't necessarily output the correct thing. So for prerequisites, we actually sort of have a slightly modified process where any irrelevant tokens that we have, we actually sort of just fail immediately. And the reason for this is because it actually turns out, prerequisites are sort of fundamentally harder than anti-requisites. They're not just a list of courses. So we would need to support sub-expressions and complex keywords like one of, two of, and, or. And you can sort of see its usage over here. So or, sub-expression, and, one ofs, two ofs. So that's sort of why we sort of are a bit more restrictive in terms of prerequisite parsing. But otherwise, just like anti-regs, we also aren't able to parse out semantic meanings. So this includes grade requirements, unit requirements, if a student is at a particular level, or if it's open or not open to particular faculty. And again, we don't really support unformatted or misspelled things, so we don't support any regs. Otherwise, I will pass the correctness testing back to Guangxi.
Alright, so we had access to the old degree audit code base, and we dug up some of the Byron test cases. It's comprised of about 60-ish, comprised about 60-ish computer science faculty transcripts, plus 20 or so biomed side transcripts. And yeah, so we had to tweak them a little bit, such to account for cases like they coded course overrides with health 1xx, whereas to our solver that means something else, like a range of courses. So small things like these are the tweak, and outdated courses and manually add to our course database. But yeah, so then we ran both ours and degree audits tests, and there's a 100% match. And but the main thing I would point out is that our solver took 7.6 seconds to run all these, whereas we, timing and degree audit took about 6 minutes, give or take. So yeah, I will now talk about the UI code.
So this is what our UI currently looks like. And the general flow would be that users would start off at the top by selecting their program from the dropdown. After that, they can either import their transcript to our parser, which will extract all the course codes and place them in the list below. Or they can manually add a course by using the input next to the blue button. And the icon at the bottom of the page will automatically update depending on whether the courses in the list satisfy the degree requirements for the program selected. And in the case that it fails, then there will be an error message which displays the requirement that was not satisfied. So now Ken will talk about the user metrics.
Okay, so some common user metrics we have is that we have about 500 users who visited the site. We have a 50-50 split of mobile and desktop. But what we really want to know is, out of these 500 users, how many of them are actually engaged in checking their graduation status? So we define this engaged user as somebody who checks their status, but they've added at least 5 courses. And by looking at this user segment, we saw that, in fact, 12% of all of the users are considered engaged. And we have some other interesting notes here. 95% of those engaged users try to manually add courses or remove them. And also 95% of them also successfully import their transcript. So you may be wondering, well, what are the other 88% of those users doing? Well, really, they're not doing much. So based off of some qualitative feedback we had, what usually happens is they go on our site, they see, the main problem is that they see that their program is not implemented yet. And so they say to themselves, okay, I have no use for this tool, so they just leave. Another reason for the large 88% is that some users go on this site on mobile. They see it's not optimized for mobile. It is mobile friendly, but it's just not optimized for it. So they go to their desktop and use that on their desktop. So we also have this other user study that we were curious about. It's not really the main point of our tool, but in the past few days we were just wondering about it. So this user study answers the question, are users using our tool to plan future courses to graduate? Our tool can be used this way, but we just wanted to know what are people actually doing this. And the truth is that hardly anyone is using it like this. The reason for that, it could be because we launched the marketing just 2 weeks ago, and we think that students need time to plan out their future courses. Also, we make no efforts to help students in this process. We don't suggest courses to them, for example, when they fail graduation. And so we have these possible improvements we could make in the future. So by popular demand, we could add more programs. We could improve the transcript and info parsers. So right now on the site, you can import your transcript. That transcript parser parses the course codes, but it doesn't parse things like what term you took those courses in, whether you passed or failed them. These are things that are possible. We just didn't do it because we didn't have time. We could organize the courses better in the UI. Right now, as you saw before, they're all clumped into that one box. We could organize it better by term. A nice to have feature is automatically loading the mandatory courses the student has to take. That just speeds up the process of using the tool. And we can also provide more feedback upon a fair satisfaction. And also some other backend improvements that Guangzi mentioned before.
Right, so this sort of concludes our presentation, and this sort of just reiterates the topics that we've gone over. Otherwise, we're sort of ready to take any questions if anyone has any. Yes?
In terms of the 507 users, where did you deploy, where did you deploy the program?
We used AWS to host the site.
No, sorry. What was your base of students, or who did you give it to specifically?
Right, so we marketed to mainly Facebook groups for students, for students here. So most of our users are coming from Facebook groups.
But they weren't necessarily the ones that were the work that you had completed for this. Do you understand what I mean? So like they weren't, you give it out to a Facebook group, but it didn't apply to everyone who was in the Facebook group.
Right, and that was a limitation because of the multiple years of possible programs too. So I think that we wanted to reach a large audience in part because we also wanted feedback on the user experience, not just, or the overall UI, and not just specifically using the actual program itself. So we marketed it to a much wider audience than we actually had support for.
So I guess, are there any other questions?
Absolutely. I'm curious, for those of you that worked in the back end, why did you choose Python rather than something compiled? Because you've said that speed was one of your criteria, and interpreted languages.
So actually we wanted to use C++, but currently we're waiting for C++ 20 for coroutines to get properly integrated into the language. And we felt like just for the benefit of rapid development, and because Python has built-in generators support, we just chose to go with that. And we found that performance was really good off the bat, so we didn't feel the need to, we actually tried to implement it in C++. We ran into a lot of friction getting things to work. So we just came back and said, all right, let's make this work, see if it performs well enough. And it did, so we stuck with it.
Okay, good, thank you. Secondly, can you go back to slide 5, please? So I'm curious, I'd like you to talk a bit more about the trade-offs between Degree Audit, the Quest auditing tool, and your tool. Like, why is it not a replacement for Degree Audit?
So Degree
What
Audit,
does Degree Audit do that yours doesn't?
so Degree Audit does a bit more in terms of integrating grade requirements. It parses the transcripts in like a far more detailed way. And in general, it is more reliable to use for like in the worst case scenario, because for our program, you do have to manually optimize the programs otherwise they could have poor performance. Whereas with degree audit, MIT Alloy is an amazing piece of software, and it's able to compute difficult requirements in a more holistic way that we don't currently do. So if you were to implement similar kinds of...
So is that another way to say that you're more likely to have false candidates?
Not necessarily. I think we are maybe actually less likely to have it because we're actually able to support more things like anti-requisites that are very easy to implement. We can support more requirement types. But it's just that for failing cases, it could take longer if the programs are not optimized. And with regard to Quest audit tool, we don't know much about it, but from what we've heard, it's absolutely comprehensive, but you can't change core courses in it, and it doesn't handle overrides as far as we know.
So you actually touched on one of my other questions, and that is, what does it mean to optimize a program?
So
expand on that.
Right. So the way that our program works by default is it tries to figure out what the easiest requirements to satisfy are. So for example, these are the kind of requirements that are just you need to have all of these 5 things. And we do that so that it reduces the remaining size for the feature solvers. But that's not always the right order to necessarily consider things, because if you have 2 elective requirement sets and one is the superset of another, you can actually just look for courses in the smaller set first. And once you have found a solution there, the remaining courses will by default also satisfy the larger requirement. So for things like that, we implement a couple of optional flags that you can type requirements with, and that includes order, which overrides our default detected order to run the requirements in. And there's also a flag called disjoint, where it will run the requirement and return only the first solution. And if that first solution does not lead to a successful solve, we just say that it fails. So basically, that can be used in cases where, say you have 2 completely disjoint set of elective requirements. By marking the first as disjoint manually, we don't actually need to go through all combinations of things in that set of electives, say like pull 3 courses from that because, well, they're not going to conflict anyway. And and we can also do things like mark a requirement as consume false to avoid having it consume its core courses. And then if you say need 9.0 credits, we can have an initial check that just sees if you have the 9.0, and then don't consume the courses and then pass that down. So it's these types of hand optimizations that you need to make to the programs. And so far we found that there hasn't been a program we haven't been able to hand optimize to run extremely efficiently. And then average single test passing runtime is about 10 milliseconds. Failing is about 50 to 70 milliseconds.
So with those optimizations, what kind of skill is needed to do that? Could you, for example, take a secretary in each of the departments in the university, and how much training would it take to allow them to produce program files for their department?
So it would take probably quite a bit of training, to be honest, but it's easy to come up with the initial program, and then you can, I think you can recognize certain patterns of things, but at its core, it does require some understanding of set manipulations and what requirements are supersets of another, and just a very high-level understanding of how our requirements are normally handled.
So if I could rephrase your answer there, Jack, you're saying it's relatively easy, maybe an administrator could create an accurate description of the plan, but optimizing it would require somebody with a CS kind of background.
Right. Or someone with more understanding of just set theory and that kind of stuff.
Yeah, but it's the optimization that requires sophisticated training.
Right.
The writing something that's a reasonable description of your plan is, you think, not that hard. Or like, can you edit a YAML file?
Correct.
Okay. So I mean, one of the creating those program files is the hard step. You know, in deploying something like this. We've got more than 3,000 plans at the University of Waterloo. You can't, the 5 of you are not going to develop all of those. So we've got to distribute that. And, you know, and my understanding is that the registrar's office had a 2-person-year effort to update that, and that was with input from the faculties. You know, so it was more than 2 persons. So somehow we've got to make sure that this is easy enough to distribute. So it sounds like maybe you could distribute the come up with the correct program description, and then come to a workshop where the 5 of you say, you know, ask the questions. Well, we can optimize that with this slide.
But we do find that most programs don't change sufficiently over the years that previous optimizations will still work. We just need to make the small tweaks.
I didn't understand why you were concerned with prerequisites.
So specifically, we wanted to work with prerequisites because of requirements like the CS chain of 3 prereqs. And that's the reason that we parse them out. But currently, we have a very restricted way of parsing them, where we only parse individual course requirements so that they can be satisfied by just one course. And we err on the side of just saying there are no valid prerequisites, so that we don't tell a user you have this chain of 3 when it's not actually valid. But it's primarily for the SES depth requirement, but it can also be used. Let's say in the future you want to take this tool and somehow convert it into generating program descriptions, then that's also something that can be done.
All right. This is awesome, and I would really love to continue here because I want to be part of this. But maybe you guys can go out to your booth with Prof. Becker and continue the conversation. Can you just say the URL again for Chantel?
It is degreecompass.uw.com.
Degreecompass.uw.com. Okay. And awesome. She's been watching from home. She's got a cold today. So thanks very much, guys. Good work.
This is Simon. He figured out the shotgun mic for the other room.
Oh, awesome. I figured it out last year, but I just can't remember the year. Should I go over for
Yeah. I'll just help those guys get set up.
You're Dan?
Yes.
I'm Eric.
Hi.
Great to meet you.
Nice to meet you.
Andrew's spoken very highly of you.
Oh, nice.
Thanks for all your help.
Yeah, sure. You are you're his SE equivalent.
Yes,
right?
Yeah. So Andrew, as you know, is a pastor at the software engineering, so I know you know he's taught these courses in software engineering.
Right. You can buy the food.
So it's exciting to have this joint effort.
Yep.
Yeah, so Dan was my TA last term, this term, and
Yeah.
he knows software engineering, which was really good.
Yeah.
Because I don't really, which is weird.
Okay, you're just going to open this. Just for a second there.
But I like our sprint model that we
Yeah.
It's good. All right. Excellent.
Okay, so just a second here, I'll read the thing.
Yeah, no, this was a fun class to do.
If I sit here and it's got one place to look.
The first sit closer isn't the others.
You're recording using OBS Studio.
All right.
Yes.
There's a gap at 12:30, so that's when we'll catch up.
What you could do is you could just plug this into the computer and have it as a audio input source to OBS Studio. And I think that would probably be
Okay, maybe that's what I've done in the past.
So yeah, because I don't think it's gonna. I don't think this signal is gonna pass through
Okay.
through the USB to the computer.
Okay, I'll fiddle with that then.
Yeah.
We got a break at 10:30.
And we don't have scheduled remote referees
For
for this. But anyhow, we
there is
could,
a remote at 10.
yeah.
Okay. Okay. Let's go.
Okay.
And I get to start?
Yeah.
So our project name is Type. We are part of CS494 now, and we're team number 2. So let me begin with our Let's begin with our team. Our team name is Green Joe. Myself, my name is Jay Park. I'm in my last year of computer science and business, and my partner Tim is currently working at setting up the booth outside. We are only 2. So our motivation. There are a lot of game platforms nowadays, but we believe the problem is they are really oligopoly, and the major platforms, they don't offer as easy as developer-friendly platform for developers. So the game market is already oversaturated. Developers are having a hard time to enter the market. So we began our user research. Last term, we asked these questions to game players online. And we found that players, they are trying to find simple yet very fun to play on browsers. And for developers, we asked these questions. And developers, they tend to have experience with developing a game, but many of them, over 80% of them, didn't publish their games because of the cumbersome process of publication. So this is our project solves problem. Our platform is for P2P games for both developers and players. So initial plan was that our mock-up, so we got inspired a lot by YouTube page. So you have all those games displayed on the homepage. And if you click a game, then you go to a game page where you can play the game on the left side, and you can even chat with your friends on the right hand. And if you go to your My Account page, just like YouTube, you have your games uploaded, and you can also add your games. And if you go to add games, you have these page to upload your games. You have HTML, CSS, JS, since our games are web-based. And this was our initial architecture. And for P2P communication, we were thinking about using WebRTC. And I'll deal with this problem later, more in depth. So during this term, we started to implement the features, and we met a lot of challenges, technical challenges. The first one comes from the architecture we initially designed. So our initial architecture is such that the server provides API and template for game developers, and then they develop their games based on the API and template we are given. But the problem is, once they upload HTML, CSS, JS file onto our server, our original plan was to merge all those files and compile on our server side, so that on our page, all those game files are living inside our server page. And there's a problem. Oh, not one, just there's 3 problems. So the first, there's cross-site scripting, name conflict, and complex file structure. So I'll start with the first problem, which is cross-site scripting. So cross-site scripting is basically when you have a server and you're allowing some other untrusted users to upload their JavaScript on our server, then any clients opening our page will run that malicious script on their web browser, and it can do anything. And that's what exactly happening on our server side, because game developers, they can just upload any malicious code. Like they can hack our client's browser information. So that was one problem. The second problem was the class ID name conflict. So HTML file and CS files, they do have those class names and ID names. ID should only exist once on a single page. But if we integrate game developers' HTML into our site and as well as their CSS rules, then there will be like conflicts with our class and ID names and theirs. So that was the second problem. The last problem was the complex file structure. Oftentimes games require a lot of files, and we don't know how developers structure their files. So if they have really complex file structures, it will be almost impossible to integrate into our compilation to determine how to compile them in our compilation time server. Because HTML works like including the files with the relative path names. So how we solved it? We use iframe. So iframe is basically a website living in another website. So you see the white background website is the main website, and you have an iframe with a gray background, which has a source to another link, and it's basically HTML itself. So we have two HTML files. But the problem was, so basically, this is our website, and our main site is running on Amazon EC2, which is main server, and we have an iframe which holds the game. We call it game box, and the game box has the game living inside. And all those games, we are storing them into the simple storage server on Amazon, which is basically a static server that holds all those HTML, CSS, and JavaScript files. And using the iframe, we can just link to the source of the S3 link. And you see we have two different addresses for them. And that was the second problem. So same origin policy and cross-origin resource sharing. So I'll start with this SOC. So this is for security reason, but for the web, you are only able to make a request to the same domain your browser is currently on. So for example, if you're on the example.com, then you can make a request to example.com/script.js, but you're not allowed to make a request to code.jquery.com because of the same origin policy issue. This is to prevent, to stop any bad servers injecting malicious data into your browser. And this was a problem for us because our EC2 and S3 obviously have different domain names, and we had to deal with it. But some people say, why don't you use CORS, which is relaxing the SOC policy with that. But the problem was so I'll start with explaining the CORS. If we enable CORS, then we are actually trusting S3 instance from our EC2. So we are letting anything happen between the S3 server and our EC2 server. But if that happens, so I'm going to talk about this later, but we are using WebSocket right now. But using the WebSocket from the S3 to EC2, you can do very creative things, and it can ruin our server very easily. So that was not our option. So how we solved it was using the post message that was available on HTML5 after 2015. So we built a class called Connection Manager that utilized this functionality and provide this connection manager for game developers so that the communication between the iframe and our main site is done through that connection manager. This way is more secure because we are actually controlling what data is transferred between the S3 and our EC2 instance. And developers there are only provided with certain APIs that cannot ruin our server. And lastly, our last problem was the WebRTC. So I said we were gonna use WebRTC for P2P communication before, but there was a problem. So let me start with the WebRTC. So WebRTC is very recent technology that enables you to communicate from peer to peer. What this means is that you don't need a server to communicate between two clients. And using this technology, a lot of cool things can happen, such as video streaming, data streaming between the clients without letting the server know what you're communicating. So even though there's a lot of benefits, we chose not to choose WebRTC because, so WebRTC, for that technology to happen, we needed two servers. So one is the stun server and the other is turn server. The stun server so every computer has their IP, but that's not the IP you see from the publicly outside. So in order to see your public IP, you need to request to this stun server and get your public IP. And that was easy. And a lot of companies these days, they offer stun servers for free. But the problem was with the turn server. So what turn server does, it allows clients to transfer their data through the firewalls. And it's basically relaying the video data or any data you're trying to transfer between two clients. But this relaying server is pretty expensive and not many companies offer these services right now. So we found out that there's not actually no server case. You actually need more servers than before. Also, we did our cost estimation and with assumption of each user plays 10 games a day. And we are very generous that they use 40 kilobytes per game. This is generous because like we are only allowing JavaScript games, which is not very intensive than those 3D video games. And as you can see, so let's see if we have 100,000 users. If we have 100,000 users, that's equal to about 40 gigabytes per day. But according to the AWS cost, that's only about $4 per day. So we decided not to focus on WebRTC. Instead, we did the WebSocket. So WebSocket is also pretty recent technology. It was implemented after HTML5. And WebSocket, after the handshake, you pretty much have a full pipeline between you and the server, which is bidirectional, fully duplex. And this is really adequate to our situation because games, they require frequent exchange of data between the client and the server, and this WebSocket with their continuous connection, it was perfect for our case. So the difference between HTTP request and WebSocket is that HTTP request, they have to open and close every request they make. But for WebSocket, after handshake, it's just continuous flow of stream until you close it out. So our final architecture overall looks like this. So in the middle, we have our Amazon EC2 server, which has which communicates with two different servers. One is the database server. They store the user data and game data. And we have the S3 instance, as we mentioned before, and they communicate through the iframe. And inside the S3, we store all those HTML, CSS, JS, and PNG for the thumbnail of the game. And between the players and the server, there's WebSocket. Alright, so let's see our final product. So this is our home page. So from the mockup, as you can see, it looks pretty much the same. We have all those games listed, and if you click the game, so we also have login page and registration page, which is really simple. And if you click the game, you're directed to this game page, which you have that iframe game box that holds the game and can basically pretty much play it. And on the bottom, there's a share link, which you can share the link to your friend. Oh, so I forgot to mention this, but on the URL, we use the hash code to differentiate between different rooms. So whenever you click a game page, then you are generated with the random 10 digits of hash code. So if you share the link, it will copy and paste, copy the link, and you can just send it to your friend. And whenever the friend open the page with the same hash code, you are basically now in the multiplayer page. And that's the dashboard page. It's the equivalent of the YouTube's My Account page, where you have all those games you uploaded before, and you can also add your game by clicking the new game. And this is upload page. So this is a bit different from the expectation. So we intended it to have the full compilation, real-time compilation page before. But due to time constraint, we just decided to upload the files, and yeah, there you go, you upload the file. So for better understanding, we have a video demo that shows our user experience. So you click a game, then you can basically play the game that the game developer has uploaded. And on the top, you can see the hash code that you can share. And let's think that browser is your friend browser. And as soon as you copy and paste the URL, you're now in the multiplayer mode. And all those communications are done through the library we provided called Connection Manager. And now we go back to homepage and sign in. So this shows like how our registration works, which is very simple. So we don't have an account yet, so we start making one. Alright, so we are now a new user. So I'm gonna try to upload new game. And click the new game. I put the title. Title should be unique. That's our unique ID for each game. And you upload your HTML, CSS, and JS files. And type your description. Also, that's the thumbnail image. So you upload it. Now there you have your game. So we go back to the home page. Now you see tic-tac-toe. And if you see the link, you see the link has tic-tac-toe, which is the title of the game. That's why we are emphasizing having a unique title, because we are using that title to make all those links between these two and as we have. Okay, so in terms of user feedback, we asked our friends to give some feedbacks. We have pros and cons. So for the good side, they said we have pretty much easy and simple games to play. And it was really easy to share with their friends to play with. And we asked a lot of CS friends, and as a developer, they said it was very motivational because of the low entrance into the game development. Also, they love the simple games. But on the other hand, they said there are too few games to play right now, so we need to work on expanding our platform. And also, there's some confusing API instructions. So using the connection manager, there was some confusion, so we were thinking about providing an instruction page for developers. And also lastly, sometimes our multiplayer game crashes, and this is due to we are not covering all those edge cases right now. Alright, so for the future, we were thinking about mainly two improvements. So real-time compilation, as I mentioned before. So instead of having upload page for uploading files, if we have those HTML, CSS, JS section, just like Fiddle or CodePen, then developers can easily debug and see their games on real time on the page. Also, on the other hand, we have WebRTC. We say WebRTC is pretty premature for implementing right now, but in the future, if the technology becomes more readily available and the servers become cheap, then we are thinking about implementing it, because you can do a lot of cool things like having a game screen set up with the video chatting set on the right side. And lastly, I'm going to talk about the lessons learned. So in terms of web technology, we learned tremendously. And my partner worked on mostly backend. He did all those server setup, DevOps on AWS, and file unloading from EC2 to S3. And I did all those protocols, like difference between WebSocket, HTTP, or even we thought about HTTP2, which is the most recent technology. And I had to deal with a lot of security workarounds between the iframe and S3, EC2. Like, it was really confusing at first, but now I think I have pretty strong understanding. And another lesson was that the project-wise, the time was very valuable. We kind of regret like we're not working like fully from the beginning. And the expectation was high, but the software requirements changed very frequently during the development. And I think 2 people is not enough for this kind of project. And that's it. Thank you for listening.
One question occurred to me. So a developer, like what kind of classes do you provide and what kind of services are you for? Do they get like a skeleton to start from? Or?
So our initial plan was to provide HTML template as well as like all the CSS templates and JS. But we are now using iframe, which means they can do whatever they want. It's like basically building a website for themselves, and we are hosting the website into our server. But we are giving them like specifications for dimensions, like width and height. And also we are providing a JavaScript class connection manager, which they can use to communicate between their game and our server.
How do you think you would? How do you think?
So you guys plug in, please.
Okay. Yeah. How do you think you would make money in the future?
So the number one thing I can think about is the advertisement. Posting like a lot of advertisement on our website. Like we have on the right side, we have pretty much blank page, so we can. That's one option. But also like if we have our developers upload a lot of games, then we can use that data to formulate some useful information in the future if we have collect like sufficient amount.
Alrighty.
I think that's good. I mean, we've talked to you a lot about your project. So.
Yeah. Yeah, a lot of content on the slide was like
yeah. Actually, that was a nice presentation. So, thank you.
What's next on your personal schedule? Do you have a gap after this?
Yeah, we have a gap after this.
Okay, so then I'll ask you to take questions out.
Sure.
Because we started late and we ran late with the first thing. Actually, I should check the room schedule for this room. Is there a thing in this room then? I just have the 1302 schedule here.
I must have screwed up.
Yeah, no, there's stuff in this room.
Yeah. Laptop just froze.
Oh, it froze.
Yeah, froze.
With the remote referee.
Yeah, we got it.
Okay.
Sorry there. Did you just give like a grade per section or?
Yeah.
Okay.
So, and then you can write your name in the box at the bottom.
Just a timeline.
Sure.
There have been cases where some referees have decided to not grade certain sections, say like, oh, I feel this is outside of my expertise, so I'm going to grade the sections that I, you know, yeah. And so you're welcome to fill it out as you see fit. You know, the educational value is in the interaction and in the feedback.
Yeah.
And I mean, you know, comments you might write on there.
Like I just want to go and like talk to him just like outside.
Yeah.
And really I just wanted to just encourage him to take it forward because it's a very, very difficult project that you will undertake. And as a result of being so difficult,
Pretty impressed with how much
they could find something that the students really love. Part of the
I think it's pretty cool.
which I see in like the
Which group are you thinking of right now?
Sorry?
Which group are you thinking of?
The Greek compass.
Yeah.
It's because of the fact like you guys are also grading on just like the amount of users. Their issue was not necessarily, it wasn't really like the quality of like users.
Yeah.
Because it went for a broad audience, almost to check this box of like a lot of users, but like most user feedback wasn't even valuable in itself. And so if it was security stuff, so like narrow down the compass down to just like a lot of demo for just computer science. Right. They would come up with some like really useful feedback in itself that they can use to iterate on. And then also telling them that like the potential for this, because so many students have like this pain point is like huge. Like they could really like sell this to like
that prof who was here, the other referee, he's been involved in these efforts on the faculty side for like a decade. And he's also excited. But yeah, so you don't have to follow the rubric blindly, right? You should, you're here, you know,
after HTML5.
we don't need somebody who doesn't know what's going on to like follow the words blindly, right? Like, what's the point of that? We want somebody to give their professional interpretation of, you know, well, you know, for example, if somebody does something in the medical domain, then those kind of numbers don't make any sense, right? So to, you know, interpret things, you know, reasonably in context, right? And that's why you're an expert when you're here.
Should I get mine? Should I fetch mine?
Both have, sure.
Yeah?
Is it close?
It's in the lab, which isn't close, but it's not far. It'll take me 3 minutes.
Mine's in the fishbowl. I'll grab it.
Okay.
Here, do you guys want to go to a different time? Is there a different time?
So at 10:30, there's a
there's a gap in this room at 10:30. No, there's a gap next door at 10:30. This room is booked, but next door at 10:30 has a gap. So why don't you do that? Because by the time we get that set up, we'll be 15 minutes behind, and at 10 o'clock in this room, we actually have a remote referee. So we'll do 10:30 next door.
And in the other room is like direct HDMI.
It's a more modern setup.
So it's a one opposite.
This is 1304, it's 1302, and we'll see you at 10:30. Actually, we'll see you at 10:20, right?
And that's free on your personal schedule? Is it?
I don't have anything else going on really.
Paper deadlines.
Paper deadline, that's all. Nothing important.
I just mean that I didn't slot you in for some other talk, right?
No.
I'm only doing the ones for this class.
Right, but still, there are 30 talks today and like 45 referees, so I don't remember everybody's personal schedule off the top of my head.
Good, all right, good.
I guess I'm gonna go make rounds then, because that makes me free until 10:30.
I've got awesome. Cool. So for the next 35 minutes or so. So it'll take me about that much time to set up. Let's find a location. We just rescheduled the talk because of technical issues. That's why I all of a sudden so at 10:30.
I'm so grateful we have like a little bit of slack in the day. Like we can bump those guys. There is a free half hour in the other room later. Like last year, there was no free gaps.
No, I think it's right helpful the fact that you guys have a gap in between, so that people can sort of like catch your breath and maybe get some good tea.
Okay. That's not going to work. is this? Oops, VG10.
Derek, do we give this to you, or do we just keep this until the end of the day?
You can give that to Shaz at the desk.
Okay.
Whenever you're done. Yeah.
Okay. Thanks.
Thanks. Just trying to figure out how to use the external microphone. It's not really working for me right now. I mean, this internal one's doing a better job than any internal microphone we've ever had, but it would be better to use that microphone.
You don't have an audio technician on campus?
Not one who's going to help us.
Okay, I'll look into that for like future, because I'm sure there are some film people there, or like a student that's savvy with audio that would be able to do this for next year.
Yeah, I figured it out in prior years, and I'm sure I can figure it out again. This is a different camera than I used before, but you know, it's supposed to be like in the manual for the camera. It's like if you plug it in, it will work. So claims the manual.
But even so, if they're willing to just come in almost for free as a student, then that puts a lot of stress off of you, and then you don't have to stress about it. Like every year they just come in and they do the whole thing.
Yeah, you know, I tried to hire one of the younger students. I said, I'll pay you money to come and help.
Yeah.
But nobody was motivated enough by money. Maybe I should have just said like, come and do it for love. Maybe I would have got somebody.
Maybe the students from computer science or software engineering?
The software engineering, the third-year students. So not the ones who are presenting today, because they have to focus on their own projects.
Now, probably a better bet is an entirely different program. I don't know if you have an audio or a phone program here at the university.
Yeah, there's probably another place that we could advertise. We just have to find out what that is.
Yeah, because whatever media program probably has some main audio. That would just say yeah, for sure.
Hey, Jason.
Morning. There's no Ethernet cord in here?
Pardon?
There's no Ethernet cord in here?
No.
Okay.
That's a thing we can maybe solve.
I mean, it would be nicer to, because I have to get an each over Skype, right?
Yeah.
But I don't trust the Wi-Fi in here.
Sure. That's a reasonable thing. That's why I have the stream plugged into.
There's no way. Does this sound okay? Sure.
Let's see. Yeah, good sound. Is there even
Is that down there's a phone? That's the top.
Okay, so we have to run it from the back, so we're reasonably long. So Ethernet cable is on the way. Who else is on our docket here? Simon.
Yes.
So hopefully Simon shows up here. So he's getting out of class. He said he could be here at 10, but I was skeptical of that claim. His class ends at 9:50. Let's see if Marcus gives us some indication that he's online.
We have another concern for you. The rubric that was posted for our team
Yeah.
is the free and open source rubric. Should have been research.
I definitely audited all of those macros before I printed the stuff this morning. But let's investigate.
Hey, Derek.
Yeah.
What does patches vapor mean?
There is no patch. But
see, that's why, yeah, that doesn't make sense.
they're vaporware, you know, it's a saying in software, vaporware. Yes, well, I hope that that's not an endemic issue.
We had Marcus just get somebody else's rubric for this movie. Like for reference.
Yeah, I'm really not too worried about that. You know, I'm here, can speak to the referees to solve the problem.
The ARPSLAM guys have research on that shit at least. And the environment and global mapping guys have consultant.
Yeah,
Okay.
they chose consultant.
Sure.
Which is not unreasonable because they're like building it for the team, right?
Yeah, no.
Oh no, you're. No, you selected incorrectly, Jason. You didn't uncomment the line of research rubric. You deleted all the other lines, but still left the research one commented. And so, if you don't select something, the FOSS one is the default. You effectively didn't select something.
Okay.
Like in your meta.tech. Aha, Ethernet cable. And that explains why, yeah, so he needs to plug in there and then another connector. So that explains why you escaped my audit, because you effectively had no selection. So I audited existing selections, but you had no selection, and I didn't cross-check that my list of teams was complete in that audit. Thank you, Simon. Greatly appreciated. So hopefully that works. Well, I'll recompile it and post it, and Marcus will get an updated one. Okay.
Hello, yes. We're just waiting for Simon here, and I think we should be good to go.
You got Marcus there?
You're on speaker now. Yeah, so I think that was an error on our part in our meta.txt, or yeah, we forgot to uncomment the.
Yeah. So Marcus, if you go download it again, it'll be the right one.
Yes, just tell Marcus to redo.
Oh, because Anish is also remote.
Yeah.
Right. So can they see the feed?
Marcus should be able to, yeah.
Well, Anish should be able to too.
Oh well, Anish is on Skype for Business here.
Oh, okay. So are Anish and Marcus co-located?
Yeah.
Yes, I'm. Hey Anish, do you know if Marcus can see the thing?
Yeah, you can see it.
Yeah? Okay, cool. Alright, so Simon's here now. Oh yeah, I guess you can see, at least when I watch it on my other laptop, there's a bit of a lag. So you'll probably be more real time on your Skype thing.
Yes, for sure.
Sorry, I didn't hear that quite right.
He said that there might be a lag between the feed and our Skype, but that should be fine. Okay, let's go. All right, good morning, and thank you everybody for joining us in person here in the audience and joining us via the live stream for our fourth year design project presentation. My name is Jason, and I have my partner Anish over by Skype.
Hello.
And we are presenting Team Autonomous Vision. We did road line detection for the autonomous vehicle team here at the University of Waterloo. So just a brief agenda of the topics we'll be discussing today. First, we'll give a background on the SAE Auto Drive Challenge, the challenge that Autonomous is participating in. We'll talk about the Autonomous implementation of the road line detection system that they had, which mainly consisted of traditional image processing techniques. Anish will talk about deep learning solutions that we used and constructed to improve the existing implementation, and we'll go into some more detail about the lane model architecture and the benefits of quantization that we implemented along with it. Then we'll discuss lane fitting with polynomial regression, and finally present a pipeline of our system, how it works from start to finish.
So I'll just mention to Simon while you're transitioning, the sheet has the wrong results rubric on it. It should be more of a research rubric. So, you know, are they solving novel problems? Is the way that your mind is thinking. So disregard
the research category.
Yeah.
Okay, got it.
Yeah. Thank you, Jason.
So a brief statement about the SAE Auto Drive Challenge. It's a 3-year competition where several different universities across North America are challenged to build a level 4 autonomous vehicle. General Motors has graciously donated each team a Chevrolet Bolt that doesn't feature any autonomous driving capabilities, and the school design teams are to build it from the ground up. The upcoming competition for year 2 will be held in Michigan, with urban driving scenarios as a recurring theme throughout the presentation. The Autonomous Student Design team here at the University of Waterloo is a team of over 100 students that have been working diligently in the competition, making our school proud and winning 4 awards in year 1. The autonomous implementation of the road lane detection system currently uses a traditional image processing technique, and this system is not very robust. It's looking for hard-coded patterns that are used to identify lane lines, often given perfect and correct conditions where exactly lane lines can be seen. And the solution isn't very robust in the regard that it doesn't work well in noisy situations. It doesn't work when there's heavy traffic, rain, snow, dust, or lane lines that can't clearly be seen or clearly painted on the road. All stemming from the fact that those patterns that we're looking for just don't exist. And that's why we figured it would be a great idea to improve upon it with our deep learning solution that Anish is going to carry on with.
Thanks, Jason. So as Jason mentioned, we decided to go with a machine learning approach to lane detection. And the reason why we wanted to do this is because generally in the field of computer vision, machine learning has consistently outperformed traditional image processing techniques that have a wide variety of areas of computer vision. So things like image classification, object detection, image segmentation. Deep learning is consistently outperforming traditional image processing processing. So we decided to go, sorry, so we decided to go with an open source pre-trained model called MobileNet to perform semantic segmentation. And so the way we train this model is by using a dataset called the Berkeley Deep Drive dataset, which has 70,000 trained images and 10,000 test images. And this dataset is really nice because it contains labels for both lane and stop lines, and as well, it's also very diverse in the sense that it has images from a wide variety of scenarios such as daytime, nighttime, rain, heavy traffic, etc. Next. So just to go over the architecture itself a little bit. So we use a encoder decoder architecture, which basically means that MobileNet acts as our encoder. And what it does is it takes the input image and converts it into a vector. And so after this vector is generated, the next step is to upsample it back to a segmentation heat map. And this is performed using transposed convolutional layers. And so once this heat map is generated, the final step is to use the softmax function to convert the heat map to a probability map, meaning that every pixel is labeled with a probability vector, giving the probabilities for each of the three classes it's predicting, where the three classes would be the none class, lane line, and stop. So in the bottom, you can see a quick diagram of just in general how these typical convolution encoder-decoder networks look, where you can see that we have an input RGB image that gets encoded down into a vector and then upsampled back up to our final segmentation. Next. So one thing that we decided to do during training was quantization, which means converting the model's 32-bit floating point number weights into 8-bit integers. And the reason why we wanted to do this is because we want the model to be able to run on an FPGA, since we don't have access to a GPU on the car, and this would be faster than running it on a CPU. So the FPGA actually requires a quantized model. And so one option we had was to just train the model like we normally do and then convert it to a quantized model after that. But we found that we actually get a reduction in accuracy that we didn't really find acceptable for that. So what we ended up doing was during training, we actually trained with quantization, meaning that although 32-bit floating point numbers are used to store the gradients during training, the weights are actually stored as 8 bits. And so this resulted in a very slight and negligible reduction in accuracy. Next. So this is just an example of one of the outputs of our model. So as you can see, the pixels labeled as green are the pixels that were labeled as lane lines. And so this is just a typical highway driving scene. And one cool thing about this is that just to kind of show you how we've been able to generalize, this is actually an image I got from Google Images, which just kind of shows that because we use such a diverse data set and because we did lots of image processing, we were able to get a model that works well in tons of different situations. Next. Again, here's another example, this time at nighttime. And again, taken from Google Images. Next. And here's an example with the stop lines, which are labeled in blue this time. And as you can see, the model still is not perfect. It hasn't fully segmented the other lane lines that are only slightly visible in this image. Next. And finally, here's an example with both a lane line and a stop line. Next. So we encountered a lot of challenges when trying to perform this task. Specifically, like I mentioned, we wanted to be able to handle all types of scenarios, like daytime, nighttime, rain, etc. And so, as I mentioned, this was partially tackled by using the Berkeley Deep Drive dataset, because it had so many kinds of images. But also, we did a lot of image pre-processing while training the model, which means that as we were sending images to the model to train on, we did things like randomly crop the image and randomly adjust the brightness and contrast, which allowed the model to generalize better. furthermore, no matter what training model you have, it's never going to be perfect, and so there's always going to be some noise in the output of the model that you have to handle. So, for example, it might occasionally label a very small number of pixels as like a little blob or a random target image as a lane line when it's not. And so we had to do some post-processing to account for these types of errors in the model. Finally, there's no bird's eye view images in our training set because we don't have the camera calibration, which means we can't convert images from the camera from a front view to a top-down bird's eye view. And why this affected us is because typically when you convert it to a bird's eye view, it makes the lane line a little bit more clear, especially as we go a little bit further out. And so what we ended up doing is that even though we trained in the front view, once the segmentation is generated from the model, at this point, we actually do have access to the camera's calibration because this is happening on the autonomous car, which we have calibration for. And so then we can convert the segmentation to a top-down view and then formally hitting on that top-down view segmentation. And finally, we also just have to wait several hours before knowing if training is working. That's just general nature of team training deep learning models. And so something as simple as like finding one small bug sometimes took a couple hours to realize existed in the first place. And then that just resulted in like several weeks of just experimenting with it in training pipelines.
Thanks, Anish. So once we get the once we get the output from the model, we have a segmented 3-channel color image. Red denoting the background, green denoting the lane lines, and blue denoting the stop lines. And once we have these segmentations, the next step is to fit lane lines into each of these segmentations. We need to generate a set of points for each road line on the image, and the color channels are important because we can use that to distinguish lane lines from stop lines. We do lane line fitting with a second-order polynomial regression, and stop line fitting with the first-order polynomial regression. The algorithm was first written in Python as a proof of concept. It worked great, although because Python is an interpreted language, it runs a bit slower than other compiled languages like C++, and the rest of the autonomous stack is in C++. So we just had to do a small conversion to get it integrated with the rest of their systems, and as well, they came with a small speed boost. So on the left here, we have an example of an image that's come out of the model. We have one lane line, and we have one stop line, and some noise on the stop line off to the right. First, we do processing on the green channel image. We find contours of each block of pixels. We do this block over here, and we do some processing of the image. Any small points that might be close to this lane line, we clump it together and consider it to be part of the same lane line. If we have any noise, which is not present in the green, but it is present in the stop line, we ignore it because it's not long enough to be part of its own distinct lane line. We fit a second-order polynomial to this lane line, and we do the same with the blue stop line, and we tag each as their respective lane line or stop line. The polynomial regression algorithm we use filters out noise, and we get a nice second-order polynomial for the lane line, first-order polynomial for the stop line, as seen on the image on the right. And here's another example. Here we have 4 lane lines. There are no stop lines in the image, but you see we get nice, clean, second-order polynomials that correspond to each of the lane lines that we have there. So this is just a small overview of the pipeline of our system and how it operates. First, we get an image from the camera that gets sent to the model, and we've been working with the FPGA team to get a model running on the FPGA, but as of right now, they're not quite ready. So the great thing about our model and our TensorFlow implementation is that it's pretty easy to run on the CPU, and the interface changeover to get it running on the FPGA is minimal. Just a few lines of code need to be changed. So once the FPGA team is ready to go, we just do a small handover, fix a few small lines of code, and then it's ready to run on the FPGA. After the model runs, it generates a segmentation map, which goes into a post-processing stage, and we remove any noise that the model might have predicted in that stage. The processed segmentation map then gets fitted to lane lines, and we generate a set of polynomials for each lane line and stop line. Then we convert the polynomials into a set of points in the image space in which we present our final set of lane lines. This information eventually gets wrapped in a ROS message, which gets broadcast to the rest of the system and eventually is consumed by a path planning module that determines exactly how the car should steer based on our output.
So, to summarize, basically we want to replace the autonomous implementation of roadblock detection because it was insufficient in non-protective situations like rain and heavy traffic. We decided to use deep learning, which resulted in a more generalizable system, meaning that it was able to handle a lot more types of situations. And while we were training this model, we used quantization to store the weight as 8 bits, which results in a faster inference time at a very small accuracy cost. Overall, this problem was fairly challenging. There was a lot of parts of the training pipeline that took a lot of experimentation, and there were different problems that arose that we just had to tackle as we went. But overall, we think that this solution is definitely a significant improvement over the current autonomous implementation. And so finally, after all the segmentation is done, we do some lane fitting with polynomial regression to generate our final.
We do lane fitting to get our final image here and our final set of lane lines that we send to the path planning team, and they determine where the car should steer. Thank you for listening to our presentation. We appreciate all of our viewers here in the audience and those joining us by the live stream, and we'll now take questions. When Skype fails, you have to go to Messenger. Yeah. All right. Yeah, so I just finished off the presentation. I said that now we'll take questions.
Yes.
I can't hear a word he said.
Yeah, so Simon or David, do you guys have questions?
Yes.
So.
Did you consider any architectures other than MobileNet?
Did we consider any architectures other than MobileNet?
Yes.
Yes, we did. Although, given the idea of running it on FPGA and running it with the least amount of overhead possible, we figured MobileNet was the best choice. And I think we should expand on that.
Sorry, could you repeat the question?
He said, did we consider any other models other than MobileNet?
Yeah. So there's actually.
We can't hear what you're saying. You can speak louder.
Yeah, so there's a, can you hear me now?
Ish.
No, we can't.
My computer
Okay, we'll come back to that when we have a better connection with Anish. But that is a great question.
I have a lot of questions for Anish too.
Yeah, well, I mean.
Can we talk more about the post-processing?
Can we discuss more about the post-processing?
Okay, do you want to talk about it?
Like the lane segmentation or the post-processing that comes out of the model?
So after it comes up in the model, so it's always been like mentioned in the slides, but we haven't really talked more about what is actually being done.
Yeah, with respect to the model.
So I guess everything before the polyfit happens and after the model outputs the segmentation.
Right. If we can get a better connection, that would be ideal.
No. Yeah, we can't really hear you, Anish. Can Marcus hear us?
Jason, could you maybe try just Hangouts calling?
Sure.
Yeah. Can Marcus hear us? Do we know that?
We can just try Hangouts calling his phone, is what I meant.
Yeah. So what I would like to get in Marcus's report, and I'm hoping he can hear this, but if not, I'll send him mail, So in the research rubric, right, it distinguishes between, you know, how many cases can it handle, you know, can it handle challenging cases, how novel is it compared to the state of the art. And so I would like Marcus in his comments to provide some justification for his choice based on his expertise in this area.
Yeah, I think that you justify like the choice of model just based on like state-of-the-art models that currently exist.
So is Anish back?
Yeah, we have Anish back on Skype now.
Great.
Yeah, I think it's like actually, yeah.
Yeah, so the mobile net model is a great option for, it's sort of made to this type of work. The requirements being that it runs on FPGA. So given that it has a fast response time, sense of this sort of context, obviously there's some sort of higher models in terms of that run a lot deeper, but that take a lot longer and require GPU use. Some examples might be sort of Inception and some of the other state-of-the-art stuff from Google, but for the purposes of running on an FPGA, that makes a lot of sense.
Yeah, let's go ahead,
Yeah. To answer the previous question before we got out there. So there are actually different teams on this working on pretty much the same problem, and each team has kind of been assigned to work with, like a different model architecture to work with. So some are using the really deep tech that Google implementation. The reason why we chose MobileNet, kind of like Mark was saying, is because of our hardware restraints that we have, and we've been working closely with the FPGA team on this project, and they are specifically the FPGA system so that it can only work with MobileNet. So it's not just some like general system on the FPGA that can work with any model. It's very, very specific to this model architecture.
Yeah, so there are kind of, I guess, two questions that I'd like in Marcus's comments for him to report on. So one is what you've been discussing, the selection of MobileNet. And the other thing that I would like Marcus to report on, and we'll have to wrap up here for the next talk in a second, but the rubric speaks to, you know, the range of cases that your solution can handle, right? And so in your talk, you said, well, the previous solution couldn't cope with all kinds of adverse situations, and your new solution copes with a much wider range of adverse situations, right? And so I would just like Marcus to contextualize your accomplishments within the industry. So we buy your claim that your current solution is better than the previous student solution, and Marcus, as an industry expert, can contextualize your accomplishments in that setting.
I feel like I can vouch definitely that they've done something great here. Like the previous solution, I mean, I know because I wrote it up in 2 nights. So I definitely know that this is a lot better because I looked at it. What I guess I really wanted to see was like some form of like quantified metric about that. So what I think, I don't know if you guys have it, but some kind of reported accuracy metric over the Berkeley set, since you've trained on it. I don't know if for SegNets you still use like precision recall for these kind of models. But if you had some kind of like, metric like that would say like, oh, we basically handle, like X percentage of all the cases that are possible in this data set, then I think that would like take this presentation to the next level.
Yeah, and so if we're gonna have to wrap this up in this room, but if you can provide that data to Simon over the next few days, he can incorporate that. Well, Simon and Marcus and David, they can incorporate that in their feedback. Yeah, but yeah, great work, guys. Really great technical depth.
Okay.
Okay,
All right,
cool.
thanks very much.
We'll touch base later. Thank you.
Okay.
All right, Tim Hive, you want to sit up? Awesome.
I'm going to go outside and see the presentation.
Yeah. Thanks, Simon.
I guess I'm doing
environment visualization as well.
Yeah. Can I just leave my stuff in here?
Yeah.
It's awesome.
I wonder how you zoom this camera. That's what I'd like to know.
Well, I don't know much about cameras.
Yeah, a lot of times there's like a zoom thing that I'm not finding. This is a different camera than I've used before.
That's pretty much what they say every time. I am actually in favor of quite a bit more transparency. The only thing I don't like about this channel is just it doesn't look like doctors and folks like that. Like I think people who are on the should still be specific those videos.
And like, there's like,
Do we start right now?
Yes.
Okay. Give just me a second to get my pen on if you want. Alright. I have it. There it is.
So we're standing here today presenting our fourth year design project, but it wasn't too long ago that we were first year students. I remember between stressing out about exams and generally worrying about whether or not I'll be employed at the end of all of it. First year has been a pretty stressful experience, and this is still the case. For many students, they report feelings of stress and isolation coming into university for the very first time. For many, they come from across the country and even abroad. The friends and family that they interacted with on a daily basis are now no longer as reachable. Due to the coursework at university and the general challenges, students have reported difficulty in meeting new people, especially outside of their own programs. Due to the co-op system, we generally see students uproot their social support networks every 4 months, and as a result, they'll develop imposter syndrome and general forms of anxiety. So mentorship is a plausible solution to some of the issues that these students face. So research shows that there's a greater sense of student community once there's mentorship initiatives in place. According to MIT and the University of Florida, there is an improved satisfaction and engagement for students once they partake in mentorship initiatives. On one hand, mentees are able to develop greater satisfaction and confidence in their abilities. And from a mentor's perspective, they're able to have a fulfilling experience teaching those that are coming through the same experiences that they experienced themselves. So the great thing about mentorship is that it's already everywhere. There are undergrad and alumni associations at other institutions that match students with professionals in their specific fields. In addition, we see companies like 10,000 Coffee that are establishing mentorship programs within corporate environments. In Waterloo, we have mentorship initiatives. In the co-op system, we have a mandate that every co-op employer has a mentor for their co-op hires. In addition, we see student programs like NSHOC and WIGS. So working with these programs, we found that there's a few ways that they can improve. First and foremost, that we see students report a poor match quality. So generally, students are matched with students in other programs other than their own, and as a result, aren't able to get that quality feedback that they were requesting. And so we see generally forms of low user retention. These mentorship relationships rarely last past the term that they're formed. And these programs also have a lack of insights. They're unable to see how their mentorships are formed and how much benefit their students are getting. As a result, they're unable to improve term after term. So these programs also take a lot of resources to run. So here's a case study of the NSHOC mentorship program. It not only requires a whole team of people, but it costs almost 100 hours and upwards of $2,000 to run. So we really feel there's an opportunity for a software solution here. So introducing Hive. Hive is the platform to power peer mentorship at the University of Waterloo. We feel that a mobile-first solution is critical here since most students are using their smartphones for their social needs nowadays. By having an iOS and Android application, we're able to cater to the student body here at the University of Waterloo and connect the community. So there's about 1,000 different ways we could have gone about building the platform, and what helped for us was coming up with a framework to decide on what features to build. So the first pillar that we have is discoverability. So this is the idea of having students connected to opportunities and people on campus that they otherwise would not have the opportunity to. Next is the engagement piece. So this is having students be more involved in their students' community. So this includes things from mentorship activities to also hearing more about initiatives that they otherwise have not heard about. And finally, we have an education piece. So this is highlighting educational resources on how to make the most of your connections here at Waterloo and of your experience here. So one of the core features of our product is that of mentorship. So these are created upon signing up. For many of our users, this is someone in their program that has been through their very same experience. So through having this long-term connection with someone in the program, they're able to have a lot of their questions answered, as well as have someone to rely on for advice. So next we have connections. So these are the short-term, on-demand connections based on interests and specific experiences. So through the search capabilities of our platform, we're able to connect users in the community that they otherwise would not be able to meet. So this is for instances, let's say, if you want to learn more about what it's like to go on exchange, you can search through our platform and search for someone who's been through that experience. And next we have surveys. So this is the critical data collection tool that we have on our platform. It's what allows us to power a lot of the experiences, including the mentorship matches. So by collecting data on our users, we're able to not only provide a better experience, but highlight it to the communities that they're part of. The mentorship programs that are onboarded on the platform can use these metrics to improve their programs for the future. And finally, we have notifications. This is how we plan on engaging our users. So by giving our users a call to action based on events around them or opportunities that they might be interested in, we're really able to make the most out of their experience here. By also giving them educational content about how to make the most of their mentorship relationships, we can really teach our users about best practices.
So I'm going to explain a bit about how Hive works behind the scenes. But first, a bit of a history lesson. So originally, Hive gave the power to the program administrators to create the matches because we believed that they had the domain knowledge to create more effective matches. We did a lot of user research, talked to users, and found that the matches that were being created were not very effective. Mentees had very little in common with the mentors, and in a lot of cases, the matches seemed almost random. People weren't even in the same program, and this resulted in mentors not being able to answer their mentees' questions effectively. We investigated this issue a little bit further, and we found that administrators either didn't have the data that they needed to match effectively, or it just wasn't a tractable problem for them to consider all this data when doing matches. So this is where we come to play as a software solution. We control the entire process from data collection to matching, and this lets us create more effective data-driven matches. We have an in-app onboarding flow that Steve had mentioned, and this sort of lets us collect the data that we use to make these matching decisions. So we can collect program, gender, positions where someone's worked, and most importantly, personality-based surveys. So we performed a lot of research on literature trying to quantify personalities, and we found that the Big 5 indicator test was a pretty good way to sort of design these surveys. Now, when we're actually performing matching, the technical aspect is it's a weighted cosine similarity score, and the weighting is sort of things that we define through this declarative framework that we've created. So we can specify which attributes and which pieces of data we think is the most important thing to take into account for this match. So for example, you might have a female mentee, and we did a lot of research and found that these female mentees really benefited from having a strong female mentor. So we can weight the gender component more strongly in this matching. The actual algorithm was stable marriage, so we ensured that everybody got a match at the end of the day, and that the match that somebody got was the best match for them. Our actual application's infrastructure looks sort of like this. So this is our mobile client. We did it using React Native, and this let us target both Android and iOS simultaneously. The architecture is a model view controller, and this interface with our backend services. Our backend is a little bit more complicated. So clients' requests come in to a load balancer, which performs an SSL termination, and then that proxies requests to our web application that houses core business logic, and that's really rolling. All this is housed within Amazon's infrastructure in AWS. So we use Amazon S3 for static asset storage, so profile pictures. We use Amazon's relational database service, which is a layer on top of MySQL, to actually store core application data. And we use Elasticsearch to power the search functionality of our application. We use Docker to sort of ensure that we have a consistent environment between dev and production and to prevent bugs in that respect. We faced a lot of technical challenges along the way, but the three ones we want to highlight are large-scale workloads, security, and limiting regression. So we had some workloads where we interface with external services that weren't necessarily reliable all the time, and they were flaky. And a lot of these things were sending up, or they sort of materialized when we had very large workloads that actually happened. So for example, we wanted to match all users and then send notifications to these people using an API that wasn't reliable. So we developed an in-house job scheduling framework that sits on top of cron and that integrates with our data infrastructure so that we can sort of schedule these jobs and have them run at off-peak times and times that sort of retry in case stuff ever failed. Security was a core focus at Hive because we're dealing with user data here and personality data, which we didn't really want leaking. So we employed best practices wherever possible. We used whatever features existed in the frameworks that we used to ensure that we had sanitization queries and that people couldn't inject malicious code into our service. And we also employed things like defense in depth and the principle of least privilege. So we ensured that all the services within our infrastructure could only communicate to the other services that we wanted to allow. Finally, we wanted to limit regression because any bugs in our application would turn users off of the platform. So there wasn't a really good solution to this because we use a Golang for the server. So we needed to develop our own in-house integration testing framework. And this let us integrate with our data infrastructure and create end-to-end tests that stressed core functionality of the application. And this let us deploy with confidence and knowing that we weren't going to regress and break features that would hurt users in the long run. In terms of productivity, at the end of the day, we had almost over 45,000 lines of code. And we found there were a few reasons why we were able to be so productive. Every single feature we created design specifications. So this let our entire team work together and iterate on design and sort of have this implicit documentation where we would say design decisions and why we had it. We also had weekly meetings. So our team was actually on co-op never located in the same time zone. And this made meeting up pretty hard. But by sort of like forcing a time to always meet up, we were able to make sure that nobody was blocked on anything and we could resolve issues to move the team forward. Finally, when we had critical features being launched to the public, we had war rooms. So everybody would be on call at the same time, and we'd be able to resolve issues effectively and efficiently as quickly as possible. So we first launched in spring of 2018 to a limited alpha test within SE. We moved on in fall 2018 to a wider launch, partnering with engineering mentorship and SESoc. The most recent term, we partnered with SESoc once again, and we actually launched a club day where we exercised the attribute-based functionality that we previously demoed. And going forward, we're planning on helping build out more administrative tooling so that people can use this platform with less interaction from our team. The biggest takeaway from our user growth is that these initiatives that we partner with and these organizations were key to our user growth. Essentially, if we didn't have these organizations that have these champions, it'd be much harder to find valuable users who are quality and who actually want to take part in this platform. And we're pretty proud of our results. So we had over 600 users join the platform, and we created over 700 connections between these users. Over 250 of these connections were organic, so people actually used the app to find other people who they wanted to connect with. We surveyed the most recent batch of people running through the SE version of this matching, and 94% of people surveyed who responded met up in person, which was great because this is much higher engagement than the other social media. And furthermore, in the data, we found that people met up for very long periods of time. On average, the meeting between a mentor and a mentee was 2 hours in length. So people were enjoying the matches that were being created, and they were gaining insights that were valuable to them. And users love their platform, as I said. So mentors were able to sort of share their knowledge with their mentees, and they felt they were giving back to the community and helping these mentees sort of avoid the mistakes that they had made in the past. Mentees were getting great advice, and they were helping, this was helping further their own careers because they were now getting these new insights that could help them steer their career directions and education directions. And finally, the programs that we partnered with, the administrators, they were able to get metrics that helped guide their program in the future, and they gave them new insights to help develop more effective programs. We're pretty proud of the impact we've had.
So having worked on this project over the last year, we came away with some key takeaways that we'd like to share. So in terms of product lessons learned, we figured that it was really important to get some version of your product out in front of users as fast as possible. So for us, the first time we launched out to our alpha users, we already had a big chunk of the platform built out. And to be honest, if we were to redo it, we would probably take a less technical solution just to be able to get that feedback early on to drive those product discussions. What we could have done is probably just use some spreadsheets and some scripts to automate some email workflow to allow these mentorship initiatives to already start taking place. In terms of user interviews, we felt that those were critical for us to understand how users interacted with our platform. Some features that we thought were really discoverable was in fact not as well discoverable as we thought. Some wording on our platform was causing confusion with our users, which allowed for poor UX experiences. And then we also experimented a lot with user acquisition. So from trying out handing out business cards to setting up booths on club day, we tried a wide variety of ways to get users, but what worked best for us was partnering with these existing mentorship programs. By working with a group of users that was already committed to the idea of mentorship, really helped them align their goals with ours and help make these programs run more efficiently. And finally, we'd like to basically say to use as many tech shortcuts as possible. So we'd like to say to never reinvent the wheel if you can. And for us, that meant using libraries and frameworks that helped us save development time. So for us, using Xcode was really helpful, especially for the updates and notifications portion. So if we had gone through the regular update route of going through the Apple and iOS and Android stores, it would have taken a lot of time for our updates to have been released to our users. And this way we could iterate on our product a lot faster. So we'd like to also give thanks to the mentorship initiatives that we've worked with so far, especially engineering mentorship, that helped us figure out the early product decisions. By giving that early feedback, we were able to change our product so that these mentors and mentees were able to make the most out of their experience. And we'd like to give a shout out to the Student Success Office as well for connecting us with a lot of these mentorship initiatives. So overall, mentorship seems like a promising solution to a lot of the issues that students face today. For us, the platform, Hive, was able to improve and facilitate mentorship initiatives on campus. And so far, the feedback has been overwhelmingly positive. So the key takeaway here is that for many of these mentorship programs, we feel that we're able to give a really great experience for our users, and we hope to continue doing so while starting new initiatives. So, thank you. So we'll take a question.
Do you have a question?
Not at the moment.
So I have a few. This is neat. I do like it a lot. So when I ask questions, it sounds like I don't. That's not actually the case. How much do you think this actually saves out of the $2,000, which actually isn't that much money, but that you described at the beginning of the presentation? Do you think that it completely ameliorates all of the work that human beings are doing, or
right? We're not planning on eliminating all the costs entirely. We feel that through providing a platform such as ours, we're able to run their programs more effectively. So by taking on a lot of the logistics overhead, which comprises a large majority of the cost for these programs, they're able to focus their efforts on more meaningful, impactful events. So by creating better experiences for the users. Yeah, good.
And not only that, but like by having sort of lower overhead to actually launch the program, like these faculties will be more likely inclined to actually launch and finish the program of their own, because we sort of handle a lot of the administration stuff for them.
So in some sense, what you're really offering is sort of a one-stop shop for new people who might want to use this. Or for new groups that might want to go in this direction.
Right, it definitely helps starting up new mentorship initiatives, but for the existing ones, they can benefit from this as well. From, like we mentioned, the mentorship matches that we make are much more effective, and we feel is a better quality than the ones that they have to make manually.
Do you have data that supports the claim that they're more effective?
Well, I mean, like the biggest like signal we had in that respect was the fact that these mentorship meetups had lasted very long periods of time. So people were enjoying the relationships, and it wasn't like they didn't have anything to talk about when they met up with these people.
Okay, that's legit. I'll take that.
And you also presented data claiming, well, not data, but you made qualitative claims that the previous matches, people reported that their mentors weren't able to answer their questions and things like that. So do you have a quantitative flavor of that that you could speak to?
So we did user interviews for the engineering mentorship program that we had helped run in fall 2018. We talked to, I think, everybody on our team talked to 5 different users, randomly sampled, that actually, we found that they just weren't, like that was the general consensus of the feedback we were getting. People just weren't able to get sort of the insights they wanted out of the relationship.
Yeah, so we also garnered feedback through our platform, and the responses that we got so far was like for all the poor quality matches, the main concern was that they were unable to answer the questions.
Okay. And then if I can ask my other question on this is, it feels like you used much more heavy tech than I would have expected for an app that doesn't need, that only has a couple hundred users in the club. Like you even have a load balancer. Why did you do that, and was that the right idea in retrospect?
So I think initially a lot of it was due to familiarity with technology. Right. So for doing SSL termination, our library used in Golang didn't essentially have that feature. I mean, you had to run Nginx. And we didn't really know how to gauge demand and where this project was going. So we could design this web service so that we could scale it up behind that load balancer in case we ever needed to scale up for like future demand.
Okay.
All right. I like the way that you have like surveys. I don't know a lot of surveys, so I think surveys are great. You report a 94% meetup number, but what's the response rate on that? Like, you know, if the 5 people who, of the 20 people who responded to the survey, 19 said yes, and then the other 400 people who you sent out the survey didn't answer.
Yeah, so this is mainly done on the software engineering cohort that we ran the mentorship program with this term. And so from the about 180 users that we had on our platform this term, we got responses from 30.
So launching early is great, and this is something that we always tell people, hey, you gotta launch early, right? And so you did. How do we tell other people to launch early in a way that they'll listen to us?
We should launch even earlier. Yeah, so I mean, I guess one of the motivations behind launching early is you sort of need to see your app being used by people to stay motivated on the project. In a lot of cases, people launch at the very end, and I feel like once they got traction, they were like more motivated to work on the project. It's kind of hard to tell people that, once you get users, you really want to work on this more, but you sort of need to sort of embed it in your heads.
Yeah, especially for all these like consumer-facing products, just getting some version out there that can prove the MVP or like the basic gist of the product that you're trying to experiment with is valuable to put in front of users.
I think people are afraid of like launching something that isn't super polished, and they feel like they need like the perfect product, but the perfect product isn't as listed. You should launch way before you think you're ready.
Yeah, and I think one of the most interesting things that I saw was like how often we would make the wrong decisions about features that we thought were like super critical and very valuable that people really didn't care about, and ended up we would just like kill. Yeah, I think we definitely could have saved engineering effort if we went even more low tech at the beginning, so we could get like more feedback earlier to sort of drive our decision-making process.
I just want to clarify a point at this point. So one of the things we didn't really compromise on from the beginning was security, because we're dealing with data here that is somewhat sensitive, and we didn't want to have like any overarching like clear vulnerabilities in our product, like SQL injection, for example, because early on in the process we actually had users try to do that to us, and we're glad that we have mitigation in place.
Right.
Yeah.
But Bobby Tables is a lower year software student.
It's really good to have friends who will try to consider it for something.
So I had an idea there, though, actually, to speak to Patrick's question. How can we get students to launch earlier and stuff? And maybe we can perhaps use Hive to create more targeted capstone mentorship relationships between students who have just completed 4A and students who are in 3B, right? So we don't have, so we get that cohort, you're in 4B, we get you to give feedback to the students who've completed 3A, but maybe we can back that up and have, in time, like move it back 6 months to September and create mentorship relationships so that when you're in 390, then you can talk about project ideas with people who are already gone through 4A. And they can say, wow, I really wish that we had deployed already.
wish we sort of had it. So actually, we talked with the UW's little people when we were in the Bay Area, and we sort of got a lot of insights into how they launched the product, and that's sort of what guided us along the way.
I have also a couple of questions. First of all, I really like the idea of I think the fact that you see a lot of solutions for it means that this is like a well-known problem. And as you mentioned, also the match quality is also a problem for a lot of these solutions. So people don't get matched well. So one of the things, maybe not at this stage of your project, but if you're thinking about scaling your project to more users, would be how much you're going to balance between privacy and the match quality, because you need more data from the users to be able to match them better with other users, but at the same time, that sort of compromises a little bit your privacy. And also, I think at one point we were talking about the data that you're using for your matching algorithms, and I thought that you were using, I don't know if this is correct or not, so correct me if I'm wrong, you're using some of that data that you collected from the users to improve your algorithm. So you were giving an example about the gender. So if you see a lot of matching based on the gender, then you see that, okay, maybe we should increase the weights for that gender, which again brings up that privacy issue. So I don't know if you guys have thought about it or thinking about it. I know you have like 500, 600 users, and it might not be an issue right now, but
yeah, so a lot of the decisions as to the weightings and matching algorithm, those were derived from literature. We didn't look at matches to say, hey, these matches worked out better. Let's try to change the weighting based on that. It wasn't like a machine learning algorithm. It was us sort of reading literature and trying to find existing precedents for what good matches already sort of can be made based on information.
We definitely would have needed a lot more data to do that in any effective, to train a model or anything.
So just to give some context to that, so when we were back in 4A, we spent a lot of time talking about, these very precise matches based on very sensitive information. And so Reza here works with the Student Success Office, but he has also served as a mentor for younger year software engineering students. I have matched him on very precise criteria with very specific individuals. So some of those cases that I discussed with you anonymously, Reza was a mentor that I matched personally. So he has lived experience on that issue and also working with the Student Success Office. So I'd encourage you to interact with him more, to explore those possibilities, now a year later where you are now, and see if there are possibilities there.
You come to your poster and we'll talk there.
All right. All right, thanks very much.
Why is it that anytime
always
I'm sorry? Well, so the current stuff, a lot of it is actually in the library. They renovated all of the furniture that's been furniture in the library. Yeah. So annoying.
Yes, that's exactly right. That's the other thing. Is you never got it.
Maybe I should get this.
So we're just waiting for Simon, and you guys invited, is it George Stoppy? Guy, sorry. I just had G Stoppy on my list. Yeah. Have you seen him? No. Okay. Hey, Simon.
Simon, do you know if Guy's coming? Guy.
I don't know if Guy's here.
Okay, well, we still have a minute while they plug in, so we'll see how that shakes out. I'm just going to run to the fishbowl and expand my set of sheets. Okay. Alrighty. Shall we more or less start?
Okay. Yeah. Hello, I'm Michael. And we're Team Slam Dunk. And for our fourth year design project, we worked with Autonomous to improve feature detection in this one open source algorithm called Orb Slam. And we did that using image segmentation. So there's a lot of terminology, so let's just break things down for you. So our presentation is going to go like this. First, we're going to talk about what SLAM is, why it's fundamental to autonomous vehicles, and then we're going to talk about the SLAM research space, which is active area of research, what kinds of algorithms exist out there, what differentiates one algorithm from another, and we're going to focus on one particular algorithm called Orb Slam. That's the algorithm we work with, and we're going to talk about fast corner detection. And after that, we're going to talk about how semantic image segmentation, how we used it to improve feature detection in FAST. So, and of course, afterwards, we're going to give you some results, before and after pictures, how this ended up playing out. And we're going to reflect on some of the challenges we faced during our FYDP journey. So it's worth, before we even talk about SLAM, before we even define it, it's good to make this one analogy where if you ever played this game called orienteering, it's basically where you're dropped in some kind of environment, you have a map and a compass, and you have to make your way around that environment. Now, basically, you have to basically localize yourself. That's what you have to do, because you don't have like a cursor that tells you where you are. All you have is a map and a compass. Now, this is essentially what SLAM is, but SLAM also involves generating the map on the fly. So usually with orienteering games, as a Boy Scout or whatever, you have a map. But in simultaneous localization and mapping, which is this problem that autonomous vehicles have to solve, it involves generating a map on the fly as you cruise through that environment, while also localizing your position within that environment. So the output, as you can probably tell, of a SLAM system, it consists of position and orientation and velocity of the vehicle, as well as a map of the environment. And when is this useful? Well, it's useful for path planning, navigation. It's kind of crucial to have this system in place. And do you need it? You need it if you don't have a map beforehand. So in orienteering, if you have a map, then you probably don't need a SLAM approach. You can rely on odometry and stuff like that. But in most practical cases with autonomous vehicles, you need a SLAM system. It's worth, before we get into the technical aspects of this, it's worth highlighting where all this falls within an autonomous vehicle pipeline. So localization, mapping, that happens right before the path planning step, as we talked about before. And how is this actually implemented? Well, localization fuses sensor data, from your LiDARs, radars, tactile sensors, with the images taken by the camera that are on the vehicle. And by applying computer vision and identifying objects, you can then build a map of your environment and figure out where you are in that environment. Now, at a high level, there's a lot of stuff going on in a typical SLAM system. There's a front end and a back end. We're most interested in the front end because that deals with this thing called feature extraction. Now features, they're basically an abstraction of objects in an image. And we track features across frames taken by the camera. And by that, we're able to localize the vehicle within the map. So this is basically feature extraction, deals with taking that image data and identifying what we call features. Features are defined as corners, images, regions. It kind of depends on the algorithm, how technically you're identifying a corner, what you're looking at within the image. Fast, for instance, as we'll get to in a second, it looks at light intensity differences around particular points. And yeah, so feature extraction, you're taking the image, raw image, and transforming it into a set of features that you then track across the frames to build objects and a visualization of your environment. So here are just some examples of what features exist. Edges, on a cup, it's kind of what a human would define as an edge, like the rim of the cup. Corners, like on this building, you define the corner as like the tip. And regions are somewhat of an outline or a blob, where the stuff within it has some kind of semantic cohesion.
Yeah, so what's the current state of the SLAM right now? So SLAM has been researched for many years, and many algorithms have been developed, both proprietary and open source. But since the advent of newer sensors and camera, the performance requirements are currently still changing. So as a result, it's still being newer and newer algorithms are still being developed. Although the original SLAM solution problem is considered as solved, but there are still some few open problems. For example, like handling dynamic scenes or loop closure. But overall, we see that no SLAM solution is perfect. Some are optimized for higher frame rate, others are optimized for localization, and some are just better for some certain environments. So right now, these are some of the popular SLAM solutions that exist. There is FastSLAM, LSD SLAM, GraphSLAM, SPTAM, RTab Map, and OrbSLAM. The algorithm that we worked on in this project was OrbSLAM. So there are essentially two dimensions in which we can distinguish a SLAM solution. One is stereo versus binocular. That is, how many cameras does the SLAM solution uses. If the SLAM solution uses 2 cameras, then the algorithm is stereo. If the algorithm uses 1 camera, then it's binocular. The benefit of using multiple cameras is that we can get a depth perception. So as a result, in case of binocular SLAM solution, it is very difficult to estimate the scale of the received map. So as a result, if you want to get a depth perception in binocular SLAM solutions, the algorithm is generally much more complex. Another dimension is the algorithm feature-based or direct. By feature-based, we mean that we process the image to find corners in the image, And by direct we mean that we compare the entire images and to find out which parts go together.
Okay, so let's talk about the solution we're actually interested in, the orb slam. These are just some characteristics of orb slam. It's open source, which is really important to our project since we want to modify it. Among the dimensions that Harpal just mentioned, it would be feature-based and monocular. We chose this algorithm because there have been studies that show that it's effectively real-time, and that it processes frames at the rate in which your sensor gives you frames. And it performs really well compared to the other algorithms, like some of the ones listed on that slide. And it works really well, with some caveats, as in there's no flat monochrome objects, and certain caveats that we didn't think were necessary to consider in our solution. So at a high level, this is the architecture taken directly from the paper. And what I really want to focus here is these three large boxes that are tracking, local mapping, and loop closing. Those are considered threads in this paper. And really, our contribution lies in this red circle. It's the map points. So we can see all three of these threads rely on this face recognition and these map points. And our focus for the remainder of this talk will be this map points component. Okay, so what is orb? What does the orb mean? I think we were just asked this. Orb stands for oriented fast and rotated brief. Fast is a key point detection algorithm, and we'll get into the details of this algorithm in a few slides. Brief is a binary representation format for points, and I think it supports like very fast querying to see if a certain point's in the setup points, or very fast computation of distance between 2 points represented in brief. And not mentioned in the title, a key part of this algorithm is the Harris algorithm, and that is used to sort of filter points that fast outputs to identify the top end that we're interested in. All right, let's delve into corner detection. But before we do that, we should define what a corner is, which could be tricky. As Michael alluded to, the FAST algorithm defines a corner as a pixel where the surrounding pixels, 16 of them, exhibit a large light intensity difference. So if you want to look at this sample image, look at pixel 15 and look at pixel 7. We'll see there'll be a threshold that a program will define, and we'll see that this light intensity difference exceeds that threshold. So this is a corner. So how does this really work? There are 2 passes. One is the slow pass, the slow version. And we go through, for each pixel, we go through the 16 pixels in the corners, and we look at the thresholds and see, is this a corner by this definition of a corner? This is highly inefficient because for every pixel, we have to consider 16 other pixels. Fast gets its name for being fast, and it trains a decision tree to really bring down this set of 16 pixels into a more representative subset. It goes pixel by pixel and looks at builds a decision tree based on the information gained from the 16 pixels surrounding it, and which pixels of these 16 pixels provide the most information, is the technical term, to discriminate between corners and non-corners. So the output of this is a decision tree, and you could plug this, like you can plug a new image into this tree and proceed to find corners. So why fast? Well, it performs as good, not better than the alternatives like SIFT and SIRF, which are 2 common image detection algorithms, and it's also open source, which is a big thing for us. So before we proceed further to image segmentation, as we alluded to, we should, we're not experts in ORB or this research at all. Why did we pursue this? The experts have said, like Katina, this quote directly from a survey in the field, the idea is that if we can recognize objects or other elements in a map, then we can use our prior knowledge about their geometry to improve the estimation of that map. So this is important to us, and this stands out to us because the SAE Auto Drop Challenge has a fixed course that we know ahead of time. So we have prior knowledge of what we're going to encounter, and we thought this would be a very interesting approach and really beneficial to autonomous.
So the task led us to semantic image segmentation. So what semantic image segmentation means is that we predict a label for each pixel with that is defined from a class of labels that we have in our representing objects. So for segmenting the image, we use a residual neural network. The benefit of using segmentation is that we can significantly reduce noise in the image. So here we see that this is a normal image taken in, and this is a segmented part of that image. So as we see, there is a bunch of light intensity difference on the road. But in segmented image, we see that because that always is just a noise in the image. So as a result, the segmented part of the image, all the road is just presented as once. So as a result, we take out the noise of the image. So the solution that we use is trained on SECapstone dataset, which essentially performs a pixel-wise real-time image segmentation. And to segment the image, we use something known as cascading classifiers, which basically means that we first train the neural network on thousands of positive image, where we get the features for the first image, and then we use those features for when we segment the next image, and then again those features are again cascaded when we train it on the next image, and hence those features get cascaded again and again. So right now we are just using the existing model by Oles and Rico that we just retrain on some more data points, but we can still fine tune the existing model further for the use of autonomous. The reason for using the existing model was since the original dataset is pretty huge, so we don't want to run the same computation again. And plus, if we run the same computation, if we run it on a smaller dataset, we run the risk of overfitting the data. So as a result, we found it best to use the existing model. So overall, our project fits into this map point component. Now, if we zoom into this map points component, so we get the input image. Now the input image gets passed into the map points component. Now the map point component first segments the image. Now, then the segmented image goes to the orb extractor, which essentially extracts the feature out of this image. Then the orb matcher matches this feature, and finally we get the output of the mapper back. So some of the technologies that we use in this project were OpenCV, Keras, TensorFlow, and C++.
Okay, cool. So how did we do? How did we even check how we did? One, we ran the fast algorithm on the unsegmented image, so prior to our work, and then we ran on segmented counterpart, so after the image segmentation that Arnold just described. And we found a rough order of magnitude that 30% of the false positives were removed. Let's define what a positive would mean in this term. We looked at a human labeling, eyeball, less technically. And let me justify why this is a good approach. As we saw in the description of FAST, the way that they describe real corners is through a slow algorithm, which is also just a heuristic around pixel image surrounding points for light intensities. So we thought human labeling would be as good, if not better, than that heuristic. So yeah, and we also found that there was improvement for noise images, with fragmentation and grainy quality. So let's look at a sample image. This is so on the left-hand side is the first run without our image segmentation. The green dots are corners. I guess most notably, you'll see there's a lot of green dots on the road because the fast algorithm picked up light intensity differences in surrounding pixels. This doesn't exist on the right-hand side of the image because the image segmentation semantically thought of the entire road as one component. Yeah, those are the routes.
So now let's talk about.
Let's talk about what the cost of this is. Is this the perfect solution? Of course not. So we improved the accuracy of key point detection, but the cost of performance. The performance cost comes from having each image go through this neural network. And one of the small subtleties is the neural net is trained by pixel. Each pixel starts the input as a node for each pixel, and it's trained for one size. So if you have an image that's double the size of what it's trained by, you'll need to cut your image in half or however many parts, run through this network and stitch it back together to get the segmentation. So yeah, that really dampens the orb slam's big sell for being real time, because we found it's taking about a minute per image. So one way to, like in the future work, I guess we can look at adding more system resources, perhaps doing these things in parallel, because as I said, stitching images and cutting up images makes more sense to do in parallel. They're not dependent on each other. Another thing that we should consider is we needed, of course, specific data sets. This is fine for AutoDrive, I think, because the data sets would be small and tractable. But like if you want to extend this further, we can see a great cost to going around the track and trying to look at every possible image that we can encounter. And from a software engineering perspective, we've greatly increased the complexity of our system by adding this deep learning module.
And we'd be remiss if we didn't talk about what kind of challenges we faced during our FYDP journey. There are various technical and non-technical challenges. I think one of the biggest ones was when we first started this project, we had to first identify a problem where we could even make a contribution. And because we had no prior experience with autonomous vehicles, with SLAM, it was really hard to, first of all, understand how all of this works. We presented with a lot of dense technical literature, a lot of terminology that we weren't familiar with. And the way we went about this was, instead of going through very lengthy papers, which we kind of did in the beginning, we dedicated some time to that, we instead focused more on more superficial blogs, literature reviews. We also communicated with people in autonomous that helped guide us to read the right stuff that would be easy to digest and help us guide us on a potential project. Another big non-technical challenge was lack of requirements. It was kind of an open-ended research problem. Again, like where exactly should we make an improvement? And in that sense, SLAM system is very complex. Feature extraction is one big part of it. So we were interested in that, and that kind of helped us narrow down our scope. We also looked at current research trends to investigate, how are problems being solved in other domains and whether we could apply similar strategies in a SLAM system. Image processing, neural networks, they're ubiquitous, so that kind of helped us. And a pretty major technical challenge during this project has been understanding the OrbSLAM code. The great thing about it is it's open source, but at the same time, it's not very well documented, and it's complex on top of it all. So as a result, we spent a lot of time analyzing the code, experimenting, running it, and just playing around, pretty much. So that wraps up our presentation. In summary, we defined for you what simultaneous localization and mapping is, why it's fundamental and important for autonomous vehicles. We went through a couple of SLAM algorithms, explained how they're implemented, what distinguishes one from the other. We'll talk about OrbSLAM in particular, because that's the system that we worked with. We'll talk about fast corner detection. That's the very specific algorithm that we modified. And how do we modify it? Well, we modified it with image segmentation to more accurately identify key points / corners. And we present you with some results, before and after pictures on how our modified algorithm performed. And here's just not a very accurate use of the Peter Parker algorithm, but it's kind of the same thing that we had before, where without image segmentation, you have very inaccurate corner detection. But after you apply image segmentation, i.e. put on your glasses, it's a little more accurate. Again, that's not the right way to use this meme, but there's the only way we can visualize it. So, and finally, we wrapped up with some challenges that we faced along the way. So that's it for our presentation, and thank you for listening. Yeah, thank you. And we got some references too.
So I was wondering if you. So I like what's been done here. A lot of, but it does seem like because you're reusing a lot of things, you're subject to a lot of the failures from the existing parts that you're using. So the corner algorithm was one of them. You replaced it. The ResNet is another. And also, could you go back to the slide where we had the ResNet results side by side? I noticed something where it seems like there's some green dots that are in the first one that are not in the second. That might be useful in the second. So the parts of the trees, for example, some other parts with the lane lines because the segment, the segmentation didn't return those. So I was wondering, because of the trees, it makes me think that you have some kind of post-processing applied here. Have you guys, I guess, was the image segmentation the only thing that was added in? Was there any post-processing that you omitted or
No, there's a blur and grayscale, but that was done on this image as well. There's no. Yeah.
Okay, and they're both using the same corner detection output? Yeah. Okay. Yeah, don't worry about that one.
Yeah,
I was also wondering if you had like because you guys told me like back in booth that we had some metrics to like track improvement of the corner detection, right? I forgot those numbers again, but they were
30% of reduction in false positives.
Like roughly like on the CityScape data set, I'm guessing.
Yeah, no, well, not on the CityScape data set, but on
our test set.
Yeah, our test set.
Okay.
Yeah, the CityScape data set we use to train.
So I figured that might not translate into you guys improved orb slam by 30%. Would you have some more metrics relating to kind of like how this translates back to orb slam's performance increase?
Yeah, so our metrics were mainly limited to fast corner detection in particular, as opposed to the whole orb slam system. Yeah, again, we didn't really dive into that because it's kind of that's a whole other, I think, component that would be pretty intensive.
So your project, with the title and everything, is really focused on SLAM, but you didn't show us too many results about the localization and mapping itself. So can you, like, based on what Simon was saying, you guys build off from that a little more? Like, maybe you just didn't have a chance to show us the presentation because we're limited on time, but good job in image segmentation, but what's the value of SLAM? What's the impact of what's passing down the line?
Again, we didn't run too many tests. We didn't really execute the SLAM pipeline and run our tests for this entire SLAM pipeline. Again, we just focused on this fast corner. It is misleading, I agree, that we do present the problem as a SLAM, where we worked on a SLAM, but even though we worked on fast corner detection in particular. But yeah, unfortunately, we don't have those numbers for that.
So, okay, with that being said, so then we're trying to look at this more as like a processing type problem?
Yeah, it is more of an image processing.
Okay, so then let's pretend that we're not passing this off to a SLAM algorithm then. We're completely ignore the orb SLAM and everything else. Mm-hmm. Is the performance improvements that you guys are getting, is it helpful for other things on the pipeline, or is it just, we're trying to optimize this one thing?
Yeah, it is mainly optimizing object detection. I think that's pretty much the extent to which we're making a contribution.
How do you estimate this to work beyond, I guess, some of the parts that you reused from the platform? So for this part, I guess it would be mostly relevant to the ResNet. So how do you see this, I guess, because you're kind of like taking an existing ResNet and we're making, of course, the assumption that whatever is open source must be somewhat good. But I guess, what would happen to your algorithm if the performance of the SegNet was, let's say, like lower than what you desire, or like higher than what you desire with some kind of test set?
We didn't have really thresholds, and we like our constraints for the project were kind of loose. I mean, that was kind of what made it like easy. Anything to add?
We could look at, like, I didn't investigate this, obviously, but we could look at like augmenting the points we get originally from FAST with the points we get from the image segmentation. So in the sense, we have like two, like a backup sort of. So I meant we have like two sets of points. That makes sense?
Yeah.
Okay.
Great. All right, thanks very much, guys.
Thank you.
So David and Simon and Eugene are in here for the next talk, but they might circle back with you at your booth to continue the conversation.
Okay, sounds good.
Thanks. And of course, you're welcome to stay and watch if you want. So that's USB-C adapter that's plugged in there now. He's on. Oh, thank you. Perfect timing. Appreciate it.
That's what you were looking for, right?
Yeah. I'll, here, let me, there's 2 copies here, so. I'm just wondering if I can find. Where the middle point is.
Hey everyone. So,
Okay, just a sec. All right.
So, we're Team 7. We worked on a data visualization as a simulator for Autonomous, and I'm sure you guys know what Autonomous is our school's student-led autonomous vehicle team competing for a challenge. And we specifically we partnered with them for improving their developer workflow through adding through adding a 3D data visualizer, as well as adding a lot of features to the simulator used complying with Year 2 requirements.
Okay, so let's start off with the visualizer. The visualizer is a tool we built for Autonomous that takes internal car data, combines it, and provides you with a real-time visualization of the data as it changes. And this tool was geared towards Autonomous's software teams in order for them to see and test their code and see how that code will affect the behavior of the car in general. So these software teams are split into their path planning team, which takes environment data, processes it, and generates like a path for the car to follow. And for them, we're visualizing the cost map they generate, which is that tile 4 in the picture right there, and the path that's planned, which is that line of green arrows in front of the car there. And this is also meant for the perception team, which takes in external data and generates the environment object that's being passed to the path planner. And for them, we're visualizing the road lines and the obstacles, which are those like green cubes on the picture there. This visualizer is also very useful for the vehicle testers who need to understand what's actually going on inside the head of the car in order to make sense of like what's happening in the track. And what we also worked on was Autonomous's simulator tool. So this was a tool that was already implemented before we joined the team, but as of Year 2, it's fallen out of use. It's a tool that allows you to draw out scenarios and see how the path planner actually plans out a path within that scenario. It's of great significance to path planning, since it enables testing outside of an actual physical vehicle. And recently it's become of great importance to cost map because they're working on a new cost map implementation for path planning. And it allows these developers to confirm the generation and behavior of the cost map without relying on hard-coded tests or in-vehicle testing. So Autonomous's code base and our code is based on the ROS framework, which is a framework geared towards developing robotic software. From a high level, ROS enables development of robotics software as a collection of logical units called nodes. And these nodes communicate with each other through a pub subtopic, which means ROS code is very modular. The visualizer in particular uses a package called RViz, which enables nodes to not only communicate with each other, but also generate graphics based on messages that are coming in. So why do we need a visualizer? To see what's going on inside the car's head. The car's algorithms are generally very visual in nature, such as cost maps and planned paths. And this data needs to be superimposed in order to understand the car's behavior. This is especially useful for vehicle testing because, as I said before, in order to understand what's going on in real life, you have to understand what's going on with the data inside the car. Although we have a simulator, although we already have a simulator to visualize things, the simulator is a bad fit for the purpose of a visualizer because it's not a ROS module, meaning it would be hard to extend simulator functionality to perception code. It's also 2D, which isn't fit for year 2. So our solution was to implement our visualizer in our viz. Our viz enables us to have a node that can subscribe to any topic within Autonomous's code, and then react to any messages in this topic by generating a graphic appropriate to that message. So because we can listen to any topic within the code base, it enables easy integration and extension of the existing Autonomous code, as well as, in general, just real-time superimposed rendering of the data. We also worked on the simulator. We picked it up in year 2 because it was not ready to help path planning meet its year 2 objectives. It was unable to model signs and obstacles that came with these year 2 objectives. It lacked a lot of quality of life features like actually pausing simulation and saving and loading of situations in the simulation. And the most troubling thing of all was that since path planning was working on a new cost map implementation, the old simulator would not have worked with this new cost map implementation, which means it would have become useless for anyone working with this new cost map code. So, work on the simulator was necessary for its readoption, and in order for the path planning team to reduce its reliance on hard-coded tests, printouts, and in-vehicle testing.
Okay, so given that motivation, we had to analyze what features we actually wanted to work on and what the visualizer actually needed. So what we decided was the most important things for the visualizer was primarily we wanted to show the obstacles and lane lines, since that was the most important thing for the reception teams to actually see. So there was stop lines and LiDAR data, because those are all the inputs into the path planning or insights into the path planning team, so that they would need in car testing to see sort of what's actually going on. And the other thing is just showing the planned path is super important for debugging, since that's probably the most important data for what you actually want the car to, or how you think the car is going to behave. And then the other thing is just we had to take in ROS messages, and this is really actually a little bit harder than it first sounds, since the definition of ROS messages is subject to change over time because of what different teams actually change especially between year 1 and year 2. What data is contained on certain ROS messages also change. So sort of being adaptable and coding in a way to actually anticipate changes was really important here. So the other thing is what we considered important for criteria was just having the visualizer be fairly real time and fairly smooth. It was really important. Having it being laggy or not slow, I guess, would probably make it fairly useless. The other thing is just ease of use deployment, because when internal tools are hard to use, people just stop using it. So we figured that one of the biggest things is making it easy to use for people. And the third thing is just because we know that so much is changing between year 1 and year 2, making the code flexible and adaptable is really important, because otherwise it's similar to other modules, it falls out of favor because people don't know how to use it or find it too difficult to work with. So making it easily adaptable was super important in how we designed it.
So let's take a look now at how our visualizer is organized. This interaction diagram shows both the external factors that are inputs to our module as well as the outputs. So on the left side, we have signals coming in all at different rates streaming across these ROS topics from modules such as perception, path planning, and LiDAR, as mentioned before. So these signals are all put into input buffers as part of our visualizer. And because they're all coming in at different rates and we have like a target rate that we want to send output out, we keep these in a buffer, and periodically we take a snapshot of the latest data we've received. So with this snapshot, we perform some optimizations. We'll talk a little bit more about them later, but it'll be things like removing redundant data and collapsing data that can be collapsed. And we transform this optimized data into a set of graphics primitives. These graphics primitives are then loaded into the output buffers, and once all of them are ready for a given frame, we then send them over to RViz, again through ROS topics. RViz then handles the rendering of these and displays them on the output.
Yeah, so big thing was for the implementation is we took in ROS bags, and ROS bags are sort of like the collected archive data from previous tests, and worked on basically creating command line tools to easily replay ROS bags and actually stream ROS data in place of actual ROS messages coming in from the car test stuff, because we weren't able to actually become the part of the actual in-car tests. So basically a big focus was making it easy to build. So that was focusing a lot on good CMake tooling, and also launch and config files for people to easily be able to actually deploy, and also just putting stuff on GitLab and Fabricator and Google Drive and Discord for all the documentation things. Because again, the big thing was just clarity, and keeping the rest of the team in the loop was one of the biggest priorities for us. So the other thing that we worked on was the simulator, and the big thing here for us was sort of firstly features to match year 2 spec, and secondly fixing a lot of the deprecated things that were around for that fallen out of use between year 1 and year 2. So for the year 2 spec, a lot of what we worked on was signs, because that was a big part of what changed between years 1 and 2. So we essentially defined a lot of signs and a lot of communication around what's implementation for stop signs, speed limits, left and right turn only, and do not enter signs. And then we also introduced some utility functions, such as being able to pause the simulation and saving and loading map to custom locations. And then we also integrated the cost map, or the new cost map stuff, and did some fixing of some poorly maintained code around the simulator also. Okay, so yeah, so it's one of the big things was the cost map integration. We go with, I think largely going from the cost map being printed out in just pure data form, and going through that workflow seems like a nightmare. So being able to visualize it and see what that cost map looks like superimposed over other data is pretty valuable, I think, to the teams to figure out what that data looks like and how, if it actually looks correct or not.
So let's take a bit of a deeper dive into the visualizer and some of the technical problems we encountered and how we solved them. So a big kind of thing that we were always thinking of in the back of our minds while building this visualizer was, how do we ensure that it is performant? One of the things we had to grapple with was concurrency. As I mentioned, we have a lot of different data sources that are all streaming in, and we need to process those in near real time as they arrive. So being able to kind of manage these buffers in a multi-threaded environment and ensuring that things like locking and resource acquisition were done in a correct way was one of the challenges that we had to ensure that we were addressing. One of the biggest bottlenecks for getting a near real-time performance is the network latency, because all of these ROS modules, they could be hosted on the same machine or they could be hosted on different ones which are networked together. So we devised a few strategies to address this. The first one was pipelining. So as you saw, we had input and output buffers as part of our module. And the big reason for these is because we wanted to send as few messages as possible over the network to reduce the total network latency we would encounter. So with this pipelining stage, essentially we have data that is being processed that corresponds to different points in time, and it's being processed simultaneously. So at any point there's data arriving that's being buffered, and there's data leaving that is being kind of constructed and put together and packaged. And so this helps us ensure that we reduce the network trips, since we're kind of taking all that data at once and sending it over. And it also helps us reduce some of the graphical artifacts that could occur if we were to send over data slowly, such as stuttering or tearing of the image. Another optimization we worked towards was reducing the size of the messages we sent as much as possible. So one of the techniques we used was delta encoding. What this means is that instead of sending the actual full data snapshot at any period in time, what we do is we save the previous snapshot, we diff the current data against that previous snapshot, and we only send the differences. So for things that have not changed that much, the amount of data we send is greatly reduced. We also define just the threshold on our data in order to be able to kind of drop values that have not significantly changed. So for example, if something has changed by 0.1 of a centimeter, there's no point in sending that data off to RViz, because when it's rendered, it's going to look exactly the same. So we essentially tell RViz that nothing has changed. In terms of other challenges that we encountered, one of the big ones again was balancing readability and organization with optimization. So it's one thing to have an extremely efficient module, but if that module is unreadable and unmodifiable for others and not well written, then people will eventually stop using it because they can't make changes that they need. So we were always consulting kind of back and forth, especially as we got to near the merging effort as to how we could structure our code best so that new members would be able to easily make the changes that they needed. And last big challenge for working on the visualizer was learning about ROS and kind of all the different quirks and specific design patterns that would have to go into creating a performant and easily read module. On the simulator side, so the simulator is based on a library called Glut, and this is a very old library which is a wrapper for OpenGL and C++. We encountered some problems trying to work with this. One of them was that we have multi-threaded use cases for the simulator. So for example, we want to be able to continue interacting with it while it's actually displaying and computing the simulation. And so these were not easy to implement, and we had to kind of rely on workarounds just because we couldn't access the actual threading model of the library. So one example is usage of control flags, where we essentially have to wait for, instead of being able to signal another thread that's doing work, we have to wait for it to kind of loop around and check its own message queue to see if anything has happened. Another issue that we encountered was a lack of UI-related features. So for example, we couldn't even render strings natively just with this Glut library. At this point, we just decided to migrate to a more modern library instead, so we switched it over to free Glut, which does have string rendering features, but unfortunately still relies on that single-threaded model. So backing up even more, one of the things that was difficult for us was kind of making sure that our timeline was highly aligned with autonomous. One of the big challenges was that the year 2 requirements just weren't released by the time we were starting. As a matter of fact, they weren't released until mid-June 2018, at which point we'd already kind of gone along with speculated work that needed to be done. And we also ran into problems coming back this term in 4B because autonomous, with the way that co-op is structured, we have different members rolling on every term and different members rolling off. And so we found that the leadership had lost a lot of context on their own progress. And so communication was a little bit difficult at first because everyone was trying to kind of grasp again what had been done, what hadn't been done, what was priority, what was needed, what was not as much priority. Another issue we encountered was a lack of usable test data. So going back to the raw specs, originally when we started out with them, they were actually already out of date. They couldn't be run until they were migrated in order to kind of catch up to the new message definition formats. And we encountered that issue again coming back this term in order to work on things where we once again had to figure out what had changed in the message definitions and then migrate them over. And so some engineering effort was spent just trying to like generate things we didn't have or trying to make the data that had broken usable again.
So after all of this, the visualizer is now fully integrated into the autonomous repository. And during all of these changes, like we took feedback from different members who will be using the software and also made the changes accordingly throughout our process. And LiDAR, adding LiDAR signal, which was not initially part of our requirements, like that was like an example of something that was like we got from feedback. So now, even though due to integration, the team itself is not at the integration stage yet, so the schedule is a bit behind, but we do have it is still like a part of the autonomous debugging workflow with a lot of documentation on how to use it. In terms of the simulator, it was kind of abandoned until the new requirements came for year 2, and so now there are teams, as Sean mentioned, the cost map team especially is using the simulator again, and it has helped them uncover like various issues and help them debug. And now we're also several steps closer towards the feature parity for year 2, which includes signs, traffic movement, signals, etc. Yeah. So, any questions?
So during the delta encoding stage, is it possible for the diffs to become corrupt? Because if you're using a chain of diffs, the error could propagate to the remainder of the snapshots.
That's true. So I guess the way that we do it, we don't actually store the diffs in the sense that we don't compute diffs based on previous diffs. We have the actual like absolute values, and we compute the diff, and then we save the next set of absolute values. So the error is constrained between 2 frames at a time.
So one thing one of my supervisors always told me was the simulator is always wrong until you can prove that it's right. So how did you guys prove that your simulator was accurately in like showing proper movements, proper how do we know that that's reasonable? What tests do you guys do?
We sort of worked off the assumption that the previous visualizer was already correctly integrated with the rest of the autonomous code. It used to be used, right?
You mean
simulator? Sorry, yeah, simulator.
Other big thing was that for the path planning team that actually uses it, like I think that one of the big things that like it directly uses their code to like actually take what's being tested on. So like I think so our responsibility largely was about data integrity and making sure that the data that they inputted was actually correct, and that's a lot easier to task than figuring out like whether certain algorithms are being correctly run.
No, that's fine. I get that. I mean, how do you test your stuff? That's one thing.
I can actually provide more context on the simulator. It's called a simulator for this, but it's not really used as like a simulation of the entire platform. We actually more so use it for like almost like unit testing of the path planning module. So just parts of like everything from the second we get an environment to formulating a cost map with the environment to planning a path in it is like deterministic. So the simulator, the way that we use it in path planning is mostly to like test out these parts. But then everything after that, where you have to translate the path into the torque and no commands, that's something that can't be tested. That's not being tested in the simulator, and that probably can't be tested.
Yeah, that's fine. So thank you for please just tell me how you guys tested yourself. This is basically what I'm trying to do.
mostly manual testing. It's very like UI graphics based. You can't really have like an automated test for that. Mostly making use of like old, sorry, this simulator. Okay, so, sorry, I was thinking about Visualizer.
Yeah, the Visualizer is a bit easier to be like, oh,
like we already have raw specs for that. We just make sure that matches up with this the scenario in the raw spec. For Visualizer, it's mostly just testing out features, drawing lines and stuff, and making sure the cost map that's being visualized sort of like aligns and makes sense with whatever's being drawn.
I think for the simulator, we're kind of like at the end of the pipeline where like, you know, we're getting like all the like at the end of the pipeline, we're like ingestible data again, so the fact that the results, the implications of our contributions were graphical can be like, it had to be manually tested because we can automatically like kind of like, you know, pick pixels and pick distances.
Thanks.
On the other hand, we did try and automate the manual part as much as possible. So for example, there's a slide that kind of showed the infrastructure for, like, especially for Visualizer. We did make sure that it's testable in just like a one line, like there's a script that has all the initializations and all the test data that's required, and you just run a one line command in order to actually step through everything.
Can give more. I guess I could just give more so like comments or questions. Like we use like simulator pretty like a lot more now around pathfinding. It's like part of like the regular, I guess, ad hoc kind of like unit testing. Just like there's like a few ad hoc tests we always do, like oh sure code compiles, and then run a few look like unit tests directly, but also like, you know, try out the simulator and like visually get confirmation that it's somewhat working. It's helped us recently debug an issue with the cost map that we probably had since year one, where there was like a bit of an offset issue, but that was really obvious with the simulator rather than like manually inspecting matrices of numbers between 0 and 128.
I think someone else also brought up an issue with like a real thing. Yeah. That was discovered because we could see things working on this.
Out of curiosity, have you guys I know you guys did a lot of like optimizations for like for network optimization on the visualizer. I was wondering if you like kept, you know, track of some form of like metrics to, you know, like indicate, I guess, how much was the improvement done.
So the best metric we kept was just like our feel for it. We didn't directly attempt to measure like numerical latency or anything like that, but we did see a visual improvement going from, like we essentially did all our optimization at once. So we built everything out, we were like, okay, we have this in a working state, and this is how fast it looks. And
definitely saw the stuff.
Yeah, so we went through the optimizations essentially until we hit the point where we're like, okay, this is like a relatively smooth playback.
And demos that I would put for you guys. Look at it. How smooth the visualizer is.
All right, thanks very much. Okay, so Team Sana. You can give them to Shaw and Fishbowl. She's got the thing to sort them. Thanks so much for coming out, Eugene. We appreciate that.
I enjoyed more stuff outside.
Pardon?
I really enjoyed them for software ones.
Oh, thanks. Well, it's your input is very valuable. Yeah.
Go back outside and see the booths.
Yeah.
So I'm back for the global mapping thing, but that's not for a couple hours. Should I just keep my clipboard and all that?
Yeah. Are you done, or do you have, or you're coming back to global mapping?
Yeah, I'm coming back to global mapping.
Okay.
And then I'm going to the booths.
Yeah. Awesome. So yeah, lunch is there now. Yeah.
Got it.
Hey, YouTube link. Our remote direction needs.
Yeah, I emailed it to everybody.
Okay.
Including your list. I guess Patrick didn't moderate it through.
It didn't come to any students.
Oh, really? Okay, yeah.
Okay, so he should have it and the marking sheet?
Yeah.
Okay.
Yeah. You can check with them.
Yeah, we'll check.
Yeah. It got held on the 2019 list for moderation for having too many participants. Patrick's usually pretty fast at moderating that.
Okay.
Yeah.
So Andrew Morton asked me if I would do this. I said yes. You said great, Eric will.
Oh, I guess we failed to assign you work.
So you don't need me?
Yeah, we can survive.
Okay, I mean, I did say I would do it, but that's fine.
Yeah, if you would like to fill out forms, I have forms that you could choose and fill out, or you could attend to other matters.
Okay, well, maybe I'll attend to other matters then.
Yeah.
Okay, just wanted to be sure.
Yeah.
All right, no problem.
Thanks, Mike. Okay, Eric is online. I'm chatting with him, and maybe I should have told Mike to stay here for your talk so you have more people in the room. Okay. All right, well, I don't know. I guess we can start. I can push the start button.
So we're Team Tana. For our FIB project, we develop medical protocols in Kubernetes. So we're today here with Michael, Felix, and myself, Justin. So a little bit of background with Sana. Sana is a cross-disciplinary organization including professionals from different fields, like clinicians, engineers, volunteers ourselves, students working on open source development. So we'll talk about, so Sana's leadership. So these two, Ken and Eric, guiding us throughout the project. And shout out to Ken and Eric. So what does Sana do? So we're going to talk about three systems that are relevant to our design project. So the first one is the Sana medical data system. It is a centralized system to store patient data. And it interacts with two components, Sana Mobile and Protocol. Sana Mobile is an Android application used by remote health workers to collect patient data through protocols. And these protocols are coming from Protocol Builder. The Protocol Builder is a web-based application to build and construct questionnaires that is based in that are XML based. And this diagram shows the previous versions of how it worked. So we have a Sana Mobile on the left, uploading the data to the medical data store, and clinicians are directly on the medical data stores working on it, put the results, and that gets sent back to the Sana Mobile. And Michael's going to discuss the terminology, protocols, and procedures.
Yes, so really at the core of Sana Mobile is this concept of a protocol/procedure. Now these terms are used interchangeably, but they refer to the same thing, which is the underlying control of these questionnaires. They define things such as the questions that are asked, the expected answer format, such as whether we're expecting a multiple choice answer or a date as an answer, and also conditional flows. So for instance, if a patient reports certain diagnoses, we might want to dig further into that, and whereas if they don't, we might want to choose a different flow to go down. And here we have stored a sample protocol. So these are stored as XML files, which are somewhat difficult to read, though you can sort of make out what this is about. So here we have a question asking, has the patient fainted before? And if they answer yes, then we ask, what's the last time they fainted? But as mentioned, these are pretty difficult to work with just as raw XML files. However, a previous FIDP group developed a system called the Protocol Builder, which provides a more intuitive GUI for working and visualizing these types of protocols. So here's how the main workbench of the Protocol Builder looks like. So this is that protocol we just dealt with opened here in the Protocol Builder, and you see that you have controls here to create new elements, and you can also download the XML when you're done and visualize how it looks like. And here's the visualization of that protocol we discussed. So you are asked whether the patient's fainted before. If they have, then we ask more information about that. And on the Sana Mobile side, these XML procedures are stored on a device, and when you select the patient, you see a list of the procedures that you have available. And when you select one of these procedures, that XML is parsed to dynamically generate a questionnaire that's viewable on the mobile side. So that particular procedure we dealt with, this is how it would look like when parsed on mobile. So we're asked, has the patient fainted before? And if you, this is on multiple choice questions, so we select either yes or it's a drop down where you can also select no. And then once you make a choice there, you go on to ask further information about that. So although the protocol builder is a very useful tool for building these types of protocols, one of its main limitations is that it's not linked to Sana Mobile. So these protocols that we're building in the protocol builder don't actually get propagated to the devices. So this introduces several problems. One is that it's difficult to install these protocols. Typically protocols are installed by packaging them inside the Android APK for Sana Mobile. And even after you've installed them, it's very easy for these protocols to fall out of sync. If I make an update on the protocol builder, that does not get propagated to these devices. So the main goal of our project was to sync Sana Mobile with the protocol builder in a seamless way, so that if you're making the changes on the protocol builder, these propagate to Sana Mobile in an intuitive way that doesn't require a bunch of user intervention. And here's a conceptual overview of what we want to do, and this is also essentially a component diagram for the first prototype that we built. So how this worked is that users authenticate on Sana Mobile not just against the MDS, but also against the protocol builder. And on the protocol builder, they're able to view a list of all the protocols that are available to them, and then they select protocols that they wish to download, and they get those onto Sana Mobile. So this is a very intuitive and simple prototype. However, it has some major limitations that would prevent it from being useful in production. One of these is a lack of protocol organization. Protocols often have some kind of high-level logical grouping between them, whereas that model we just talked about there does not capture those at all. Instead, when you download these on the device, you just see a long, big wall of protocols with no organization between them. The mobile client also needs to authenticate dually against both MDS and the protocol builder, and it's quite strange for a mobile client to have to store two different sets of authentication credentials for two completely different sets of services. And also, modeling protocol ownership is difficult. The protocol builder accounts are separate from the MDS accounts, and once you've downloaded a protocol from the protocol builder, it's stored on a device that's also authenticated against MDS, and it's not really clear what ownership in this case entails and how you would share this protocol among a bunch of different users. So our solution to this problem was to implement something called procedure groups. So procedure groups allow basically a many-to-many mapping between the observers, which are essentially Sana Mobile users, and the procedures. So this is how a procedure group could be visualized. So here on the left-hand side, we have a bunch of Sana Mobile users that are authorized to view the set of procedures. And on the right-hand side, we have a set of somehow logically related procedures. And this is how the component diagram for our final implementation looks like. So there are a few major differences between from the diagram we discussed earlier, so I'll go over these. One of these is that we're using the medical data system, the MDS, as a bridge between the protocol builder and Sana Mobile. So instead of Sana Mobile directly pulling from the protocol builder, it's using the MDS as a bridge. And instead of syncing individual procedures, we're syncing entire procedure groups from the MDS. So the rough workflow now looks like this. You're on the protocol builder, you've built a protocol and you want to push it to mobile. What that does is you can initiate a push to the MDS, and then once it's in the MDS, you can associate that procedure with a bunch of procedure groups. And then on Sana Mobile, you're able to view a list of procedure groups that you have, and then you can start the procedure group, and then what that does is it downloads all of its procedures, and it also starts a sync. And every 24 hours, we check on the MDS to see whether there are any updated procedures in that procedure group, and if they are, we download them as up-to-date ones. Now we'll discuss the changes that we made to the protocol builder, MDS, and Sana Mobile in more detail.
So with regards to the changes we initiated to MDS, we initiated 3 major changes. So the first of all, we introduced the concept of protocol groups to the MDS. Second of all, we introduced some new API endpoints to help support the synchronization feature. And third of all, we decided to investigate opportunities to improve the deployability of MDS as an application. So with regards to the introduction of the concept of protocol groups to MDS. So as I mentioned before, a protocol group can be thought of as a logical group of protocols. And it comprises of several attributes, including a title, an author, a description, and a list of associated procedures. So what's important here is the fact that a protocol group has a many-to-many relationship with protocols. So a protocol group can contain 0 or more protocols, and a protocol can be a number of 0 or more protocol groups. So here's how a protocol will look like So as you see here, there's a protocol group called Preliminary Protocols created by Dr. Smith. And right now in this protocol group, there contains only one associated protocol, and that is a protocol called Identifying Information. So the second change we initiated to MBS is to introduce several API endpoints. So the first endpoint that we created was to create new protocols. The second endpoint lists protocol groups. And the third one actually syncs with a existing protocol group. So what the request provides for this particular endpoint is a list of procedures and the latest versions. And what the response will contain is for every procedure in the request that is outdated, it will return the latest version of that protocol plus the actual XML file content of that up-to-date protocol. It'll also return a list of protocols that in the request that it could not find in the protocol in the request. So this is an example of a response for the list protocol group endpoint. As we see here, we can see that preliminary protocols protocol group that we showed before, and all the information that was seen from the webhook can also be found in this response. So the third thing we investigated was deployability. So to gauge the deployability of MDS, we tried to deploy this to both Docker and Heroku. And we were successful in being able to deploy to both. But what we found, especially during the deployment to Heroku, is that it would be very useful if we could improve the portability of this app from Python 2 to Python 3. So right now, the MDS app is written in Python 2. But we found that through the use of several Django framework features, such as the Python 2 Unicode compatible annotation, and tools such as 2.3, it's actually possible to facilitate a future port from Python 2 to Python 3, which is helpful since in the future more and more support will be given to Python 3 and less of which will be given to Python 2.
So now we'll discuss the changes that we made to the protocol builder. Now, part of the new workflow is that the protocol builder pushes protocols towards the MDS. So in order to support that, we need to allow users to set an MDS instance. And on top of that, we integrated these new MDS endpoints with the protocol builder. So this is similar to the workbench for the protocol builder that we saw before. However, in the top right-hand corner, you see there's a new push to mobile control. When you click that the first time, what you see is this pop-up that says that there's no MDS instance, you can add one below, and it asks you to input the root MDS URL and authentication information for this MDS instance. And once that's in place, then we're able to actually push protocols to the MDS. And the rough state machine of how this flow works is as follows. So if the MDS instance is already set, as would happen here in the left-hand flow, then we're able to push to the MDS right away. If it's not set, as you can see in the right-hand flow, then we show that input modal I just described here. And then once you input your authentication information, we try to log in, and if that's successful, then we're able to continue pushing to the MDS. There are two common error modes that we expect here. One of these is that you inputted the incorrect MDS, and we're unable to log in. In that case, we show the input modal again so that you can correct the MDS URL. And another is that your authentication information is correct, which might occur either because your username or password was incorrect or because you had an old session key that has since expired. And in that case, we also correct this by showing the input modal and you can re-enter your authentication credentials, again, to retrieve a new session key. On the Sana mobile side, we have a new activity that lets you view the list of procedure groups available to the current observer. And this is how it appears. So you see a list of all your procedure groups as well as some metadata associated with these. And when you click sync, what this does is it downloads the set of procedures stored in that procedure group. And it also initiates a periodic sync. So every 24 hours, what we do is we send to the MDS a list of currently installed procedure names as well as their version number. And if on the MDS there is either a procedure with a newer version or a procedure that's missing from the mobile client altogether, then we download that. So that way, every 24 hours, we have the most up-to-date information coming from the MDS. So a few challenges that we faced are here on this slide. Some of them are specific to open source software development, some of them are more general. But one of the main challenges was requirements elicitation. Sana has several different products and components that were involved in this particular project. So we have Sana Mobile, Sana Protocol Builder, and the MDS. Now, all of these serve a slightly different purpose in Sana's ecosystem, and we had to get a good understanding of what role they play and how to best get these to communicate with one another. So this wasn't at first a purely technical project. We had to get a good understanding of Sana's mission and goals and then figure out how we can use technology in order to get to the goals that we want. Another place where we had problems was in terms of making estimates. In general, we were overly optimistic in a lot of the estimates that we made. A lot of this, I think, is because we're working with unfamiliar software systems, and we typically underestimate the amount of time that it will take to actually get a good understanding of these kinds of software systems and get up to a level where we're comfortable doing development at a steady pace. In hindsight, it would have been better to set aside more time for just understanding these kinds of software systems and also make smaller sub-goals. For instance, instead of saying we're going to do this protocol builder implementation in 6 weeks, we could say let's split the protocol builder implementation into 20 subtasks and then do 4 subtasks a week. Something like that in hindsight would have led to a more steady rate of contribution, I think. Another challenge we face is inheriting an older code base. Certain components, specifically Sauna Mobile, have been worked on by many groups in the past and have accumulated some significant tech debt. This reminded me a bit of Conway's law, which states that the structure of a software system reflects the structure of the organization that built it. So that was something interesting to keep in mind when working with open source projects in general. And lastly, there's a certain saying from Fred Brooks that you should plan to throw away a prototype because you're going to anyway. We thought it was an exaggeration at first, but in hindsight it ended up being very true for our project. That first prototype we built where we're syncing Sauna Mobile directly with the protocol builder we didn't intend that to be a prototype. We thought that that could be a final project, a final implementation. But in hindsight, it very much was a prototype. That just wasn't up to par for something we could merge into production. But it was very useful to build anyway, even though the majority of the code did get thrown away. We were able to get a good understanding of the different components that we were going to be working with and also some of the pain points that we would face later on. So the code doesn't exist anymore, but the knowledge that we gained was very useful in our final implementation. In terms of results, there are some pull requests for the MVS and Sauna Mobile that are still in review. We've merged intermediate steps as well as some UX and testing improvements that are sort of tangential to this project, but make these products more usable. And the protocol builder pull requests have been fully merged. In terms of productivity, the initial prototype that we built, which was mostly on Sauna Mobile, had around 1,500 lines. It was primarily a throwaway prototype, so most of these lines are not used anymore. We were able to salvage some UI elements, but the majority got thrown away. Our final implementation has around 2,500 lines. Of these, around 500 are in the MVS, and 1,000 are in the protocol builder, and 1,000 in Sauna Mobile. In the future, we hope to get the remaining PRs merged and then help oversee a release of this syncing mechanism into Sauna's existing deployments. And some other things we could look into are releasing Sauna on Google Play. Now that it doesn't need to come prepackaged with the protocols, we could just release a version without any protocols, and then the protocol builder and MVS could be used to start the protocol syncing mechanism. And another interesting thing that could come of this project is popularizing the protocol builder now that it can be used to sync up its protocols much more easily with Sauna Mobile. We're hoping that it could be more popular in Sauna's deployments. So that concludes our presentation. Thank you for listening, and a special thank you to Ken and Eric for listening in through the live stream. We're happy to take any questions.
All right. Clap extra loud for Ken and Eric. Yeah, so Eric and Ken, you can send me questions in the chat if you want. And I was wondering if two different doctors work on a protocol, how do you cope with like merge conflicts?
Yeah, it is possible that two different doctors could push from the protocol builder to the MVS the same protocol. Right now, we don't support merging. What would happen is that one would just overwrite the previous version. But these protocols would both still be stored on the protocol builder. So even if on the MVS one just overwrote the previous version, then it didn't actually get deleted. It would still be on the protocol builder, and it would be able to communicate with one another and decide which one they want to push and re-push. But we don't have some kind of merge conflict resolution strategy.
Okay, so just every time you push it writes and it says this is the latest have you
Yeah.
fainted protocol.
That's correct, yes.
But then the old one is still there. So time puts a linear order, like
Yeah.
push time puts a linear order on the versions.
That's correct, yes.
Yeah. So what are the PRs that are outstanding now?
So we have two major PRs that are outstanding. One is for Sana Mobile, which adds the integration with the procedure group syncing. So specifically, this activity here and some of the syncing logic is in that one. And in the MDS, we still need to add a few extra API endpoints. These are the ones that we discussed here. So we still have a few of those outstanding.
Cool. Did you end up interacting with any of the users of the system?
No, we didn't end up doing that. I think it would be useful to do later on. We still intend to get this merged in and help oversee a release. So we didn't manage to interact with users, but if we're overseeing a release, I think that would be something that would be useful to do.
Good. Excellent. Well, I want to thank you guys for doing a great project, and thank Eric, and Ken, and Sana for, I think, being our longest external partners. 6 years now since SE 2013. So I guess it would be 7 because that group would have started in 2012. So that's really fantastic, and I'm very grateful to Sana and grateful to you guys for carrying this torch and doing such a good project in such a worthy area. So thanks very much.
This one doesn't have any external, right?
No, we don't have external.
But you can go down to this one.
Yeah.
And an Afi.
Yeah, a Nerfy.
Nerfy.
I know, it's not phonetic.
Yeah.
He's accustomed to that mispronunciation.
He's very gracious about it. Okay, I'm gonna go put them in here.
Yeah.
Okay, so there it is. Great. We have a multitude of connectors. We'll get you one that'll work. And so there's some problem with working for videos. Okay. Yeah, there is a cable.
The thing is, the video is playing.
I don't think you're trying to problem with it. It's usually my too. I have not before. No. It's okay, because I think we just got the video work, so. Alright. So, I'm sure your video will be here. And down, down. There you go. I'm just gonna grab my mouse. So these section logs that you had up there, are they like old ones, or is that like a fresh book?
Those are pretty new.
Okay.
I think those are from last year. Yeah.
Yeah. Do they buy like boxes of them or something? Or?
Yeah, he buys handfuls of them at a time. They're expensive.
So they're expensive?
They're $40 or $50 each.
How many logs are in there?
Usually about 90.
Yeah. Were they like carbon copy?
Carbon copy.
Yeah, that's probably why.
Yeah. Yesterday was a technical difficulty day for me. Everything I touched just, it just broke. You ever have those days?
Oh yeah. Yeah. Some days it's better to just go have a beer. Yeah, I don't know.
Hello, Team Circle Check.
So this is Derek Rayside, EC product, and he's the capstone guy.
Yeah, I think I wrote you some feedback on your abstract that Andrew forwarded you.
Yeah. That's
so
right.
I've been looking forward to seeing your talk. That's you know, you achieved what we've been trying to get the SE students to do for the last decade.
Problem?
Yeah, connecting with like a real problem in the real world, and like, you know, actually solving it apparently. So your abstract claims, I will see in the talk.
Hopefully we can prove it.
Yeah. So Dan Brown is coming, who's the Associate Director Undergraduate for CS.
Yeah, I just showed his face.
Oh, okay. Great. And Brett and Dan and Watson.
The thing is this. So 5 minutes above.
You should have some after.
Yeah. Is the video?
Shouldn't.
Yeah.
I just have to switch over now. I'm just leaving it back in the
Did you figure out the mic?
No, but this is not the camera I've used before, but it's working fine. Like I can hear it on the stream, and people remotely are like, yeah.
Stoked for presentation.
Yeah.
Stoked. We have like 2 minutes.
Oh, so this is Matt from Creative Services. So
hi, Matt.
Matt wanted some video for.
Oh, okay. Oh, right on. Okay.
So 2 minutes when we grab it.
He's already done like some interviews and booths.
Yeah. Well, maybe you can, you know, there are better settings that I can do here.
We're gonna take 2.
You know, once a year I plug the camera in, and the lighting is bad, but it's adequate.
Hello.
Hi, Dan.
How are you?
Very well. How are you?
Good. Not only are you feeding me lunch, you're feeding me well.
Oh, great. Yeah, Shaw's
is good at that.
Yeah, has adjusted our selection for this year. She's got new ideas there.
Okay, great.
Which I'm glad to hear that they're succeeding.
I think they look great.
Yeah.
I think they look great. Are you all here? Or? We're not all here. We're not all here.
No, so it's, yes, there we are, one, and then an external visitor to the university.
Okay. So you actually in the know?
How's the day been treating you guys?
Good.
Nice.
It's a good coincidence that the food served at the same time. Maybe we'll get a better mark.
You're my last one. If there was somebody right after you, you'd run the risk of me being asleep in a post-lunch haze, but you're my last one.
Is it just me, or does this presentation smell really well?
So we're all here.
Okay. Are you guys plugged in?
We're ready.
Okay.
So our design project is called Circle Check. So starting off, let's just talk a little bit about the basics of the problem. So across Canada and the US, hundreds of thousands of commercial vehicle operators have to fill out a mandatory building inspection form. If they fail to fill out these regulation forms, they are liable to get fined, and if their vehicles break down because they haven't been diligently filling them out and sending it to the managers, then all of their companies are on the hook for that cost. So these regulations and systems are very harsh in that sense. And the final point is that inspections and these paper forms are hard to manage. So as you can imagine, we have a little booklet here. Managing this is not easy. You have to keep it in your vehicle at all times, and after you fill out a couple, you have to physically hand them into your manager. There we go. So let's talk about the cost of this problem a little bit. So these physical booklets, that one physical booklet costs around $40 and lasts about 4 months. And usually, like if a company has maybe like 10 vehicles, small company has 10 vehicles, 5 vehicles, large company has closer to 1,000 vehicles, that cost can really add up. And it's a 4-month basis, you have to repurchase all of that physical booklets. Problems aren't communicated. If there's something wrong with the vehicle, it's going to take a month before the manager finds out. It's going to take a week before the manager finds out. So problems can compound very easily. And because problems can compound easily, there are a lot of heavy repair costs and time loss. So as you can imagine, repairs of these vehicles aren't cheap, right? And if you're repairing a vehicle, you can't really use it.
So a lot of these workers lose a lot of time, companies lose a lot of money repairing these vehicles, and workers lose a lot of time where they can't do anything, where they can only sit around and not do anything if one of these vehicles goes down. So the general idea is kind of these vehicles cost hundreds of thousands of dollars, upwards to $1 million. So why do we have such a terrible solution that solves this problem? We can introduce our solution. So let's just talk a little bit, just like very basic, about what our solution is. Our solution is a mobile and with some cloud support. Our solution has customizable checklists, so operators and managers can focus in only on the important details. And also it's instantaneous. Instead of taking a week, instead of taking a month for managers to get that critical information about the vehicles, after an operator fills out a checklist, upload it immediately to the cloud, or they can email it, and managers can find that information right away. And also, it can be tracked over time. So let's think about where our app can save companies a lot of money. Well, first off, if a company is using our app, instead of using these booklets, they don't have to buy these booklets anymore. So right off the bat, you don't have to pay money for these booklets. All the information is in bite-sized chunks in our app, so that it's a lot easier for operators and managers to digest the information, and we only include the very important information. Problems are identified quickly, so like I said before, all the information is transmitted immediately so that if there's something wrong with the vehicles, managers can find out quickly. And overall, it's just an easier process. Instead of having to carry around a booklet, keeping track of which sheet you filled out, ripping the sheets out, handing it to the manager, you just fill it out on the app, and you don't have to worry about it anymore, because it automatically uploads to the cloud. And you can basically eliminate all of the repair costs and save a lot of time as well. So now we'll have Jason do a quick little demonstration with a video. Hopefully the it's a little bit bad quality in this internet, so we'll add it.
It's better with sound.
So here we can see the person logging in. We can load up a vehicle, and the person can walk around the vehicle, kind of like, I think here they're adding the loader vehicle, they're putting in all of the information. Loader vehicle.
And have it sync to the cloud. Yeah. So then you can access that vehicle and perform a checklist for the vehicle. This is just a video explaining, just a demo of what might happen.
So if there's something wrong with a part, they can click on that part. If they can't find it, you can do a search.
And this is something that the logbooks don't offer. You can add comments, you can add a photo, just an extra layer of communication that you don't get.
Yep.
And that's
And we have a happy driver, because they don't have to keep track of. So we'll continue presentation.
So we were lucky enough to work with a stakeholder. In this case, it was a quarry manager, and they owned about a dozen heavy machinery. So we worked with them, and we helped develop this idea. Initially, the first term, we just contacted the quarry manager and got the basis of what needs to take place to put these forms in electronic into an app. So we also established contact with the Ministry of Transportation, where we verified that this app is compliant with the legal standards necessary to meet the Highway Traffic Act. So we went above and beyond just construction vehicles. These are road vehicle. It's road vehicle compliant as well. So with that, we entered the first term. We produced our minimum viable product in Android. We developed an Android app, taking in consideration what the quarry manager had told us about the problems. And we gained feedback as we were able to test it with actual drivers of the quarry. With that, we began this next term. We had further contact with the quarry manager. We discussed where the app kind of fell short and what needs to happen. Basically, they expressed the idea that we need a multi-platform app. We need both iOS and Android. They would like it cloud-based, or else it's really just local to the phone, and that's kind of contrary to the point of all this. So we also refined the checklist. The data that was there, we made it more suitable to do a proper checklist, so you can actually go down the list, and if you follow the list, you will actually, it will give you like a nice walk around the vehicle at the same time. So we did that. So technically, we built with React Native. We have cloud capabilities. Our app can become, our app has a Google Cloud backend, which allows for reliable and scalable, going further to scale. So, and it is somewhat standalone right now, as a standalone. So moving forward in the future, we are looking to obviously increase what we have in app form. We would like to improve upon the functionalities of maintaining of data on the user's phone, as well as getting backend to work over multiple companies, because as of right now, it's just one company and everybody can see all the data shared within that company. We're looking at monetization of how we can do this. We're looking at a subscription model based on per vehicle. And we want to keep the data entry to a minimum here. So we're even moving forward, we'd like to even reduce the amount of data entry that you actually do on your phone. We will continue to test the product moving forward and build our monetization model into a more solid form. We've been pretty much focused just on the technical side right now. So that's about it. And the alternatives. So let's talk about the alternatives. Caterpillar has an app. It's very costly. It's an enterprise app, and it's specific to Caterpillar vehicles. So, and it's available on the App Store, but it is an enterprise app. So you do have to contact the Caterpillar themselves, and they have to hook it up. Logistics software that exists for fleet vehicles. They're very general, and they often don't even address the specific issues that need to be looked at, especially with construction vehicles, which tend to break down more often or incur more repairs, that they need more repairs, is what I'm trying to say. So checklist apps are also available on the App Store, but they're very general and they don't really address what we're trying to solve here. So I believe that our solution is really the best out there right now. So wrapping up, we are CircleCheck, and our aim is to make daily inspections simpler, safer, and easier to manage.
How on earth did you find this problem? Like this is a terrific problem.
Yes.
Like this is a really terrific problem.
Yes.
But like, how the hell did you find this problem?
Oh, to be honest, my brother is in the business, and he's been in the business for over 10 years.
Okay.
And he's a general manager. And he's
At that quarry?
At the quarry. So
okay.
He gave
awesome.
Yeah.
Awesome.
He gave great insight to that. So.
No, I think one of the real strengths of this project is that you've identified a pain point that obviously needs a tech solution, but you're identifying with a lot of care about why the obvious solutions don't quite work. You've only made the sort of the end of the application that the driver would do. You haven't made the end that the manager would do to like track problems with their fleet. Is that right?
Well, yes. Right now you can select a vehicle, and the idea is that you would be able to access all of the past checks. But right now, as it stands with our product, we can email the information, but the information isn't shared. But yes, I think moving forward, it would be a manager side.
Yeah.
Or they could just see all the vehicles.
Like, I want to know what my problems are that I need to start budgeting for, or hey, that vehicle's been down 20 days in the last 60. There's something really wrong with it, or like beyond what we've been preparing, or like that's the kind of thing I can imagine if I was a fleet manager, I would want to know about these kind of things. But yeah, no, this is I think the real success of this project more than anything is the quality of the focus on the actual problem.
I think that's just a comment from just when I saw you guys much earlier in the semester. Incredible. The fact that you included a demo of this thing, I thought that was just fantastic. And the alternatives in itself. Have you been speaking to like an investor? I'm just curious because you put alternatives and like none of the other groups have mentioned alternatives at all, but like it's something that you would have in a pitch deck.
We went to the velocity pitch competition and they kind of sat in on them and we got a lot of pointers of like what to do, what to include, how they were going about it, and we sort of tried to emulate that.
And just so they know, like the major components, what you got, like, so you do a checklist on the phone and you can email a PDF immediately.
Yeah.
But it's also synced to a database. Well, it's a Firebase, right?
Yeah. The vehicles are synced. Right now, if you want to look at our program, the vehicles sync. The checklists do not sync. So the checklists.
So right now they're going out via PDF and an email.
At the end of the day, moving forward, we want everything to be able to sync with the cloud, and we also want to build more on the cloud end, like a manager's portion of the app, and then we have the operator portion. So so
like
we focus on the operator portion.
The people that are going to like invest are like the managers. So I agree with Dan. Like there's analytics that they want, right? That you can't do with the paper books. So
yeah, like the real lose with these paper books is that like they just go on a shelf and no one ever actually tabulates anything.
Yeah.
Like that's the
once you got the data, you can do stuff.
Yeah. Like for instance, if a vehicle is needing oil constantly over multiple days,
there's clearly
you can flag that and see. It could be a bigger problem down the line. It could lead into total engine failure.
So yeah, just to expand on Andrew's point for your marketing efforts, right? So it's great that you, from our CS HCI hat that you focused on the actual users, and it's so awesome that those users are not you.
Yes.
It's so great to see that. That you're dealing with different people in a different context. But as Andrew pointed out, a weird thing about corporate software is that the people who pay for it are not the end users. And so to sell it, you're going to have to really build out that manager functionality, because those are the people who are going to make the decision to buy.
You're right.
Well, at the end of the day, the other thing is that your value prospect is it's saving those people money.
Right.
Like they are actually really important users, because their needs are quite. I mean, even going past what Derek said, the other thing that's neat about this is not only are they not you, like they're blue collar. God forbid. Like you have like people who are designing an app that's like for world travelers or something like that. Like that is awesome. But the truth is that the white collar people who are sitting in the offices are the ones that are actually going to buy the software. So yeah, that's important in that context.
But at the same time, the fact that you focus on the operators, because I mean, you get enough operators that are demanding this,
Absolutely
that
right.
it's gonna follow its way up the chain in itself, though, right? So to me, the figure of focusing on MVP was very smart of just what you did, because you really just with the MVP just want to hone in, just focus on just making that one user like really happy, and then also again to Derek's point about the manager building that out. But like for this point in time, though, I think it's just like a really great job.
So another marketing angle might be getting unions on board, right? Because if unions say, this is keeping our guys safe, because the maintenance is now going to get done, because now we fill out this paper book, and then like maybe the truck gets fixed in 6 weeks, or maybe it doesn't. But with this, the equipment is maintained and our guys are safe, and it's also saving them time. So if you can get the unions to apply pressure, that could be another angle.
Yeah, depending on the environment, this is a highly unionized workforce. The other aspect of that is also getting unions on board makes it not software that the boss is mandating down.
Right.
That goes to your point too. That like if it's the guys on the machines who are asking for this stuff, that will make adapting to the technological change a lot easier for that community of people than if it comes in as you're going to use the software now, aren't you? Screw you.
I had something. So we looked at some alternatives, and we found that they're really inadequate overall. Why do you think there's nobody who's in this area? Because it's hard to find a software project that other people that is not a big competitor, right? This is the core
I think that
what's the
lack of care for the workers. Really, I think that's what it comes down to. It's basically this is how it's just been done, and there's not much aid going to that space.
And is it that people who have this problem aren't going to be software people most of the time? Does it boil down to that, or is there some other? What I'm getting at is there some other hurdle? Is there some other barrier that's keeping other tech companies from doing exactly this?
I think that there has been a lack of technical use in the field in the past, in a short little while. But now that everybody has adapted and carrying around cell phones more readily, it's ready to switch.
Right. So it's prime. So now's the time.
And maybe there isn't a lot of motivation for the entrenched players to change. Like the people printing the books want to keep printing the books, right? And selling them. And I mean, at least from what you discussed, you said Caterpillar, okay, they sell trucks. So they're making some stuff, but then they only make it for their trucks.
And you should see that it's made by complete software developers that are just way over the loop. Like it's very complicated. I was getting dizzy just watching what was going on.
It might be worth. So in this space, the company that I'm familiar with that has the best tech is actually John Deere. Like John Deere has surprisingly good software developers who work for it. At Grace Hopper last year, I saw a demo of a lot of their various things, and you might. I would be surprised if I would not be surprised if they were the rare exception and actually had somebody fail to suck in this area. But yeah, I am not surprised that a lot of the other manufacturers suck in this area.
Yeah, like the main problem is that the software that they make is proprietary for their own vehicles, right? And they're not going to make even if their software is like world class, they're not going to make that public for all the other
part of what you're buying.
big companies, right? So So what we're making is we want to cover everything. You know, small players, medium players, big players.
I think to your point, I think it sells itself. You mentioned the unions, but I think like too the Ministry of Transportation and the Labor Board, they love to see that kind of stuff. If they can just go in and everybody, they can just check.
If you can, if you can get partnership with regulatory bodies who then mandate your stuff, like,
well, or at least
or even just have like some kind of portal where the company can do their compliance work. Like they use your software and they basically have no additional compliance work because the data gets sent to the MTO, right? And then they're reducing their extra compliance stuff. Like, then that's another great way to promote.
Yeah, because otherwise you're like having those rooms in these plants that are full of like that book, going back 5 years for 50 different tries.
And I mean,
and like somebody has to manage that, and suddenly like that sucks.
And does somebody at the quarry at the end of the year have to like write a report about their room full of books and send it to the MTO? Like, right? So if you can alleviate that workflow, if it exists, you know, I think that could be another real value proposition.
You could save the government money.
Well, and you can save companies money in doing their government compliance.
Yeah. Compliance costs, I mean, obviously we know a lot more about the university in this respect than we
Right.
know about, like, I don't know much about quarries, but compliance costs for government regulations cost this university an astonishing amount of money.
So anytime a professor goes on a trip, you submit an expense report.
3 to 5 people look at that report.
Right, and you're saying, okay, well, I'm going to spend NSERC money, taxpayer money, to go on this trip, right? And so there's a lot of scrutiny on all of those line items. You know, do they meet with tri-council regulations? And you know, we want to be responsible with taxpayer money. It's good, but it's a lot of compliance work, and maybe companies in these domains also have similar MTO compliance work, and this could alleviate that.
Everything has become more and more compliant with safety, compliance. Everything is paperwork. So if they can reduce the paperwork,
I mean, it's worth saying it's to a good end. I mean, like the fraction of the population that dies in workplace accidents has dropped dramatically in the last 50 to 100 years for really great reasons. And these sorts of, one of the things they use these kinds of assessments for is after a bad thing happens, they look at all the evidence of what happens so that they can then make regulations so as to minimize, like there's a continuing improvement thing going on there, which is really virtuous, but the compliance costs are astonishing.
Yeah.
This is a really great project, guys. Yeah.
Thank you.
What about presentation?
Is there a group in there? I think there's a group in this room. Let me check my
Team YouTube careers.
okay. Right. Yes.
You're staying for that? Or?
Yes.
Okay. You're faculty here? I don't think I know you.
No.
Hi. How do you do? How do you do? You're here at Waterloo? Or?
Yep.
No, I'm actually in New York.
Oh, okay. Okay.
Okay.
Thanks. 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 Glad you're here. Glad you're here. Awesome. Yeah. Everyone's in computer science undergrad programs.
Okay, so you and Andrew?
So Andrew is running the Capstone 4CS, which is new this year. Software engineering students are computer science students, but that program is run by Derek and by Pat Lamb. The 3,000 students who are getting degrees in computer science, just called computer science, that program reports to me that I chair.
I see. Okay.
So it's a very Byzantine and uncomplicatedly structured university, but this is mostly software engineering students today, but it happens the project we just saw was a CS project. Right. And a very good one.
Yeah, really thrilling.
Yeah, like the presentation was dry, but the actual work is.
The visuals were good though.
Yeah.
They just
I
need
mean,
more technical.
having sat here and watched previous 3 hours of talks, like, this year is a bit not as good on the visuals. Like these guys did a good job.
I like their video.
Yeah.
Well, I mean, I just like the fact that, I really like the fact that it's a project that's not about 20-somethings traveling or trying to find a girlfriend or making sure that they've graduated
Out of all
properly.
of them, out of all of them that I saw, it seemed like it had from the beginning. It seemed like it was the most obviously polished, useful. I mean, not at the beginning.
No, it's not that polished compared to some of the better ones.
But you're talking from a technical standpoint.
Yeah.
I would say even from a presentation, like the one that Bilal's group did was from a presentation standpoint better. They just don't. They have a really cool app that lets you explore census data about the city of Toronto, which is awesome. Which is really awesome. But it doesn't have the business oomph behind this one. Like that's what this one has. It's so unusual.
To me, this is something like a pitch out of something from Colossus. It's ready for and that's really what resonated. I liked about it a lot.
Absolutely.
Maybe not necessarily for the audience, but totally for Capstone, from how it should evolve.
You can totally see where this is 6 months from now.
Yes.
Yeah, no question. 6 months from now, this could be brilliant.
I don't think I changed that, but that's fine. I can just
and just nice to have oh my god, it's about people who aren't like that.
So are Lynn and Calvin?
That's awesome.
No, it's probably from doing that.
Not on me, but it's super easy to remember.
Well, I sent an email to all the referees.
I'm the easiest guy in the world to recognize.
So hopefully,
it's great to have you there. It's great to have you here.
I can just rebuild your sheet right now with the other rubric and update that. So Anarfi is here locally. So this is the one that's going to go up.
Hi.
And Anarfi's from York, and he's on the business side of things. So he's interested in your project. And so is Lynn.
She's here.
Yeah, great to see you again. Yes, I thought that was you, but I aren't good enough to read your name badge at the distance. Thanks for coming back to school.
Yeah, still around in town.
Yeah, excellent.
Nice to come back.
Okay, where is...
So we will set up?
Yeah. So do you have a way to communicate with Calvin?
Yes.
Okay, so if that email that like Calvin drew at Shopify, if that email works, see if you got the email. I don't know.
Let me call. Yeah, he's there.
Okay, great. Can you see the feed?
Yeah.
Okay, so I'm just in the process of updating. Okay, so if he goes to the URL that I sent and gets the grading sheet again, it'll have the other rubric. Thanks for coming out, Wojtek. So the team, for whatever reason, is on the new product rubric, but they sort of want to be considered from the research angle. And so the general flavor of that angle is how many, it's assuming that you have an algorithm that does some computation, and it's like, well, how many cases do you deal with? How robust is it? How good is your algorithm? But
this is no longer relevant then, the new product category?
Yes, they do not want to be considered from that perspective.
Do we have the criteria for the revised?
Yeah, like I can give you another one that has that. I just won't say the right team name at the top. Let me.
Yeah, it's just blinking it. It's not connected to the project.
There we go. So, yes, no, you can keep it. Yeah, so you can just, you can use that and cross out the top bit and write YouTube careers.
Do we need to press anything for the projector? It's just blinking, it's not connecting.
Should just go, hopefully, maybe try the other computer or something. Oh. Is there another adapter of the right kind? Is Calvin one of our alumni as well?
Yeah, he's graduated last year in ECE.
Oh, okay. So like I was pretty sure that name was familiar, but we didn't find him in our SE database. It's funny, Lynn. So Patrick made this new database of SE students that we populate basically from the SE seminar enrollment data. So when we looked you up, it guesses that you're SE 2019, which is wrong, but just because you transferred from ECE, like you're in a...
I transferred from
CS, right.
And my sequence is abnormal. So
yeah, so it couldn't correctly infer. And then I was like, hey, wait a minute, like, what's going on here?
There.
Yeah.
Do you have a computer that generates?
No.
You have 2 Macs with you?
Yeah.
Is it on Google?
Yeah, it's on Google.
Yeah. I mean, I guess I could give you my computer. I'm not super thrilled about that idea, but show must go on, as they say.
You sure you don't want to do stuff or somewhere?
Here, you want to share that with derek.rayside@gmail.com? Derek.rayside, like I can plug. maybe. Yeah, that's fine. We haven't had any problems onboarding before now. But I guess we have problems now.
I can try to talk to my
Okay.
Thank you so much. Alright, hey guys, sorry about the delay. We're from YouTube Koreas, and my name is Neil. This one, and I'm Mignon. And we are giving you guys a brief introduction to our project, YouTube Koreas. So YouTube Koreas is a web platform that connects people with their dream jobs. So our current focus is on the referral systems. I'm sure everybody here are familiar with the referral systems. Pretty much all the well-established big tech companies have systems that allow their employees to recommend candidates to open job positions. This is often encouraged by additional rewards like cash bonuses. In smaller companies, startups, this type of referral still happens, in the form of people encouraging their old colleagues to join their new teams. In all other industries, even without the explicit form of a referral system, people refer each other all the time. So this system is in all industries. But there are problems. So for referrals, the people they know might not have the skill sets they need for the job position. So we have Steve here. Everybody has a Steve. Steve is your favorite drinking buddy, but Steve is not a good software engineer. So you cannot have Steve in a company. This happens all the time in different sorts of companies too. So in smaller companies, we have an overall lack of talents because of the lack of exposure of the company to the market of talents. And in bigger companies, even with a lot of hires, a situation happens is talent starvation in certain teams. So what I mean by that is, for example, AI teams have the most human resources these days, while teams like infrastructure has less. So even with a number of general hiring, some teams are still lacking talents. So this is a problem in all situations. For the prospect side, when they are applying for jobs, one common strategy they use is to cold mail people. Of course, this leads to a very low success rate. The difficulty is due to having no pre-established relationship with anyone that's in their dream company. That's where YouTube Careers step in. We see the market because there are two parties with demands, and all we need to do is to connect. So using YouTube Careers, we can help prospects to get a competitive edge over other candidates because they can get referred by employees in their dream company to get an easier interview, to have a higher chance to land an interview. And a side benefit, which is also very significant, is that they can talk to people in their dream company before they apply to gain more insights to help them making their decisions. So on the referral side, there are also a lot of benefits. For example, it allows them to introduce new talents into their company, into their teams. It helps some referrals to develop professional networks. And it also sometimes comes with a cash bonus. So with all that being said, you may wonder how exactly does YouTube Careers work and how exactly is YouTube Careers different from other platforms. So one key part is that we connect prospects to referrals automatically with our match algorithms. So minimal work is required from both sides. So when a prospect registers on YouTube Careers and uploads a profile/resume, we match that profile with all the profiles of the referrals in our systems to generate a match. So when that match happens, we inform both sides so that they know there's a match. And so the work is actually done offline. And also the process is very fast. So not only do we not have to wait for it, we are also scalable because we can support a lot more users. So let's take a look at our algorithms. So our algorithm is keyword-based, and so one simple and straightforward way to do keyword-based algorithms is to simply extract keywords from profiles and do a comparison. So the problem is that string comparison is slow in performance, and so what that will cause is for prospects to not see a result for a very long time, even though the right referral is quite there. So that's why we decided to use locality sensitive hashing. So LSH allows us to quickly find similar profiles, which is going to generate matches. So the other reason why we decided to use it is because we already have successful cases using LSH. So it's used in VisualRamp, which is a Google image research engine. It's also used in video audio fingerprint. So as I have touched briefly on the previous slide, we have other alternatives that we consider. So the first one is to do simple keyword comparison, where we just extract keywords and compare it to profiles. The other option we consider is to use machine learning. We could have used Doc2Doc. We could have trained the model in Doc2Doc to vectorize all profiles, and then we find k-nearest neighbors in order to group them up. And then we lastly implement NLP to understand the context of the profile to find matching profiles. So in both cases, the problem is that the execution is slow, and for machine learning, we need data to train the model. We don't have data. So that's why we decided to use LSH. So let's look at the first step of our approach. So the first step is keywords extraction, where we use TF-IDF scores to implement a corpus, a vocabulary for our documents. So TF-IDF, the term frequency means the number of times that keyword is used in a document/profile, while DF, document frequency, means the number of documents/profiles that contain such a keyword. So TF-IDF is a simple but powerful way to identify keywords, and many sophisticated string matching algorithms make use of TF-IDF. So one example we can provide is we actually have two negative examples here. So the first one is generic words like experience and projects. So they will have a high TF because each document usually repeats it a lot of times. But since every document pretty much has experience in the project, so it has a very low IDF score. So that's why it's not a keyword. And things like technologies that are used in just one company, for example, they will have high IDF because only, say, one person's profile has it, but the TF is also low, so it's not a keyword. So one positive example would be stuff like backend, for example. Like it occurs a lot in my resume, so it's high TF. It also occurs in some number of profiles, so it has a high IDF. So that would be a good keyword to use. Now let's move on to the next step. After we compute our vocabulary, now we can use locality-centered hashing. So what is the locality-centered hashing? It's a hashing algorithm that aims to, so it has a high probability to use a hash to group up similar profiles in our case. So assuming we have this locality-centered hashing function with a probability of success of P, so we have two profiles and we know it's similar, then its success rate is P. Then if we have X functions, our final success rate, which is using X functions to try to find whether or not two profiles is a match, is 1 minus P to the power of X. So 1 minus P is a failure rate. To the power of X means all the functions fail to identify them as a pair. 1 minus that is at least one function identifies it as a pair, the chance of that. Yeah, so the reason why I talk about P is because LSH doesn't guarantee a match. You sacrifice for its high speed. So the actual way we implement it is sort of like this. So in this diagram, each of the C's here, C1 to C4, are profiles. This line is our vocabulary. So for each keyword, a 1 represents that the profile has a keyword, a 0 represents the absence of a keyword. So what we do first is we randomly permute the indices of our vocabularies. We permute it x times. So these are the permutation results. So we did it 3 times here. And then we find the index of the first feature that the profile contains. What that means is, for this permutation, for example, C1 has 2, 3, 5, 4, so we take 2 because it's the smallest. For this permutation, C1 has 4, 2, 7, 5, so we take 2. And for this one, 3, 4, 1, 5, so we take 1. So the result is generated here. So using the indices, we can generate a signature of length x. So each of the column here is one signature, and the length is x, corresponding to the 3 permutation here. So this process is called mean hashing. So we just reduce the profile down to a signature, which is a good feature map of the profile, given that we have a very high x. So the x we are doing right now is 512. There is a following up problem. So once we have the signatures, which are smaller than the profiles, enabling us to do a faster matching, we need to figure out a way to actually do the matching. So we can't just compare the signatures directly. The reason is that, for example, in this example, we have 112 and 112 on C2 and C4. Sure, that's probably a match, right? But this case doesn't happen all the time. Like oftentimes we have 221 and 241, like C1 and C3. How do we know if that's a match or not? So it's not exact. So yeah, that's where the problem is. So the approach we take is we group up a signature into bands. So for one signature, we have a number of bands, which is B, and for each band, we have a number of rows, which is R. So we say 2 signatures match if at least some number of bands or buckets match with each other. So our current setting is band size equals to 2. So if we go back to our previous example, so assuming our band size is 1, then C2 and C4 will still be a match, while C1 and C3 will be a match too, because the red one is a, so our band size is 1, so the 2 matches to the 2, and the bottom 1 matches to the 1. So if band size is 2, C1 and C3 wouldn't be a match. But this is not like the perfect example because the signature is pretty short. So if the signature is very long, we can still probably get a match. So yeah, the hash hit, so the matching of a band is a rough indicator of similarities between 2 profiles. And you may ask, so why does it work at all? So we're going to do a little bit of math here. So we have the number of bands. So in our configuration, it's 256, 512 divided by 2. And our rows per band is 2, as specified by the previous slide. So S is our probability of matching rows. So what that means is for each row here, what's the probability of it matching to another signature? So our matching threshold is 2. What that means is that we only classify it as a match if it has 2 bands matching. Anything lower would be not matched. So now we can calculate the probability of a match. So what we do is we take 1 minus the probability of having just 1 band matching and the probability of having no band matching over there. So S to the power of R means the probability of matching band. So S is per row, R is the number of rows per band. So S to the power of 2 is our chance of matching band here. So S to the power of R. 1 minus S to the power of R means chance of not matching a band. We have B bands. So 1 minus S to the power of R to the power of B would be having no band matching. So that same probability to the power of B minus 1 times S to the power of R, meaning 1 band matching. And then multiply that by B, which is the number of permutations. We get the probability of only matching 1 band somewhere anywhere. 1 minus all of that means the probability of matching at least 2 bands. So if we plot the diagram of P over S, so probability over similarity, we get such a graph. So this is after our tuning, so we want to achieve a near 100% probability at 20% similarity. So this is what we want. You may also ask me why is, how do you define similarity? So similarity is number of same keywords over number of all keywords. So between two profiles. So A has 5, B has 6. If they share 1, that would be 1 over 10. That would be 10%. So how is that the same as probability of matching rows? I can talk about it, but maybe after the presentation if you guys have questions on that. So, yeah. So, using our word implementation, we generate our matching results. So, the conclusion is that it's just as intended. If we have two students from the same major, for example, we can get a consistent hash hit of 4 to 6. And then the keywords that are matched include stuff like optimized, detection, distributed. So these are all pretty good keywords to indicate like they have similar backgrounds. On the contrary, if we match computer science students to finance students, we usually get 0 hits. And so I can also assure you guys that computer science with software engineering is usually pretty good. Finance versus finance itself is also usually pretty good. So in our implementation, we consider a hash hit of 2 a match, as specified in the previous slide. And a hash hit of 1, we say it's an almost match. So why do we do that? It's because we have a feature, it's called keywords recommendation. So this is a interesting feature I want to share with you guys. It's matching feedback. So we have different prospects matching to referrals. For prospects that have, let's say, 2 matchings, 2 or more, so it's already a match, so we don't need to do anything. For prospects that nearly get a match, like 1 bad hit, we are able to provide some feedback to tell them how you can improve your resume or what do you need to learn. The feedback we give is common keywords among the referrals. So yeah, that's most likely the stuff that they want to put on their resume or the stuff they want to learn about for their career. So with that out of the way, I will give it to Eric to talk about the platform a little bit.
Yes, so in order to code this algorithm, we need a platform to let people upload their profile and run the algorithm and see the match. So we build a web application, and here is after you log in, you can see who has been matched with you and your profile completion. And here you can input your basic information like your name, birthday, location, industry. Industry can be used to determine which category of words can be used to do the TF-IDL. And you can choose whether you are a candidate or referral. Here you can upload the resume. When you upload, we will do the matching algorithm on the fly. After like 10 seconds, you will see the match because it's a hashing algorithm. So most of the time it's used in encoding the profiles to hash, and the matching is like instantaneously. And you can type some, if you don't want to do the resume, you can also input your other experiences, education, and projects. And here is the keyword feedback. You will see the words we recommend you that you want to put on your resume or you want to learn. So here is all the technology we use. We use React Redux as frontend, and we use G-Cloud, gRPC, Kubernetes, Docker, and Postgres as our backend. So here is the architecture graph. When we designed the platform, we wanted to be scalable. So we took the microservice approach. Each service is in a container, and we can make any number of replica of each service. And here, like for the analysis service, it's the most computational heavy service. So we put more replicas. It can distribute the workload and run the matching in time. And one thing worth knowing is we use Golang as our backend language because it's a compiled language, so it's faster than JavaScript, and it has good support for concurrency, which is very useful for backend service because it can handle like multiple incoming requests. That can improve our entire overall throughput of our system.
So to wrap up, here are some of the user reviews we received. So in general, we have some positive reviews. People think it's a good concept, and people like the fact that they just need to upload resumes, and all the work is done on that way. People also have feedback on the keyword feedback. They wish there would be a categorization. So in summary, YouTube careers connect people to referrals, their dream jobs. So most selling features are automatic processing, the on-the-fly, fast and accurate matching, and also matching feedbacks. YouTube careers. Thank you.
So I'll have a brief time for questions, but then we'll have to take the questions out because we've got to get the next talk on, and I think there's no overlap in the referees. The next group, we have a bunch of remote referees as well. Yeah. So why don't you guys come down, and we'll start doing the plugging while there's a little bit of talking.
I have a question for you.
Yeah.
To compute similarity, there's a whole broad range of techniques. So can you tell me what else you consider as alternatives to locality sensitive hashing and why you decided to settle on LSH for your application?
Okay, so our alternative options are really just good to go. So originally we actually set our eyes on this river, but realized that common business which is another like. So we decided to experiment with this approach because we found that this turnout was always very predicted. So we just decided last night.
Yeah, that was the other room. Oh, really? Yeah.
So is there like any challenge you face during the development?
Hi. Thanks so much.
Yeah, basically
Derek Grayson. Thank you so much for being involved with the projects and coming in here today. And
set up the Kubernetes.
So like right now, it's validate the
I very much appreciate you
like
making an effort to come back here and engagement with our students.
You should not get any keywords from it. If it's a
I am very excited to see how it's
based on your industry.
I've
so like
seen
what's
it
the user
sort of earlier on,
like if they
but I don't know where it is now. So I'm excited to see that.
So on one hand, they wouldn't receive the matching. So I think you're referring to like the verification process.
Yeah.
So we don't have that yet because the product is more like a shell on more algorithms. So maybe we're implementing in the future. I don't know. It shouldn't cause any problem for other users.
Okay, so maybe you guys can take the conversation there to your booth. Good job on the algorithms. It's very interesting. And thank you very much, Wojtek and Lynn. And Calvin, who's watching remotely. Yeah, so your remote referees can send questions, they can email them to me and I can say them, or if they have contact with your other referees, that's another way they can communicate the questions at the end. And I am very excited to see how things are.
All right, good afternoon. We are Team Runway, and we're here to talk to you about the custom consulting software project that we made for VIA Aerospace Systems. In this talk, we'll be going over our tasks and objectives, as well as some of the constraints and criteria. We'll then outline our solution, as well as some of the other solutions that we considered along the way. And finally, we'll discuss some of our outcomes. Our client, VIA, is an aerospace systems company that provides customized software solutions for their clients. One of their key technologies is the Closed Loop Bench, or CLB for short. The CLB is a highly customizable testing platform for aerospace systems. VIA's customers use the CLB to simulate the engine while developing their own engine controllers. The CLB is capable of simulating a wide variety of both configurations and different test scenarios, which can reduce the time and cost associated with developing an engine controller. The CLB produces a large volume of signal data from these aircraft simulations, which can be time-consuming for an engineer to manually inspect and verify. VIA identified the opportunity to decrease the time and costs associated with this process by creating a software product that will help analyze the outputs of the CLB. tool that can analyze the simulation data and provide insights to engineers can help reduce the time and effort associated with validating tests and can reduce the risk of human error. As a research and development opportunity for VIA, one of the main objectives for this project was to explore new technologies. These technologies can be used to grow their current product service service offerings to their customers. Outcomes from the experiments that we ran can be used to find new opportunities as well as make improvements upon existing ones. And one of the other main objectives of the project was to use the results of our research to develop a software product that was able to accurately predict whether the test simulation contained a passing or failing test run. This tool can be used to extend VIA's current suite of tools to include interpretation of simulation outputs and provide additional value to their customers. For our tool to be useful, it of course must satisfy some set of requirements. So the tool must perform well on a diverse set of test scenarios, and it must also be able to produce interpretable results and insights in a reasonable amount of time. As stated previously, the CLB is used to simulate aircraft systems in many different types of test scenarios. The data review tool can be the data review tool needs to be implemented generally, such that it can be used to analyze many different test scenarios and is also able to handle scenarios that it has not yet seen. Some common measures of performance in classification problems such as these are accuracy, precision, and recall. For anyone in the audience that's not familiar with these terms, accuracy can be expressed by answering the question of the predictions we made, how many of them were correct. Next we have precision, which can be defined as of the number of failures that we predicted, how many of them were actually failures. And finally, recall can be expressed by the question of all the failures out there, how many of them were we able to catch. Now in general, accuracy is of course desirable, since we want our tool to be able to make correct predictions. However, in the field of safety critical systems, often high recall is favored over high precision to reduce the rate of false negatives. That being said, we basically just don't want to miss any failed test cases. Another criterion regarding the performance of our tool is its ability to produce results in a reasonable amount of time. It's preferred that given an input test run, we're able to produce some interpretable results to give back to the engineer within the magnitude of minutes. This gives engineers a short turnaround time and can really reduce the costs associated with developing the underlying aerospace system or controller. There are many existing techniques that can be used to classify test runs as passing or failing. However, most of the ones that we investigated, they do not provide any level of interpretability into the reasoning behind the result that they produce. So it might tell you that this is a failing run, but you might be still tasked with figuring out why or where to start looking for that failure. Our tool is used in a context where some degree of interpretability is desired. So providing engineers with insights as to why the test failed and where to begin looking can really help accelerate the development of the underlying system. We'll now go over some of the notable challenges that we encountered while going through both researching and implementing our solution to the problem. One of the main challenges we considered, or we kind of ran into first, was the sheer size of the data being processed and assessed for anomalies. So for kind of our project, we had access to hundreds of test files, each with thousands of signals and tens of thousands of timestamps. So kind of going through and analyzing these files, it was very difficult to extract important data. And by that, in this context, we mean important data. We define important data as which signals are most significant to the results of the test run and which signals have meaningful relationships between each other. Another main challenge that we encountered was that of having limited access to labeled data. So in our project, a label defines whether the test is a passing test or a failing test. In the general problem space, getting these labels is a very expensive task. It requires an engineer, an expert in the area, to spend a lot of time reviewing these to determine whether it's a passing or a failing test. So while we do have the benefit of having access to a very high volume of data, the labeling of this data can be quite expensive. And even if access is available to these labels, it's beneficial to design the system around not having access to the labels. It's better that the tool could gain further insights by the introduction of these labels later on, but does not purely depend on them to produce results initially. As a result, it was challenging to focus our efforts only on methods that didn't rely on labels, but rather were improved by the introduction of them later on.
Yeah. So our solution to this problem is designed to address these challenges while satisfying the requirements of the project. One of the important design choices that we made was to frame the problem as a time series anomaly detection problem rather than a pass or fail sequence classification problem. One advantage of taking this approach is that given enough data, if we can assume that the majority of the data represents normal engine behavior, then we can train our model without the need for the pass or fail labels of the test runs. Another advantage of this approach is that it produces interpretable results in the form of the locations and severity of anomalies, which can then help the engineers to understand why our solution believes that the test is failing and be able to respond accordingly to that. So here's a quick overview of the design of our system. We begin by taking the simulation outputs from the closed-loop bench and performing a pre-processing step. This pre-processing step prepares the data for use by our model. And we train our model using the data from the CLB to model the temporal relationships between different signals so that it can understand what normal engine behavior is. And then using the predictions from this model, we can then compare the test runs to the predictions and then find sequences of high error where we can identify anomalies and raise those to engineers so that they can use these results to improve their engine controller designs or figure out why the test is failing. And we also provide an interface for engineers to provide feedback to our tool to help improve the accuracy by reclassifying incorrect predictions. So in our pre-processing step, we apply a number of transformations to the data to prepare it for learning. These transformations include feature scaling, padding, and some data reduction techniques. Feature scaling normalizes the input feature weights so that we can avoid assigning disproportionately large weights to signals with large values. Padding variable length time series data into fixed lengths provides consistency and makes the learning task simpler for our model. And then the data reduction techniques are meant to address the large volume of data that we have. It's very difficult for us to process all of the data, so we make some trade-offs where we select a set of signals that we are considered to be important, and we also reduce the resolution of the data. For our machine learning model, we chose to use a long short-term memory network, which is a kind of recurrent neural network that is capable of learning long-term dependencies. This property of long short-term memories makes it ideal for tasks where you have events that are related in time but are separated by an arbitrary length of time. And so it's useful in these cases as compared to traditional recurrent neural networks and other sequence learning methods. We train our LSTM, our long short-term memory, to learn what nominal engine behavior looks like based on the signals. And so the idea is that given enough data from a diverse set of test scenarios, the model can understand the relationships between the signals over time in the normal engine behavior. And this has the potential to generalize for new test cases that haven't been seen before if they exhibit similar behaviors and relationships between the signals. Using this LSTM, we can take new test runs and process them
so that we can use, at each time step, make predictions about how we expect the signals to change over time. And then using these predictions, actually these predictions represent what our model believes a normal engine would behave like. And so this also produces some level of interpretability for engineers so that they know what the model thinks the engine should behave like. Using the signals from the test run and the predicted signals from our LSTM, we can then perform some dynamic thresholding on the error to see when the test runs deviate significantly from the expected behavior. By finding sequences of high error, we can identify anomalies and raise these to the engineers to show them where we believe that there are anomalies in the data. The dynamic thresholding technique that we selected was from a recent research paper that we found. This thresholding technique uses some error smoothing to reduce the spikes that commonly occur when using LSTMs to make predictions, and also includes an anomaly pruning step which reduces false negatives. We provide a user interface to the engineers that use this tool to show them graphically where the anomalies are and provide insights. And this interface is also where engineers can sort of select different test cases to train on, to test on, and also select different signals. The reason we decided to give this ability to the engineers is that given our limited knowledge of the data and limited access to labels, we wanted to see if the engineers at Avia could, using their domain knowledge and understanding of the data, experiment with the tool to see if they can improve the accuracy based on their knowledge. Before we arrived at our solution, we considered a number of other solutions. One of the potential solutions that we considered was rule-based methods. Rule-based methods are ones that use, that assign sort of acceptable ranges of values to different signals. This could be on the actual value of the signal or the rate of change, or it could change over time. And these kind of approaches detect anomalies in the time series and can provide some level of interpretability by showing what kinds of rules were violated and where those violations occurred. Disadvantages of this kind of approach were that it requires us to have some understanding of what the signals actually mean, which we did not have, and also that it's difficult to program these kind of solutions to understand relationships between different signals. But some of the advantages are that it's actually a lot simpler to implement, and that it's relatively cheap for the computer to perform these computations. When we experimented with this approach, we had some difficulties with events in our data not being aligned in time. This kind of thresholding approach is very sensitive to small time shifts, especially in signals that change very rapidly. Other approaches we considered were feature-based methods, which are very common. Feature-based methods use feature extraction, which transforms the time series data into a set of single value characteristics. So for example, some of these characteristics could be things like the linear trend of a signal, or the maximum value, or the number of peaks. And this kind of feature data can be used with traditional classification techniques like k-nearest neighbors and other kinds of neural networks and SVM. In our case, the labels for the classification would be whether the test is passing or failing. And so we explored some of these techniques, but we had difficulty getting it to perform well because of the shortage of pass or fail labels that we had. Another challenge with these are the low interpretability of the results, in that it can tell you whether it thinks the test is passing or failing, but not provide any insights into why. From our challenges with classification techniques and the shortage of labels, we tried some clustering algorithms. The idea behind this was we thought we might be able to group similar test runs and have engineers label entire groups as passing or failing, and also show some tests that are complete outliers. This was meant to address the lack of labels, and we tried implementing this with a couple of different algorithms, but were not able to produce useful results.
So now we're going to talk about some of the outcomes of our projects. So we have delivered the solution to the client, and they were since then able to use it. We received feedback from the client regarding the accuracy and usability of our solution. So we iterated on that feedback to improve our tool. The feedback has led to various improvements, such as more configurability on which signals to train and test on. We also made some various UI changes to improve general usability. We also added more information to the results provided to the engineers regarding the predicted values of anomalous signals. As this project was more of a research opportunity, not only will we be providing the solution, but we'll be providing all the documentation and research about the steps taken so far, and our analysis of conclusions that can be made in future steps following this project. So I think here are some things we learned from our project. We found that researching took a lot more time and effort compared to the implementation, and that is because research papers and techniques required a lot of prerequisite knowledge before being able to understand and implement them. So reading a paper would come up with a bunch of terms that you had to read up other papers for, and this would continue and so on, and took a lot of our time before doing. We also found that research papers were often very domain specific, and their results were difficult to reproduce. Finally, we found that experimenting with machine learning and artificial intelligence techniques is a very, very time-consuming process. This is because one execution of a particular algorithm could take between several hours to a day to set up, train, and then run the algorithm. If you have to make several modifications to an algorithm, the iteration process would take up much of your time, and it would be hard to plan time accordingly around that. So that concludes our presentation, and we can open up to any questions.
Excuse me? Yes. So you guys given another term of doing the similar, the same project here. What kind of improvement you are thinking about? What kind of things that we need to provide to you to make the job much easier?
Yeah, so I think that if we had greater access to the pass or fail labels of test cases, there are more kinds of solutions that we could have explored. Or even if we had, say, for example, labels of different activities that happen throughout a test run. So for example, if we could label different phases of some test with what activity is happening, then if we could divide those into phases, we could try to classify each phase and see if we have like some sequence of activities, does this represent like normal behavior or some failing case? That kind of solution could be interesting. It could also address some issues, like, for example, if you had a test case where it was okay to have some anomalous behavior at the beginning as long as it eventually resolved itself, our current solution might not be able to work with those kinds of test cases. So if you could have some contextual understanding of what is happening in the test, then that would be helpful in helping the tool to work with more diverse set of test cases.
So you said that you didn't use the problem as a classification problem because you didn't want to consider labels of pass and fail. Is that true?
Right. So in the end, we do provide a label of whether we believe the case is passing or failing, but that's at the end, which is combining our two steps, which is using the LSTM to make the signal predictions, and then the error thresholding to find anomalies. So if we detect anomalies, then we classify the test as failing. And if we don't detect any anomalies, then we classify it as passing.
Okay. So your approach is not clustering. Where is it?
Sorry.
Let's talk about it.
So our approach
Clustering.
makes use of anomaly detection techniques instead of directly trying to map the data into a pass or fail label. So we start by
so that was your initial attempt.
Right.
And
Some of our previous attempts with the feature-based
okay.
methods.
And then you sort of focused on, okay,
Yes.
now we have to do this labeling that threshold. Now, which brings up the next question that I had. How did you come up with that error threshold? You talked about the rule-based method. So what was like that thresholding? How did you come up with that?
Rule-based methods.
Yeah.
So some of the things we tried were just like finding, like using all of the data, finding acceptable, like statistically acceptable ranges, like within some number of standard deviations, or some where we would take like the first derivative of a signal to see like the rate of change.
And you already knew that whether that data is labeled like.
So in order to apply those kinds of techniques effectively, it would be useful to have some understanding of what the signals actually mean.
And you have that information. Yeah. Okay.
Any other questions?
So you mentioned about that the training process taking like hours to days to complete.
Right.
Is there any method or approach that you have in your mind that maybe you can try it out next time that will be shorten the training time?
Shorten the training time? You could increase the amount of hardware that you have to work with. That's one way to do it. Other kinds of techniques are if we had more knowledge about the signals or more amount of labels, we can do some more scientific based feature extractions. So like understanding what signals actually affects the result. So we could select a smaller set of more important signals.
So that's the approach that you had to select like features. Didn't reduce the training time, or?
It did, but we could potentially reduce it further. The set of signals we used was one that was provided to us by NVIDIA.
And that's only the set of signals that we use for output predictions. So we use all the signals available in the data in the mapping of as the input mapping, and then we produce a model for each output signal that, well, I guess that the engineer believes is an important signal. But if we were able to do a reduction on the inputs, there would be a reduction in the amount of data feeding into the model. So potentially
That would be another way to reduce the training time. Yeah.
And with respect to adding more hardware, specifically since we do a model for each output signal that we believe is important, the model training and testing could theoretically be parallelized across different machines, just as an example how additional hardware would be used to use the different solution.
Okay.
All right, thanks very much, Team Runway.
Thank you.
All right, and thank you, Avia. Thank you for coming out.
Nice to meet you.
Yes, likewise.
And this project that we have going on right now,
Yeah.
we actually are interested to continue with.
Okay, well there'll be
another capstone team. If
yeah, there
any
is
recommendation.
So the next crop of students start their 4th year in May. And so we can propose this to them, and maybe another group will pick it up.
Do we contact?
Yeah, so you can correspond with me.
Okay.
Patrick Lamb will be the instructor, but I'll connect you.
That would be great.
Yeah.
Okay.
Yeah.
Very nice to meet you then.
All right, likewise. Thank you.
Take care.
This is a great opportunity, so much technical depth here for the students to work on, and it's so great to see the software students connecting with engineers in other disciplines. You know, that's a thing that we really encourage. So we're thrilled with the opportunity that you're providing.
Yeah, we're excited with this project as well.
Yeah.
We're very excited with that.
Thank you.
Thank you.
Thank
Yeah.
you.
Derek, how are you?
Yes. All right, how are you?
You're busy. Do you have a few minutes?
Yes, let me
Take a look.
just start this. I gotta press the start button and say go,
Okay.
and then I'll run out.
All right, so
Yeah.
we are in the lounge.
Okay.
Andrew is already there.
Okay.
So we're just giving them an overview, but
Lovely.
it would be nice to
Yeah.
have you in.
Perfect. Thank you.
Okay, I heard that.
Yeah. Okay. Great. Okay, Gabrielle, thank you so much for coming.
Welcome. Thank you for inviting me.
Yes, and you brought a coat.
This is Carly. Hi.
Hi.
She's from Co-op as well.
Excellent. Yeah, so I learned a lot about the student experience from this project.
Yes.
So yeah, so I'm glad that you're here. And so in my email it was probably too perfunctory, but don't take it as like, oh, here are features that Waterloo Works can add. There are a lot of things that cannot, for either technical or social or organizational reasons, be added to Waterloo Works, but that are important aspects of the student experience. And so that was eye-opening for me, and I hope that they communicate that effectively, because I've sort of had to push them on that at times. I'm like, okay, look, when I was a co-op student, we threw paper in slots, but you know, like, look, there's new software, and why isn't it doing the job? And then eventually, I think I understand that now, and I hope that we'll see that clearly communicated in the talk. Yeah, so this is Gabrielle and Kylie? Carly, sorry, from Co-op. And I think Chantel is going to be watching remotely. So she's alum from 2016, I want to say. And she's been involved for a couple of years, but she has a really bad cold today, so she couldn't come to school and cough on us all. So I will start the recording. And, oh no. Okay, success.
Awesome. So we're Tim Fergus, and we're here to present UWGMs, which is a job application management system made for Waterloo students. So 19,800 students participate in the job search every year. So co-op process is obviously a very prominent problem among Waterloo students. Our inspiration for this project mainly came out of our own frustrations with using Waterloo Works and job mining over the years. I'll dive into more of the specific problems with Waterloo Works later, but to manage applications each term, some of us usually made like a spreadsheet that looks like this on Google Sheets. So it's color-coded based on status, and you can see a lot of information like number of positions open, location, date applied, and any interview notes we might want to leave with the number of rounds. So this is just an easy way for us to track all the information related to our applications. And in addition, we know that a lot of products out there like Weaver exist for employers to track information on and status of applicants, but nothing exists that we know of on the applicant side to track our applications. So as mentioned before, there's a lot of issues that we encounter using Waterloo Works. So this is what your applied page on Waterloo Works will look like. So this is most of your applications. You can see most of the data is here. You have the title, company, your current application status, and location. But the issue with this grid is that this information is static, and it's not always accurate. For example, with the status, employers oftentimes contact students outside of Waterloo Works to schedule interviews, And if they do that, the status isn't reflected here. So you can see that it says selected for interview if you have an interview arranged through Waterloo Works, but if it's not, your status will stay applied. So it's not always representative of your current state in the job cycle. On top of this, you can't really add any applications. If you decide to make applications outside of Waterloo Works, you can't really add that to your grid here. So because we don't know, a lot of employers contact students outside of Waterloo Works, students often resort to Reddit. So every term there's this very popular megathread on Reddit, Waterloo subreddit, called Waterloo Works Megathread. And people normally post here when they've received interviews or coding challenges from companies. So for example, here you can see that there's aggregated information. So somebody just took all the information that anybody posted on this megathread and made a list of all the companies that handed out interviews, regardless of if they were through Waterloo Works or outside. So as somebody applying to one of these companies, you can see that if somebody else got an interview or contacted by a recruiter outside of Waterloo Works and you weren't, you can kind of maybe guess that maybe you won't be contacted, and you can kind of write that application off. So in addition to, I guess, Waterloo Works not being able to provide the customizability to manage your applications, they also don't provide a good guide for where you should apply to given where you are currently in your academic timeline, or how to what to maybe expect from interviews. So here you can see Reddit. People on Reddit are seeking help for figuring out what type of questions they ask and what they can expect from interviews with a specific company through Waterloo, because our interview processes are oftentimes different. In addition to the previous problems, there's also a number of missing features, like we don't have the complete interview schedule since some of our interviews are scheduled outside of Waterloo Works, and we can't export to Google Calendar by Calendar, for example. We don't want to use Waterloo Works as our primary calendar for this kind of stuff. It also doesn't provide a good visualization of your application lifecycle in terms of how many applications you have with each status and how it integrates into your academic timeline. So basically, you can only see your applications for your current term, and then all of your applications in your previous terms are all in just one gigantic grid, and you have no way of knowing what term they belong to.
So for our solution, the first part was an application board, which was a centralized place for students to manage and track all their job applications. It's like with an intuitive drag and drop interface to move things between different statuses. We supported importing from Waterloo Works, so you could copy and paste your apply page into our application. And we also allow manually adding external applications for anything outside of Waterloo Works. We also supported recording interviews and other information, so we'll get more into later. We supported separating into different boards, so you can have one board for maybe one type of job you're applying to. For instance, you might be applying to some project management jobs, but also some software development jobs. And you can have one separate board for each to easily keep track of which is which and group them together. Additionally, it lets you keep a history, so you can have your 3A co-op term applications in one board and then your 3B co-op applications in the next one, giving you a nice history to look back on. The next part of our solution was interview management, so a centralized place for students to track all their job interviews. This supports calendar export, either via iCalendar or Google Calendar, and if you add or edit any interview information, that will stay synced with your Google Calendar as time goes on. So it's a very easy way to avoid missing an interview or having to check multiple different places to find your information. So we also were able to leverage the community to a great degree. So the first example is we were able to use user data to drive some helpful statistics. These stats can help students make better decisions with their applications. For example, with Facebook, there's a lot of applications throughout every co-op term, but only the upper year students tend to get interviews or job offers. So this could help show first year students that maybe their time and applications are better spent on other companies. There's also company discovery, which is people also apply to part of the image. And that's very helpful for if someone worked at a small company and they want to find similar ones, we'll give them a list of those, which will be help students find these companies they might not have otherwise that they couldn't try. So all of this is designed to help students make informed decisions about what their application is. Additionally, we have interview reviews where people can leave notes on their interview to help others prepare. So this has a lot of the information you see in the mega thread, like the number of rounds, whether they're technical or not, and maybe the kind of questions, but we discourage the specific questions because that can be unfair. So the goal of our product overall is to streamline the co-op job applications process for University of Waterloo students. So it's a student-led product, and we felt like it had to be a side of the Waterloo administration because we want to be able to encourage or discourage certain job applications. Like, for example, the 1B Facebook being advantageous. But it's sort of like a bad idea, or maybe it doesn't sit well if SECA was like, you shouldn't apply to Facebook.
So we kind of want to walk through a user story just to give an idea of how we expect users to use our application, or how we would hope they could use our application, and how it could help them. And so we'll tell it in the perspective of a student applying their 2A terms, so likely their second co-op. So while applying, they can do some company research. For example, this is the same screenshot as from earlier about the statistics with Facebook. And so they can see that if they're in their 2A term, a lot of them apply, but not a lot of them get interviews or offers. And so if they're on their last few applications, they can probably direct them towards somewhere they're more likely to get interviews for. In addition, if they're looking at smaller companies, they can use company discovery to find other similar companies that they might enjoy or want to apply to. So after finishing applying to all the companies, they can create a board for their current terms of 2A, and then import all of their, so they can control all their applied page on Waterloo Works and import it through this mobile here, and then it'll populate the board for them. In addition, they can add external applications as well to the board with anywhere they've applied outside of Waterloo Works. And so let's say they go through the process and then they receive some interviews, in particular an interview with Google. They can open up their Google application and add a Google interview here, and also track any notes that they might want to leave, like recruiter contact information, or how many rounds, or if they're scheduled for how they plan to prepare, pay or location, or just really any other details. So they can populate, by adding interviews to your application, they'll populate your interview schedule here, and they can choose to export it to Google Calendar so they can keep track of their interviews. In addition, while they're preparing for interviews, they can look through the interview reviews for companies that they're about to apply to know maybe if they want to prepare for technical interviews or non-technical questions, how many rounds in person on campus, and data like that. And then they can also add interview reviews of their own to help future students that will be interviewing for the same company. Finally, when the process finishes, they land a job, and then their final report will look like this. So they received offers from a few companies, were rejected from a few companies, and then also just their applications went into a black hole. No idea what happened to these companies on the apply page. And then they can keep this board for future reference whenever they are in future terms and want to look back on how this process went. So we don't intend to be an alternative net per se for any existing products. We can't really replace Waterloo Works because that's where you apply. But we kind of took pieces from all of these products that we thought, with features that we thought were useful to us, and consolidated them into one product and tailored it towards Waterloo students. So with Waterloo Works, there wasn't a lot of flexibility in changing a lot of information and adding external job applications, so we allowed for that. Google Sheets is a very manual process, and both Waterloo Works and Google Sheets don't really help students figure out where to apply or where might be a better idea for them. Also, Google Sheets there's no bulk import, and it's also kind of hard to use because you have to populate everything manually yourself. And then students often turn to Glassdoor for interview reviews to see what kind of questions they were asked for similar interviews in other places. But Waterloo-specific processes or interview processes are oftentimes different than what you find in Glassdoor, because their interviews are sometimes through Waterloo Works and have a shortened process or maybe sometimes a longer process. And so Glassdoor mostly just has, or I guess mostly use it for interview reviews, but we decided to take that aspect of it and work it into our product. So we crowdsourced information from our peers and just asked them to add any application they remember applying to based on their Waterloo Works history to help us collect some data to begin with. And then also asked them to write some interview reviews for companies that they've applied to previously. So we launched our product to students in the lower years while they were going through the application process earlier this term through Waterloo Works. And the feedback we got was that they really enjoyed the functionality. So they love the drag and drop mechanism and the visualization of the status of their applications. And how customizable it is in terms of being able to add external applications and having everything in one place where you can see it all. Where we got negative feedback was that all of our information currently right now is heavily biased towards upper years. So that's most of the people that we asked to help pre-populate data with. And so because we have less data, a lot of it's just more kind of inaccurate or less representative of the bigger picture.
So we used a wide variety of technologies for building this application. On the front end, we had a separate front-end, back-end architecture. And on the front end, we had React and Redux using TypeScript bindings, and Design, which is a component framework from Alibaba. And it's all served on AWS via CloudFront over S3. Our backend is written in Python using Postgres as a database. We have some web framework or web servers Tornado. We're using SQL Alchemy for queries and SendGrid to send emails. All of this is hosted on the backend. So we deal with a lot of sensitive information. So we have to take privacy and security seriously. To us, part of this was obscuring the exact values of company statistics. Instead of showing that like one person got a job offer at Facebook, we would just show sort of approximate value to avoid people knowing exactly who it might be. We had to ensure that interview reviews were anonymous to other users and not to us, like for moderation purposes. We handled auth very delicately. We used bcrypt and JWT to figure out who the user is and make sure that you can't impersonate someone easily. The other side of this was password resets. We had to make sure we're secure. We used an email reset, which is safer than, say, recovery question. It can often be easy to guess by others. We also ensured that the calendar exports weren't easy to enumerate. For example, you couldn't find your calendar link and then change it some way to find somebody else's introduced calendar. We also protected the database to make sure that only a few select members of the team had access to it at all, and that no one in the general public or the developers in general could see it, just to decrease the odds of anything happening. We had immutable company information so that people couldn't change company information, like details and maybe vandalize anything like that. Security audit I did to make sure that everything was like, there were no vulnerabilities to enumeration or any of the aforementioned things. Like, for example, when you're viewing your board, it'll show you an ID in the URL, and the idea is that if you can't change that ID to another number that's similar, and find someone else's job application board. So in retrospective, we did face some challenges. The first and foremost one was that bulk importing was very finicky. Depending on Waterloo works and the specific formatting of that applied page, which often changed. It changed a couple times on us. So it wasn't very consistent. A lot of change. You have to like, you see something's not working anymore, and then you have to look into it and find out exactly what changed and how the new meanings of everything are, which took a fair bit of time. We originally wanted the reviews and statistics to be per job instead of per company, but it turned out to be very difficult or impossible to consolidate that. It's a hard problem in general, and it became even harder because between co-op terms, the actual job IDs internal to Waterloo works would change. So our choice was either to guess which jobs were the same, using some approximation, or just putting it on the company, and we chose the latter. Users wanted to keep a history of applications, so this is what introduced us to the idea of having boards, where you have one board for each co-op term. So we ended up doing a whole redesign of the UI to use this new board architecture, which was very well received. Frankly, we wish we'd launched earlier to gather more information, more data, more feedback. But that was just a matter of we were dealing with whatever was changing and just finishing everything up with the design. So in the future, we plan to open source it so that the users can help maintain the product. This is most likely to be for purposes of the Waterloo Works format changes again. And we'll need to be adding some flagging and monitoring mechanism to protect from bad interview reviews or company details from the companies, just to avoid any kind of vandalism or inappropriate content. Thank you for listening. This is the summary we'll talk about, and take any questions.
Hi. So really interesting project. I'm just wondering, how many people have tried this so far?
We first asked our friends to use it and then brought it on to learners who asked more people. So we would say we've collected feedback from around 30 people.
30? Okay. I do have a few other questions too, and I don't know, things may have changed from when I was working in co-op, but you talk about students using Waterloo Works and then also searching for jobs outside and the inability right now to customize things. So as far as I was aware, upper year students had to choose whether they were going to use Waterloo Works or not. And so if they decided they were going to arrange their own job, then Waterloo Works would just be out of the picture. Has that changed, or?
Yeah. As far as I know, in the last co-op cycle, the interest changed. You add one external application if you received an offer from them, and go with that versus your other Waterloo applications.
Yeah, if I recall correctly, you had to decide by the ranking period or approximately then, but people would often, even before that, have external applications, and if they got an offer, then they would contact SECA and try to get it sorted out.
Okay. And do you know like the time requirement? Because especially in first year, we already have a problem where students dedicate so much of their time to searching for jobs that their academics get neglected. So do you know the amount of time they would be potentially spending in this as well?
We hope to reduce the time overall. It would be hard to measure the exact effect without doing some sort of study, but the idea is that by helping them make smarter applications and applying to companies that would benefit them, they could spend less time preparing for these sort of far-fetched interviews that they probably wouldn't get anyways. So we hope it would reduce time, but we haven't done any studies.
I guess one final question. This is kind of pessimistic. So with co-op being so competitive already, like, do you get a sense that a lot of students would want to use this and, in a sense, offering advice to other students who potentially, increase their chances of getting a job and decrease?
Yeah, there definitely is a huge element for us. Like even based on our statistics, somebody can create a whole bunch of applications which are based on just student statistics. So a lot of it definitely relies on our limited model rate and then also our trust in our users. And then also can easily mug interview reviews by saying it's the biggest thing on the planet and you talked about absolutely nothing the whole time when it really could have been like a really technical interview. So those are definitely problems we're aware of. But we're hoping to kind of make that less of a problem with motivation.
So do you guys, is there a way of vetting whether or not these are authentic students and it's not just, Joe Blow making up a fake profile and writing a bunch of incorrect information?
I mean, totally around the idea of is there a pass for authentication?
We just want to kind of separate our application from the school to make it emphasize the fact that it's a student-led product so that we can leverage the idea that we're using the Waterloo community to drive things like statistics and interview reviews. But in terms of how credible users are, that's definitely something we have to somehow moderate.
Those are my questions. Thanks.
Thank you.
In terms of thinking, so as you talked about the data piece on the employer end at the end, does some of that data come from students dragging and dropping a job all the way over to the hired category? Yes, this is sorry.
Yeah.
Okay.
So we gather all that data from them.
Okay.
So if it's in the interview column or if it's in the offer column, we can assume that they've got an interview, or if they drag it into the rejected column from the interview column, then we can assume that they've got an interview.
So really it is true crowdsourcing in the end and trying to make students go back and finish their application. So similar to the challenge before that within Waterloo Works that maybe statuses don't change. You want everyone to use this to change the status appropriately so that students in the future are happy.
It needs to be the same problem from a different perspective.
Yeah. That's all for me. Thank you very much.
Thank you.
That's great. Where did you come from? There's another place I'm not actually their instructor, I teach the other, another course. Anyway, their instructor will be here in a little bit. Thanks for coming.
A lot of power.
It's not terrible. Okay. 2 days.
Wait, is it Chris? Excuse me, I forget your name.
Simon.
Oh, Simon. So, I'm just looking at the list of referees. XM Spam, is that?
Yeah, that's me.
Okay, great. So we're looking for Derek and
also David
Murdoch. Yeah, he's around.
They're expected to be here.
Okay.
Yeah.
But is he like? Is he from? Is he one of the staff?
Murdoch's a grad student here.
Grad student. Okay. All right. We'll wait for them, I think.
Yeah, no, they should both be here. I know they took like a small break because there was like a big gap between the last time.
Yeah, Derek's just talking to some Oracle visitors right now.
So we're just waiting for the other two.
Yeah. Derek will be here soon. He was just talking to some visitors. Oracle.
The hours.
He's listed as one of your referees officially, so he should be here. She just left.
David.
And David.
Yeah.
Both, right?
Yeah.
David's a grad student, is that?
Grad student, yes.
So, should I be here?
Well, I don't know. You can bring like Derek, I guess.
Yeah.
Maybe. Sit far enough to not see this.
Yeah, the other copy of it.
Yeah, and you can
Success. So Derek will be a couple of minutes. So he said you can start without him, but it would be nice to have Dave here. So anybody have a number for him?
Yeah, I do.
That'd be great. All right, I gotta fiddle with this.
So I shot him a message, but no reply.
Let's give him another minute. We got a little bit of a buffer. Worst case, I guess you can watch it later. Alright, well at least you've communicated with them, so I think we should probably get going. Derek will be here shortly.
So,
talk to Simon.
So good afternoon everybody, thank you for coming. My name is Victor, and as part of the global mapping team, today I'll be talking about our project, some of the design decisions we made, and some of the trials and tribulations we faced along the way. But first, a bit of background. So for this project, we've been working together with Autonomous, which is Waterloo's self-driving car team. The team is currently competing in the SAE Auto Drive Challenge, and the competition is currently in year 2 of 3. So what we've been asked to do is to basically make a subset of what Google Maps does. So since this is a multi-year challenge, the way the competition is structured is that each year they provide a set of challenges that the team is to achieve. So for our specific problem, in the first year, the goal to achieve was to find a location on a map given an address string, whether it be a numbered address or a point of interest or an intersection, etc. And for year 2, this year, the goal was given 2 points, find a route between them. And the ultimate goal of this is that next year, this solution will be directly integrated into the self-driving car so that it can direct itself from point A to point B. So since we're in year 2 of the challenge, you might be wondering what happened in year 1. So we actually had a solution in year 1 that competed in the competition. It actually did pretty well. It got 36 out of 50, which is enough for 2nd place. But despite how well it performed, there were some problems with it. There were a fair number of problems with it, actually. So due to the number of requests, of improvement requests, and our unfamiliarity with the code base, as well as some of the design decisions the previous team took with the solution, we ultimately decided that it would be in our best interest to create a new solution. And with our new solution, we had 3 main goals in mind. First was to simplify the installation process. The second was to improve search results for locations and to improve usability. And the third was to actually achieve the year 2 challenges, so to actually implement pathfinding. So we'll go in a bit more detail about the installation process. So in the previous solution, everything had to be installed manually. One of my favorite lines from the original README was, the applications will require a few tweaks unless you are literally me. So that's something we desperately wanted to avoid. We didn't want there to be this sort of insider knowledge where if you didn't develop the application, you wouldn't know how to even run the application. So our vision was that you run one script and everything would be set up. You wouldn't even have to think about it. But as you know, reality is often different from theory. So in reality, we have one script, and running this script will install all languages, databases, and libraries required to run the program. And it'll also start up the back-end process that's used to perform location queries. Additionally, we have some other scripts that will need to be triggered manually. These include importing data into the database and running the front end. And the reason we do this is because when you import data, because of how large the data set is, it can take hours or days to do it. So it's not something you necessarily want to do every time you just want to install the software necessary for it. And for the front end, again, you might not want to run the front end when you first install a program, so we have that as a separate thing. Next, we'll talk about some of the improvements we made to location querying. So in the previous solution, the way that they determined how a query should be processed is that they use regular expressions to match the query string against a set of predefined options. The problem with this is that addresses are not well defined, so eventually you're going to come across cases where the regular expression will fail. So to help circumvent this, we decided to use a library called libpostal. This library is a natural language processing library that basically extracts the meaning behind each of the words in the query string to more accurately identify what the query string is asking. Secondly, in the previous solution, to find locations, it would go over multiple Postgres tables to find results. We've decided to consolidate a lot of these tables into an Elasticsearch database, and this has several benefits. For one, we make use of Elasticsearch's fuzzy matching options, so in a query string, it doesn't have to exactly match the query string, which will help returning results when the query string is maybe a little bit malformed. Using Elasticsearch also helps us eliminate an odd bug where if you searched for an address with a hyphen in it, it would crash in the original program. So using Elasticsearch fixes that problem. And we've also designed the Elasticsearch indices so that we consolidate a lot of the common tables together so that instead of iterating over each of those tables, you just search over one. Next, in the previous solution, there are certain queries that you can enter that have a lot of possible results. For example, if you're looking for a McDonald's, there's plenty of McDonald's. And what the original solution would do was just return the first one that I found. So we decided to improve the user experience by, instead of just returning the first one, we would give you a list of the ones that we found, and then you'd be able to pick the one that you actually wanted to find. And finally, in the previous solution, some of the data points are actually missing. So the example that we were given, there is a Schlitterbahn water park that was just not in the original data set. So we've done some investigation and we found that for whatever reason, the original solution did not import the required databases or the required tables. So we've gone and added those up. So this is an example of the query results. The main thing of note here is that on the right side, we've added this new bar, and that's what allows us to select the address we want. And finally, we'll go into a bit of detail about our routing. So for routing, we're using Postgres to calculate the routes between it. We're making use of some Postgres extensions. We're using PostGIS, which helps us store geographical data, and we're using PG routing, which helps us calculate the routes between it. So at this point, we currently have a fully functioning system that can calculate routes and display them on the front end. We're using a Dijkstra's algorithm to calculate the route, and we're using estimated travel time on the road as the cost. And the way we calculated that is by taking the distance of the road and dividing it by its speed limit. So next steps for routing, while it works, there are things that can definitely be improved. For one, they support all routes at more zoom levels. For some reason, if you zoom out too far out or too far in, the route will simply disappear. So for most cases, it'll display it as intended, but we want to cover more of those edge cases. And also, the testing of different cost factors in route calculation. So as I said, we're using Dijkstra right now with estimated travel time as a cost, but there are other routing algorithms and other cost factors and heuristics that we can take into consideration to help us calculate both more optimal routes as well as improve the speed of calculations. Because right now, for example, if you calculate a route from Waterloo to Toronto, it'll take like 5-10 minutes. So any way we could decrease that time would be beneficial. And this is an example of the routing. So it's a bit blurry on the system, but I can point you through it. So in this top here, you enter your starting point as a latitude longitude pair, and then you enter your destination as a query string, number, address, point of interest, etc. And then you would click routes, and then it'll draw this line here directing you between the points, and then in the sidebar, that would show you the possible locations in search. In routing, it will display a road-by-road navigation. So it'll tell you what direction you should be heading on, what street name you're heading on, and how long that road is. So we're just going to go over the workflow of our system really quickly. So at first, the user will enter the locations to find the path between, and then the front end will give the query strings to the application server to parse with libpostal. Once libpostal parses the query string, it'll determine what type of thing it should be querying for, and give the Elasticsearch query to Elasticsearch, and Elasticsearch will return the latitude longitude pairs. So now that the application server has the locations of where it should be routing between, it'll actually calculate the routes by giving it to Postgres, and then it'll return that information back to the front end to display. So a question that might not be immediately obvious is, where is this application running? So based on this diagram, you might think, okay, running it on multiple machines makes the most sense. You run one component on each machine. But the problem with that is that ultimately the final solution has to run on a single machine. Since this will be running on the self-driving car, it will have internet access. So we have to be able to store all the data, all the databases, all the backend server on that one machine. So then you go to the other side of the loop and say, okay, we're going to develop on a single machine. But the problem with that is that while the competition computer might be powerful enough to run the system, our development machines are not. The data we're given is about 100 gigabytes of just raw data, so our hard drives couldn't store it, and our processors were not powerful enough. So for development, we had to distribute. So we're basically stuck in this loop where we don't know what to do. So the only real solution is to support both of these options. And the way we do this is we want to make it as simple as possible to change between whether you're developing on a single machine or more distributed system. So we make it so that with just a few configuration changes of IP addresses and port numbers, you can configure how you are running the system. So when we're developing, we have each of the components on a separate server. So we store the data on a Google Cloud instance, which has enough memory and storage that we need. And then we run the front end locally, and they communicate with each other. But during the competition, since everything needs to run on one machine, that is possible. And that is our presentation. To summarize what our solution, we've introduced a new address parser using libpostal. We're using two databases. We're using Elasticsearch for location querying, and we're using Postgres for route calculations. We've Dockerized everything for straightforward deployment, and that also helps us with the question of where we're going to be running the solution. And for development, we've introduced a cloud instance of the data to increase development quality.
So how did you guys test it?
Largely we tested through manual testing. Okay. So we would put in a query and make sure that it returned it for addresses that were through the competition itself. Mm-hmm. It's like anything that was used in the previous one, as well as any things that are more familiar for us. So things like Southern Ontario, so like our home addresses, where we lived before, and stuff like that.
You tested the weird hyphen address stuff?
Yeah, so Elasticsearch just basically just handles this on its own. So it shouldn't just fail like it did before.
That was a great bug to find on competition day. Simon, I'm sure you have questions.
So I'm guessing that a lot of we came up with like an MVP here, and then it happened to work really, really well for the 5 examples that SE gave us. But I was wondering if, it's part of my issue by the way, it's just like, were there any alternative solutions that you would consider? For example, you decided to use an NLP API for it. I remember we had a long discussion about whether it's even possible for Linux to parse all these different addresses. I guess were there alternative NLP APIs other than that? like we're using Dijkstra's, is there like alternative algorithms to consider if it takes 5 to 10 minutes to route between Toronto and Waterloo?
Regarding the NLP solution, so it's an NLP sort of ML solution. It's sort of the only one that I found when I was looking for different sort of ways to properly parse addresses. So there wasn't really any, it was either that or continue trying to use regexes, which just don't really work very well regarding that.
In terms of routing, there are definitely different routing algorithms we can use. So PG routing supports a variety of different ones. So we chose to use Dijkstra for this, but they have A-stars and other options, so that just requires more testing to see which one works well. And we've also considered different front ends to use. So we ended up reusing the front end from the previous solution, but we considered switching to Leaflet because of how much of a hassle developing the current front end is. But by the time we decided, we sort of locked ourselves into a language choice. Since we're using a Python RPC framework, Leaflet, converting everything to Leaflet with those changes already in place takes a while.
I'm kind of curious just about the competition itself. Like, it seems like they're making you reinvent stuff that's out there, right? Like, will cars not be connected to the internet? Like, what's the motivation behind this contest? You know, like you have to do it because that's what they said. Right? So I'm not really questioning why did they choose that? I'm just curious. Nobody knows.
If I had to guess, it's probably because like it's student design teams. It provides a good learning opportunity to students, even though it already exists.
Okay.
Like we all know more about routing software and some of the methodology behind it and the struggles involved.
That's true. Okay. And also, I'm curious, like your address database or whatever you call it. Like, is it just storing the addresses as blobs, and then like I'm curious about how that Elasticsearch works.
So it stores it as like the specific. I have a number of different fields that I've populated from the Postgres database. And it
feels like road name. That
yeah,
kind
so
of
like
thing?
street name, and it would be like. So for example, for point addresses, which are just addresses on the map, it would be you could have the number, you would have the street, you'd have the city, the province / state, and a number. I think I also had a postal code, and you'd have each of those as fields. And then doing the search, I would just concatenate all of the different tokens together that come out of the postal algorithm library, and it would. I do a cross-fields checks that each token has to exist in the specific JSON blob.
Okay. So then that Elasticsearch thing is just an algorithm that works on the Postgres database?
So Elasticsearch, sorry, what?
Yeah, I'm just kind of a bit curious. Like, how does Elasticsearch work, or where does it live?
Elasticsearch is its own database.
Okay.
So it stores, it's basically a NoSQL database that stores JSON, and it supports full text search features.
Gotcha.
That's basically the idea.
Okay. Anybody else have questions? Yeah.
No, I like a lot of the things that you presented, so now I'd like to go to some questions, like dig a bit more into like technical depth. So I was curious about, could we discuss a bit more about the cost function? It's been like briefly mentioned. I'd like to discuss kind of like what we've considered, what are possibilities in the future. You even mentioned like we'll consider alternative cost functions. Is there like a problem with the current cost function? Is that what leads us to consider more in the future?
So for the cost function, we actually started with distance, and then when we had our practice talk with Derek, he suggested to us to use time because obviously if you just take distance, you might avoid highways, which shouldn't make sense. Let's say if you're going from Ottawa to Toronto. So
it's crucially important for the competition. Like the guy who makes the rules said this, that the route involves an escalation of road categories and then a de-escalation of road categories. So you're working your way to the 401, you're getting off the 401. That's what he wants to see.
Right. So right now that we're using time, we haven't really considered any alternative cost function because we feel like this works sufficiently well. And the way it calculates currently, it
have the information regarding the traffic, you can't. There's like no better way to estimate the speed that you will be driving at.
Throughout the you working on this tool, have you noticed some cases of the database itself being dirty? Like this data is like given to us by a competition sponsor. I was wondering if that was exact and if we had to fix something.
So there's a few things that I've noticed about it. One is that it's not actually up to date. So it doesn't have addresses that are after like 2015 or something. So for example, I was looking at First Columbia Street West, and that did not exist as an address in the database. Another couple things is that there's a lot of null values for street names for whatever reason, the way that streets are oriented. I don't know why. Like there are even things that are in Waterloo that should be named in some way, and they just don't name them. So when you're trying to route the unknown road, we don't really know what it is because they're not properly filled.
And following up on the speed limits, when I was going through the database, I actually found that some streets, even though they were valid streets, the speed limit feel very low. So the way we got around that was streets are categorized into types like highways or local streets. So we calculate the average speed of highways and we just substitute that.
I think the weird rendering issue we had like earlier when I went by the booth is probably because of the database, in my opinion. I guess this is like really extra. If no one has any questions, I can keep asking. But I guess like from your experience working on this, how would you suggest about like what's the best way we have to clean up the data that we have? And you know, some of it might not be in like states that we're familiar with. Like you guys picked up the Waterloo ones because we knew one Columbia as an address and we tried to look it up. Is there a way to, I guess, kind of like almost automatically detect what's missing? And almost like, you know, the replacement of the value doesn't have to be automatic itself, but just to kind of like scope out, you know, what's the data set, like data quality.
So there's open source alternatives for, so currently we're using here data. There's also open source alternatives that have also addresses, so we could probably try to correlate between those two databases in order to fill in information that we don't have. I think that's one option. But there's no real, you can't go through it manually because it's just too large. You can't go through it and say,
this specific road is missing its speed.
yeah, just not, it's very difficult to do that. Unfortunately, most of the data most map data is proprietary. So you can't go to Google and ask, can I have all your map data? They don't really provide that to you.
Yeah. For year one, we got 36 out of 50. If we had the actual Google mapping people with us, we probably would have gotten somewhere around 40, in my opinion. The last 10 points, I think, was because they were actually
at least
something wrong with the database.
At least some of them were because we were missing stuff. Remember, because we went back and looked.
Yeah, but there was a team who managed to get 50 out of 50, and it was a real mystery how they got that. I'm like very leaning towards they definitely modified the database.
I actually did check for missing streets, there's no addresses that are missing, because point addresses don't actually have streets, so you have to cross-correlate. They have to do a join between the two tables. I checked, there's no, at least in the Canadian data set, there's no address that is missing a street that is null. So there's no, that doesn't produce an issue, it's mostly due to in routing that would be an issue. You'd have unknown street that doesn't know what you're trying to do.
So do we have a plan moving to the competition? That's what I want us all in the room here to, you know, the outcome of today to be.
So currently our routing is fairly slow. So one of the worries is that if there's a large, like say you want to go across America.
Yeah, there will be questions like that.
Probably will be. There probably will be. So that probably won't finish in time.
Yeah. So Dave, who runs the competition, those are his questions. It's like, I used to live at this place in Indiana, and my in-laws were in Texas, and so I'm going to ask you to go from where I used to live to where my in-laws used to live. Or I happen to know that there are 2 bars named, you know, Margaritaville in Key West, and so I'm going to give you that as the ambiguous specifier.
One of them was in Key West, and one of them was in like Vegas or something.
Right. Yeah. So he's lived in a bunch of places in America, and he's going to ask us questions about those places, and they're going to be far apart.
So that's one of the things that our solution falters on. I have ideas on how to fix it, but we need a little bit more time in order to fix it.
Yeah, well, competition's first week of June, is it?
Something like that,
Yeah.
So it's like May 29th.
Right.
One other thing is that we need a computer to load it onto. It has to be large, and it probably has to have some kind of OK processor.
Right.
Something that has multiple threads would be nice. Not so much for the actual application, but for, especially for loading data, it can be fairly slow if it's not a good machine.
That's not the kind of thing you could throw a GPU at, is it?
No.
Sounds hard.
It's not really a GPU.
It's mostly, it's mostly just a data averaging.
Yeah, it's mostly just pulling stuff out of Postgres and then putting it into Elasticsearch.
It's mostly just, there's so much of it. None of it's really GPU parallelizable.
Right. This time we'll be in the middle of the city. I think we don't even have to run it on local.
If we don't have to run it locally, then we can put it on the cloud.
Yeah, I'm thinking about only
Where are we actually doing the static runs this year?
It's going to be in some room near city.
Oh, right. But yeah, still have network there as opposed to when we were in the middle of the desert.
Are you allowed to throw multiple computers in the car and have like a local distributed
computing cluster?
You are. There's no rules against that.
But in real life,
You just have to be able to physically fit them and power them.
yeah. So in real life, you don't have enough power capacity to run more computing. So the Moose at a point had this challenge that they needed to bring some laptops in to provide extra computing power. So they could only drive the car as long as the laptop battery could like power itself. So yeah, that's your throttle issue.
So regarding data, because there's so much data, we probably need to start at least a month before loading everything. It's just, if something fails halfway through, you need to be able to rerun stuff. Just have that, some kind of buffer area.
Yeah.
I think that would be important.
Okay, excellent. Thank you very much, guys.
Thank you.
Yeah, you guys can just set up
Once I'm done, all the sheets finished.
Bring them back to Shaw's at the fishbowl.
Got to sign one of the recommended products?
Yeah. So put your name in the box or sign it or something.
Sure.
Because it's really important to me who wrote that stuff. That is very helpful for me in understanding what the stuff means. Right? Like you know, I asked you and Simon to be here because I value your opinion, right?
I appreciate that.
And do these sheets go back to the teams as well?
Yeah, so I scan them and share them. So it's a way to deliver feedback, right? I'm a bit of a feedback. I think that's the educational opportunity here.
Great. Sounds good.
Thanks. So what are we going to do competition-wise? So we got this team, we got the other team. Now you've seen them both a bit. I get the impression that these guys, like on the systems side, are a little bit more sophisticated with the Docker stuff.
These guys got the cloud compute brand. The other team doesn't have that.
Yeah.
They just rely on single cloud computing. So architecture-wise, they're very strong. These guys didn't explore anything other than Dijkstra's.
They seem to both be sort of outsourcing the graph computation to some Postgres plugin, right? Or am I not?
I'm not exactly like sure how that works. They're both outsourcing the parser. Like
The Elasticsearch bit.
Sorry, the input parser, user input parser.
Right.
Which is a nightmare.
We tried to do it ourselves last year and it didn't
Right.
work well.
Yeah. So the yeah, maybe it's foggy in my mind, but I'm sort of under the impression that there is some kind of path routing thing in plugins for Postgres that they're using.
What it sounded like, they said PG routing.
Yeah.
Some PG routing thing between Postgres and Elasticsearch that like kind of come up. Like that.
So yeah, let's try to figure out. You know, are we going to try to merge these two teams? Merge
We're
the
going to make
code?
them both switch to the US part, see the performance on that. And
Okay.
make a decision.
Yeah. Okay. Awesome. Yeah, because maybe, you know, maybe it's A or B, or maybe it's like some kind of hybrid or something, or maybe it's a hybrid.
Generally, I'll try to get them to do a hybrid so that they can both work as a single.
Yeah.
What do you have there?
Maybe it's a hybrid of people with one code base. I don't know.
Yeah, I want them for this.
Yeah.
The challenge now is the scale, I think. That's
Right.
the-
Yeah.
Some assumptions, some heuristic, the scale.
Yeah. I just want us, as the organizational leadership, to be open-minded about picking the best path for us to win, as opposed to like a strict A/B kind of thing. I mean, if A or B is clearly the right way to go for whatever reasons, that's fine. But if there's some other, you know, gray zone, mishmash kind of thing that's a better forward path, then that's also fine.
That's good.
Okay, awesome. Thanks, guys. Okay, so Alexander Kelly is remoting. Yes, that's what he said to me by email.
That's great.
And he asked, I came and talked to the guys earlier for them to send like a poster to him, so he could take a look at it beforehand.
Send us a poster. Okay.
And I haven't checked my email for a little while, so let me do that.
Okay.
And I guess, do you know Alexander? Should
No,
he
I
be
don't know.
connecting with you?
So I guess we're going to friends. Where it is? How do you put these video down? Okay. So that's the board now.
Oh yeah.
These and timeline.
Oh, right.
I'm not sure.
Actually, I think we just fixed the front end is getting all the screen.
Yeah, but only has the title. Only has the title.
Yeah, because the scraping dash only has.
Oh, today like she did?
Yeah.
They were showing me earlier, like the scraping, the Davis and Davis, like getting it. So now it's getting the titles.
Yeah.
I don't know, I guess we should get going. Are we good there?
Yes.
Okay. Let's go ahead so we can start.
Hello everyone, we are the team 1, Habitat team. And our original project proposal is to create a website that supports clubs in the campus to host their events. And then we brought our purpose to not only provide the club events, but also to scrape events from other websites, like for those events that is around campus, to let people discover and see those events happening around the campus, and also create. Also has the club creation and club event pushing functionality.
Yeah, so to expand on that. So last term we kind of only have a page which is only a basic RESTful API, get post code. And this term we are expanding on more events, so not just club events, we're expanding on social events, sports, other events that's happening on campus. And we are actually using a real-time streaming platform.
And our targets, as we know, this is for all students in campus. And for the club's representatives and members, they can have the access to create their own club and post their own information and post their events to our website.
So there are some challenges that we need to focus on from the beginning of the term. So first is to fetch, like, how do we get the source? What's the source for the events? So we figure it's probably better to use a scraping. That's like the best source right now. Maybe later we can add like feed or something like that. Right now we're just doing scraping all the events. We also created
because we fetch all the data from other sources, we need a method to make those data into different categories, so we can add text to tag to those data, and people can see different categories in our website. And we also need a notification system that to notify users that there's new events coming to the website and there are new events that clubs are pushing. And also we need to have a front-end solution that to display those data pushing to the database in real time.
So this is what we are using for our front end. We use React and Redux. Redux is for state management, and React is just a front end library created by Facebook. And this is our back end, and this is where things get interesting. So we are using all these technologies. I think we can show you here in the architecture diagram. So essentially, we are using Kafka for the real-time streaming. So it's a distributed streaming platform, and so the user triggers so there's a few sources for the events. One is scraping. So scraping servers first, it scrapes the external websites, and it gets all the events, and then it connects with the classifying servers, which like adds tag to the events, like social, sports, and things like that. And then it pushes events to Kafka, and the main server subscribes to Kafka, and it will be notified whenever there's a new event. A few things that's worth mentioning is that all the backend are deployed to the cloud. We're using compute engine for Kafka, the AWS for the front end, for the scraping and classifying service, and also the hardest part is Kubernetes. So we actually deployed our main servers into a Kubernetes cloud, so that it's actually scalable, and it enables like load balancing. It also has automatic rollback. And
also we use the Amazon S3 to store our image. So for the front end, they can access the image just by a simple URL. And also we use AWS to deploy the front end. And
so yeah, we essentially use Redis for cache, and that's also hosted on Google Cloud Compute Engine. That's also on another instance. So we use cache to actually store the map of socket.io ID to client ID, so that whenever there's a new event showing on Kafka Stream, the servers can know which site IO actually push the event to in real time. And the MongoDB is just for all the event data. And for the classifying service, we're using Google Cloud NLP API, so it just directly passes the, so it automatically has all the functionality we need. So it just, whenever you pass a string of input, it just returns a category. And that's what we are using. We're essentially mapping the category of Google Cloud NLP to our category, and that's how we implement it.
Now, most of the backends are deployed in cloud, and also the front ends are ready to cloud. And this is our front end UI, and this is some actual pages from UW Clouds. This is a login page. You can see you can choose. This part of functionality is not completely done. Eventually, we want our
we want the user to be able to pick interests, and then we just recommended the top 3 interests in the main page. But that, we need more time at that because we only have 3 people. This is our main page. As you can see, we have essentially 3 tags, one for social, one for clubs, and one for academic. The ultimate goal is to have the system recommend the tags for the user.
And this is specific cloud page for clubs, and you can see this club title, and this is events that push. This is the event image and the description, and events time are all displayed. And you can also follow. See, there's a button you can follow and unfollow a specific club. And once you follow club, if the clubs you're following are pushing the events, you can get the notification immediately through the SECapstone. We also, because we want to have permissions from clubs to use their images, so we contact some of the clubs, and they gave us great responses, and they said they are happy that somebody is doing this kind of platform, and they are looking forward to develop even more features in the platform. And this is some conversation we have with the clubs.
So some of them tried out our website and they think it's pretty good.
Okay. I think
there's actually a few maybe technical challenges that we implemented. So first is the events from the scraping service. So they actually can be duplicated events, right? So we actually needed to hash all the events. So we actually only hash the date, the title, and that's it. We hash the date, and we use that as ID in the database. And that will ensure that it's a unique event. And we also, the other challenge is also using cache to store the map of SECapstone ID to client ID. And so whenever there's a new event, the server tries to find whoever followed the event. So that's the second challenge. And the other is Kubernetes. The networkings are really complicated. It takes a long time to deploy them in the cluster. That's pretty much it.
So you said when there's a new event, it has to go to like alerting the people that are following it? Is that
yes, it's the notification. That's through SECapstone, that's through real time. So whenever the user makes the connection to the server, so there's a SECapstone connection, and then there's a new SECapstone ID. And we actually store that ID and the client ID, the user's ID, in the cache. And we use that as a source to to find whoever followed the event and to find the IP to push the events to.
So your guys' stack must be the most complex I've seen all day. Why did you, so like I saw some of your services you use Google for, so you use Google for NLP and then you use compute. But then you have your front end deployed on AWS, and then you've got Kubernetes as well thrown in there. Why did you choose like Google for that, for what you chose Google for, and like Amazon for what you chose Amazon for?
Because we are in charge of different the deployment. I'm more familiar with he's more familiar with Google Cloud.
That's a good reason.
Okay.
But they're distinct URLs, so
there's
no difference.
There's a specific reason why we need Kubernetes on Google Cloud, because Google created Kubernetes, and it's kind of a natural thing for us to deploy the containers to Kubernetes, to Google Cloud.
And you decided to do everything. Sorry. You decided to do everything containerized, as I saw.
Only the main server. So the interesting part is, if you think about it, only our main server needs to handle all the user requests. So only our main server is containerized and it's pushed to Kubernetes. So all the cache, they're on a cache database, the other servers, they're all on other instances to make sure that we don't have a stake in Kubernetes cluster.
And then I guess the last question off of that is, like looking back, if you could go back, do you feel that like using the different services for what you use them for ended up being to your advantage, or if you could go back, would you have done everything on one platform?
On one platform?
It should be better.
I mean, like the Kubernetes take a long time. If we were to do it again, we probably wouldn't do it. But it does have its benefit, like auto scaling. So we actually have one node or two nodes running right now on dual load balancer.
Yeah.
So that's pretty.
Okay. So you didn't feel that having your services across, or having your things deployed across these different services really hindered you in any big way?
To be honest, I don't think it really matters, because I think even if everything will be on one platform, it will be on separate instances, because we're using like a microservice architecture.
Interesting. Thank you.
Yeah, it felt like with the amount of clubs that you've been involved or tried to help, like you spread yourselves almost really too thin to do something that's really truly effective with just like one club and just satisfying just that and just like what the needs that they necessarily need. Because like different clubs will have different needs, right? Do you see what I'm going with here? I'm just saying that to do something to present, I guess, a UI that's just really effective, that you're trying to serve too many people.
The UI is trying to.
Actually, oh, please, sorry, go ahead.
Sorry, I'm not sure if I get your question, but actually the user needs to log in to see everything.
So then you have like a set sort of like user interface, the standard, or it's adjusted per club.
Sorry, can you go to the?
Well, if we're on press for time,
not really.
Okay.
So this is actually all the clubs right now. And it actually shows all the recent clubs. If I click on the club page, do you have the second page? This page. So you can actually see all the clubs you followed, which is essentially all the events you have. And I don't know if that answers your question. Sorry, could you repeat the question?
No, I'm just saying, like, just having just a general user face. Let's say if you work with, I don't know, the Bible Club, for example, and just you work with them and just print together like an interface that works extremely well for just the Bible Club.
Oh, you mean what, like an interface for just for that club?
Yeah, just for like that particular club, and then replicating that across.
We have like big pictures for each club. I don't know if you can show them.
Like the actual website.
Yeah. We might need to run the
I think like the current situation is clubs do have their own custom rule web pages or Facebook or whatever, right?
Mm.
And they're trying to bring
Put it all
it
in one
together
place.
into one platform that will notify people when there's stuff that they're interested in coming up. So,
which is a great idea.
but you're saying
We
something slightly
should add customization to each club, or allow them to customize their own club. Is that what you think?
Yeah, within this master app,
Yeah,
right?
yeah.
Because it's a brilliant idea, right? Because as it stands right now, you have to go to so many different places in order to keep track of everything. But you've just really solved that problem and putting it all in like one place in itself.
Right now customization, not really, because we don't have the time to do it. But yeah, it's a great idea, and we have actually considered it. It's just the time and resource. We are actually not just doing this for our campus. We are actually want to do this for every campus. So it's like an event stream for all campus thing.
That's also the
yeah, it's also allows.
Now you've done other universities as well.
No. We only did it for our university, but we're planning to do that.
I hope
you can provide backend.
Like I noticed that you added the scraping. Like that's something I think Dan suggested back in October, right? I'm just curious a little bit about the scraping. Like, are you just scraping static pages, or can you cover up all the different types of? Like some clubs just use Facebook, for example, right?
What are you scraping right now?
Right now, only UWFS because it's easier.
Yeah.
But yeah, we have 3 articles scraping UWFS right now. But yeah, we want to add that for Piazza, but Piazza has logging, which is
okay.
What I will say is I like the way that you guys did your deployment. I mean, I know this all happened kind of fast and it was recent, but the way that you guys did your deployment is actually really smart and it looks nice. Because I mean, you're working with things that are containerized, like you said, as microservice. So like, if you wanted to deploy this on another campus, I'm not involved with it, but my impression is that it wouldn't be entirely rebuilding everything. It should be as easy as starting up a new container, giving it a target, and then letting it go.
That's actually one of the benefits of Kubernetes. So if we want more load, it's basically just one command. I just ask Kubernetes to create another replication of the pods or containers that I'm using.
You'd have to make what it scrapes configurable, though, I guess, right? Like right now, you scrape feds, right? So you'd have to have some way to generalize that.
We have a general API to scrape other events, but right now we are just using it to scrape.
Oh, okay.
Somebody would have to still write
general scrape events.
Did you want to ask anything, or you were just here for the next presentation? Okay.
Just a bit ready.
Alright. Maybe can I add something?
Sure.
Not to brag or anything, but I feel like our infrastructure is already like enterprise level. I think so. We are even using Google Cloud Build to build our container. We are using Google Cloud Container registry to host our containers. So we are essentially everything is on the cloud. So that's pretty much all we want to add.
All right, good. Cool. Thank you. Oh, service.
So no demo for.
We will come to you for the demo.
Okay.
So yeah.
Yeah.
Did you want
to?
to?
Just a purely comment. You should do this full time. Like to do this really full time because it would help a lot of campuses like across the country, like even the US.
Kind of a platform to connect campuses as well. Maybe like L'Oreal and UWaterloo, we can connect, right?
All right, thank you guys. All right. All right. Did you see it?
Finish this up?
Nicely.
Yep.
evolved from last time.
Someone, I apologize.
Yes. Dan.
So we didn't get a chance to actually chat.
Oh, it's all good. Are you good now?
Yeah, I get back this one.
Do you have a card or something? I can send you an email with some stuff I got going on. Just say
I'll
hi.
have to say bye.
Or how I can even type it down for us. Yeah.
Yeah, that's the way. F-I. Or 1, 2.
So you're going to use PC?
At Gmail.
Yeah, right.
Email. Right. I'm working with a startup right now, doing like
Oh, that's different.
Yeah, it is a little. Yeah, it is a little different. So we're
different in a good way.
Yeah, so we're kind of pursuing like a new business model, like something to bring like low cost solutions to businesses that are sponsored by.
Yeah, I saw that. That's great.
Company
keep it for
product sellers. L'Oreal, those type of people.
And you
basically sponsoring
you talked to the
booking page of the
other,
system through product sellers.
I thought you wanted to
essentially
make
like
it
advertising.
transparent.
Oh yeah.
Essentially offering low cost software to end users by marketing for.
Also being transparent.
So you're going to offer so
yeah,
also services that give us to help us walk.
Yes, but for a low cost because we're marketing for people who sell.
Okay, so this is almost like customized. Actually,
I'm gonna send you an email
and then we'll organize some things.
Yeah, so tell me what you think. I'd love to meet the CEO.
Sure. So this can finish off this.
Oh yeah.
You guys that?
Yeah.
So, I just want to check with Derek and make sure that Dr. Magwood is connected.
Yeah, I messaged him this morning, but I don't know if you know.
Yeah, so I'll just check with Derek.
Cool.
I think we are waiting for Andrew.
Yeah, to get documented.
Yep. Yeah.
Yeah. What a cool step to. I mean, this is a cost. Yeah, I think he has 1 or 2 periods off per day. Though he has 3 periods a day, that's when spacing suffers.
Is this the time period you guys asked for?
No, I'm just gonna ask for this. Not for each.
All right.
I guess it was the only spot that worked for Dr. Magwood.
Okay. Yeah. Hopefully it's not too important class.
That's history.
Yes.
Really fun things like some angry letters to
Derek, show up here. There we go. Okay. He knows. Show us like in an official way.
Okay.
Yeah, show a file.
Okay.
Yeah, it's sound.
We just need to mark off the 2 grids.
Yeah, that's right. Yeah, 2 grids and then on practice the results.
Yeah. Oh yeah. Okay. We have to circle one of those 2.
Yeah. And in the grid you can like add plus minus.
Yeah.
Yeah, if there's any that you think should be award considerations, just circle the star.
Right.
Or just making, because far they're kind of put together with the regular series.
Yeah. I think you said do a calendars for
something like that. Seems a little looser than that.
Yeah.
Alright. So Eric will be showing up. He did send the email to URL, so I'm just hoping that Dr. Knight would got it. I did tell Derek to come, so.
We're recording the way.
It's recorded either way, yeah.
Okay. Yeah.
Yeah.
I'm waiting for it. Let's see. Okay.
Yeah.
Do you want to
focus on show? Well, we should start, I think.
Okay.
Okay.
3:30. That's fine. 3:30.
Yeah.
Well, hopefully he'll show up some halfway through. Yeah, so this is OpenX. For the past 2 terms, we've been working on this Team Zero, 3 of which are represented here in this very room. Yeah, so it says the tagline here is Spaceflight Simulator, which may not mean a huge amount to a lot of you, but I want to first talk about a couple of things that aren't our product first. In general, simulating space. It's actually something that is very popular to do. Hollywood does it. Apollo 13 is a movie about pretending to be in space. 2001: A Space Odyssey, an older movie, still pretending to be in space, but more fantasy magic-wise. An even Kerbal Space Program is a modern game where you can physically play, very much pretend to be in space with your own ships and fly around space. Importantly, these are all fun, otherwise these wouldn't have been profitable movies, but they're also educational. In Apollo 13 you learn about O-rings and square rings, and coming back from the moon. So there's in fact an entire high school club devoted to simulating space because it is both fun and educational. So Space Sim is a club like this. It devotes every Friday, every week to simulating space. And there are lots of components to this. One way of simulating space is pretending that astronauts are in a spaceship with real electrical components. These aren't real electrical components. You pretend they are. We also pretend that we're actually on an alien planet. This isn't an actual alien planet, but we pretend that it is. The important part for our presentation is we also have software that lets us fly around the solar system and pretend that we're flying around the solar system. This software is called Orbit, and in fact, it was written by the mastermind of SpaceM, Dr. Magwood, who is hopefully watching us on a live stream or on a recording. And over the course of the last decade and more, he has written an entire simulation suite in Quick Basic that simulates the atmosphere of a spaceship, the power grid of a spaceship, and the spaceship flying through the solar system. And it is very familiar to SpaceSim members. It has a huge feature set after having been developed for a decade. But unfortunately, there's only one maintainer, Dr. Magwood himself. And because of the technological limitations of Quick Basic, which we can ask about later, it's hard to continue development on. But Dr. Magwood does. This is the most important part that concerns us for our product, OrbitX. So our goal over the past 2 terms was to recreate the spaceflight component of this simulation suite, pictured here. Because it really is very useful. It teaches grade 9's astrophysics, which is crazy. But it is only maintainable by one person and has technological limitations. So the goal of OrbitX is to rewrite this in modern programming language so that it can be maintained even by members of SpaceSim high school students. So 4 main pillars that we've identified for rewriting this orbit X is, first of all, to have n-body astrophysics, like legacy orbit, to have a maintainable code base so that space members can maintain it themselves, to have it be compatible with legacy orbit so that we don't have to completely rewrite all the components of the large code base that is legacy orbit all at once. And also to make it familiar to users of legacy orbit, but still learnable by new users of the code. And Yujin will go into detail about a few of these.
So before we even start telling you what we have done, we need to take a look at the old physics engine of the orbit and look why we need to change them. So the old orbit engine is quite a remarkable piece of program developed by only one person. So it allows you to control tools, the spacecraft, the habitat, and on the right, Asia, which is a controllable space station. It provides the basic utility for you to dock with stations. It allows you to land on planets, allows you to launch off planets. However, unfortunately, due to the limit of the engine, the physics isn't simulated scientifically. That said, meaning that only the physics is only simulated only the gravity of the sun is affecting everything at the same time. Otherwise, the only object that's around habitat is simulated physically. Furthermore, because due to the age of the physics engine, which is written in QBasic, and because the limitation of all the limitation of the engine, the whole program only have 64 kilobytes of data. So if we want to add new features, we need to remove some. And furthermore, because it's the way it is written, we believe we can use the modern software engineering technique to improve it and to make it more modular and more maintainable. Furthermore, looking at the UI and graphic, everything in the old program is represented by simple circle and shape. The graphical UI, unfortunately, is being reported by myself and many others to be unintuitive and difficult to read, and we hope that our new program could improve on that. So based on that, we developed a brand new physics engine as well as the graphic engine, but I'm only going to talk about the physics engine. The physics engine is based on n-body physics, all formulated into an initial value problem. Later we have, initially we only have the gravity that's accounted for. Later we have we let the whole physics engine handle fuel, as well as landing and docking, as well as launching everything. So this allows us to only have one function that graphic or main function can call, and this all that's and completely decoupling the physics from graphic. Now Patrick is going to tell you more about the maintainability that we come up with. And maintainability of that engine.
Yeah. So this is of course a large pillar, the second pillar that we talked about, Orbit X. It has to be maintainable by members of Space. So there aren't any groundbreaking software engineering techniques that we're experimenting with. These are all very tried and tested common design patterns, things like low coupling and high cohesion between modularized components of the software, object-oriented data structures, and internal APIs between the major components inside our project, Orbit X. This is one of the areas that has suffered, especially over the second half of the project when we're adding new features. In the near future, we are planning on doing some more work on refactoring the code base to make it even easier for new contributors, and not only touching the code base to have that happen, but also to make a contributing guide that will point out in plain English where in the program features of interest will be for new contributors. The third main pillar of OrbitX is the compatibility layer with legacy Orbit. So legacy Orbit, as I have said a few times before, was developed over an entire decade, so it is impossible to rewrite all features of all components of legacy Orbit all at once in 2 terms. So we've only focused on the spaceflight component, but to have our spaceflight component communicate to other components of legacy Orbit, like the power grid simulation, we pretend that we are the legacy spaceflight component. So we can communicate, here we can, this is a screenshot taken when our OrbitX is being piloted. You can see that our throttle has been set to a non-zero value. And this is actually a screenshot from the legacy Orbit GUI at the same time as OrbitX is running. The legacy Orbit GUI can actually read the value of the throttle that we have set in OrbitX, showing that we can tell the legacy Orbit information about our program. And we've also read the amount of fuel from legacy Orbit, and we have taken it and put it into our program. So OrbitX and legacy Orbit can communicate between each other. So we can simply drop in our OrbitX project as a replacement for the legacy Orbit spaceflight component, and everything else will still run with it. That's the plan anyways. So much less work on our part. And the final main pillar is the brand new GUI, which when we started this project last term, we had vague but ambitious plans of completely revamping the GUI to be a completely new experience. But actually, when talking to members of SpaceSim, they found that the legacy GUI was sufficient for most of their needs. It had all the values that they needed. Members were trained on the legacy GUI. So we realized that it wasn't actually worth it to completely revamp the GUI. So we've copied many of the same fields from the legacy GUI, pictured here on the bottom. The text is not important, just the general look and feel. We've copied many of the same fields into our GUI, pictured at the top, and again, the text is not important. We've still tried to make some, in my opinion, significant incremental improvements on this. So in the legacy GUI, there simply wasn't enough screen real estate to fully describe each field. So what does VHAB roughly mean? I'm not entirely sure. So in our revamped GUI, we have more screen space to work with, so we can better describe what each field does with a short description, which you can see on the right, and the user can toggle an extended description for each field, giving them better knowledge for what each field does, but still keeping the same look and feel of the legacy GUI. So these are the 4 main pillars. We've taken pretty much all the main features of legacy Orbit spaceflight component and rewritten them in OrbitX, recognizing that the legacy Orbit has been battle tested by dozens and dozens of missions and hundreds of simulation time hours in the past. We're not quite at feature parity. Even at the beginning of CS4903, we did not think that we would fully replace OrbitX, or legacy Orbit, at the current time. The remaining work to be done in the spaceflight component is, we talked about the contribute guide earlier, so making it easy for new contributors to contribute. And also refactoring the code base to manage the current technical debt. We can go into detail about that later if you have any questions. An atmospheric drag model and autopilot.
in the indiscernible far future, maybe even rewrite other components that weren't served. But as it is, we're pretty confident. Any questions?
Sure.
I have a couple. Some are silly, some are good. So, Dr. Magwood, I guess you've stayed in contact with him throughout this whole process?
Not so much Dr. Magwood. His usual management style is making sure other people can do the work. So I've been talking to members, like high school students.
Okay, sure. Okay, and then have you showed them like your latest version? Like, when's the last time you had to sit down with them and show them what you have?
At the end of last sprint.
End of last sprint.
Yeah.
And so what's the feedback been like? Is it are they thinking we're going to adopt this right away? This is the coolest thing, or are they more along the thought lines that there's a lot that needs to be there before we can really adopt this?
Especially during the early demos, there was a lot of I didn't expect that, and a lot of miscellaneous small issue feedbacks. And a few very large pieces of feedback that they've given us, which is why we did demos early, so we can try and work on those big pieces of feedback. Every indication that I've gotten from members has been that soon, and given that school's about to end and it's about to be summer, I don't know when soon is, they will replace the spaceflight component with OrbitX. Yeah, we'll have to do dress rehearsal demos before that can happen. But I've got an indication that yes.
Cool. Okay. Do you know if your simulation allows range points?
Yes.
Should.
Yeah, I haven't tested this, but it turns out that the physics library we use, NumPy, is fast enough that we can do in-body gravity calculations. So in theory, we can have Lagrange points, which I'm not entirely sure how well the legacy orbit can simulate that, but yes.
Well, legacy orbit, as I think you said, it only computed like the gravity around one body, right? Like the reference body is like the one you're closest to.
Yeah.
Right?
So I think like in relation to Jupiter, it would be Jupiter, the Sun, and then anything nearby Jupiter would probably be influenced by planets.
Oh, okay. So in theory, it could. Yeah.
Yeah. In theory.
I see. Yeah. Okay. I think I had another, but I forget. If anyone else has.
Sure. I've got some. So you're doing n-body physics. You're using a physics engine. So do you have to worry about things like errors accumulating, that kind of stuff? Errors. Like, so you're representing physical values and you're approximating them.
Yeah, I think error in the RC is handled by a band, which is thrown out, which is handled.
Okay.
Small error is handled.
Yeah, we don't really think about it too much.
Okay.
Legacy Orbit did the simple regular method, just like position plus equals velocity times a small time step.
Yeah.
The integrator that we use does Runge-Kutta 34th order. So there should be less cumulative error than the simple Euler method. And Legacy Orbit has shown that it can simulate for years and years and years at a time.
Huh.
So,
all right.
Yeah. But we haven't tested our program for years and years and years at a time.
But currently the orbit that we've seen when with the time we are seeing is pretty stable.
Okay.
Yeah, no moon's flying off in the skies.
I wasn't worried about it. Just frame rate. Like, so early on, you had some issues with frame rates. What was the solution again for getting frame rate up?
Yeah. So trails, which you can see here because they're pretty. Turns out that was by far the most expensive graphical operation. We also did, so that was like a very simple change, just remove them, and then our frame rate went up drastically to about 30 FPS.
Physics-wise, we did a large architectural change to put our physics engine in a background thread. I don't think we've quite got the right mix. Sometimes when a lot of input is put in at once, the program freezes a little. And sometimes when there's very high time accelerations, the program also freezes. So there's fine-tuning to be done for sure. But at least when no one is touching the keyboard.
Okay. Ricky, you guys remember?
No, I don't know.
Anybody else up there want to ask anything? Okay. So landing was another challenging thing that you worked on, right? You want to tell us a little bit about that?
Landing, initially I thought like to put it outside the initial value problem, but then I realized it's like a bit like too slow and a bit more complicated. So instead I just put it inside the initial value problem, but with only like one function at the external that tells it that you have landed.
Jeff Orchard is one of the other referees, and he's very experienced with initial value problems. He teaches the course, and that's how I learned about him.
Could you define that for us real fast? Initial value problem, could you define that for us real fast?
Oh yeah. So yeah. If you can define the initial position of, say, a golf ball, and also define how a golf ball moves, like at first it starts going up in the air, but then eventually it starts going down again, you can find out where the golf ball was at any point in the future, roughly. And the way this is done is through, that's like an initial value problem. It's like integrating
I think they're right.
Yeah. Yeah, but all it really is like there's an initial position and objects have velocity, and over time, according to the velocity, the position changes. So
it's basically a simpler integration method.
Yeah. Yeah, and importantly, it can be done very fast by libraries like NumPy. And it's the core of our physics simulation, but it's also very opinionated on like owning all the data in our simulation.
So you guys more or less just had to define the position, like the state of things and the behavior, and you didn't have to do all the computations.
Exactly. Yeah, so we say where everything starts out,
right,
and we also tell NumPy that things gravitate, and also the habitat has an engine, and sometimes when things hit each other, they stop moving, and then it does the rest.
One code they move when they landed, one code they move when they docked, if they can dock.
Yeah.
So do you always have the initial starting position for everything, like everybody's in the same place in their orbit every time you...
We can define that in a JSON file. The JSON file we're using is from the old orbit.
Yeah.
And this is what you have all the sources things. So in theory, you can just create a new JSON file with some initial values and object with their mass and things, and you can
And in fact, that's what we do for unit testing.
Yeah.
For unit testing.
For test.
Yeah, we just like have a small JSON file with a few objects in it. Check that everything moves correctly.
All right, cool. All right, well, thank you. Hopefully Dr. Nyler heard that.
I hope so.
Saw it.
Yeah.
You guys can get set up there.
The presentation was originally supposed to be so now it's just us. Yeah, Because originally you asked us and we didn't.
Sure. It doesn't matter. Yeah. So maybe. So I think
like just to understand. Is that
yeah. Yeah, there's a lot. Yeah, I know they probably can talk that up. There's going to be a certain segment. It's only way that we got these. There's going to be a certain segment of the are saying about simulation. It's like a non-trivial problem, especially to have it around one time. But there's going to be another segment of the audience. So, what is that? Correct.
Thanks for going with it.
Yeah, sure.
I finally actually saw it like yesterday.
Oh yeah?
I didn't even bother asking.
Oh yeah, no worries. He's back in France in August. He's sure for a shorter treatment. Yeah. Yes, sir. So there's 2 stars. Do they get? There's a technical star. And there's a communication.
I think that's an artifact from Sylvia's. Actually, that's just really asked you for your opinions before they go a little bit deeper when I told you there.
Yeah, sure.
So you saw that number earlier, right? No. Oh, okay.
No, they're
oh, okay.
You just let us know.
Yeah. We started ahead of schedule. Is that bad?
Probably in case of news. Yeah, I don't mind being interrupted.
So, yeah, this is Jeff Baker.
Yeah, we actually came by our stand.
One job, so.
Alright, so here we know what we'll do it for.
And then here's one of Mike Godfrey's residents.
Oh, hey. Nice to meet you. Nice to meet you. Also TA for the course.
Yeah.
Oh, okay, cool.
Yes.
So you look familiar with some of these things.
Yeah. Yeah, I think you guys can go ahead. We're recording.
Alright. So my name is Matthew.
My name is Bogle.
And we created an iOS and Android app called Audacious. So let's jump into what is Audacious. So the overall problem that we're looking at in the world is the fact that we love to express our opinions, and a lot of the times this has to do with food. And we notice that food reviewing in general is very public. It's normally found on public platforms like Google reviews and Yelp, for example. But we wanted to consider the trend of people that might want to keep their opinions more private. So in general, when we look at opinionated tools on these kinds of platforms, we're looking at a small subset. So we're just going to jump into what kind of tools we're talking about.
The first one, for example, is the like button. The like button has, it's a medium amount of privacy. If you're on YouTube, it's pretty anonymous, but if you're on Facebook, it's got your name attached to the like button. Personalization is binary. It's very low. It's just, I like it, I don't like it. And the simplicity, well, it's very high. It's a very generally understood rating level. The next one, that is an opinionated tool we normally see, is something along the lines of a Google review. I know we see it on Amazon as well. The privacy is very low. It's a posted review, but the personalization could be somewhat high. You can get into long paragraphs and add some pictures, whatever you like. And the simplicity, once again, for those reasons, is also pretty fair. Everyone can kind of do it. The next kind of form we have is something like a database. This is for the people that are really into this stuff, and the privacy obviously is as private as you want it to be. The personalization is sky's the limit, and simplicity, sky is the limit downwards. So you can really make it as complex as you want. So our product was some kind of opinionated tool, is some kind of opinionated tool, which promises to maximize all of these categories: privacy, personalization, and simplicity in an app. So we'll jump into a demo so that you can kind of see what the app is.
Alright, so this demo is from my perspective as a user. There are several different user stories that one could have when using this app, but this is how I would use it. I just realized this is reflected. Okay, so I've lived in Waterloo for almost 5 years now. I've spent most of my time in BC, which means that when I need to get food, I end up going to the UW Plaza. The Plaza is great. There are several options to eat at, but the thing is that I always end up going back to the same 3 restaurants, usually Laziz, Chinois, or Shawarma Plus. So I've decided to try and fix that by tracking what I'm eating in the Audacious app. So I'm encouraged to eat at new places. So if I go down to the map tab here, I can see everywhere I've been in the Plaza, which is not in Mountain View, California. Hold on. Sorry, this is supposed to be in Waterloo, but in the emulator it's just set.
It probably doesn't have permissions for location services.
Yeah, that's another thing.
It was working like 5 minutes ago. I guess because we reopened the app with location on, so then it's
I'm just
Google.
I think we're still in. We can take. Yeah, we're still in the West.
Wow.
There we go. That's good. It's very hard on the emulator to zoom. Obviously, a phone is nicer.
This is harder than making the app itself. Well, yeah, basically, I mean, you can see a global map, so if I were to if I did eat in other countries, I would see that on this app as well. So if I zoom in, I can see that there are 3 or so restaurants I've been to in the Plaza, and I think that's an okay amount, but I do want to add some more to my journal entries. So I'm going to add a review for the food I had in Fishbowl today. So if I press the plus button, I can start writing a review. So initially, I'm not 100% sure what I'll rate it, but I guess I'll go 3 stars tentatively. For the location, I can add the DC library. And then did I enjoy my dining experience? I mean, I guess it was free food, right? So it can't be that bad. Free food, I had butter chicken. Butter chicken tasted like 8 months of hard work. And then now I can enter tags at the bottom to stay organized for the future if I wanted to search this review and look at my butter chicken reviews from the past. So butter chicken, and I can add a UW tag here. So once I've added my tags, I can go and add some metrics about how I felt. The price is free, so I can leave that as $0 signs. Food quality is pretty good. Health, I mean, I guess I had a salad, so 5 out of 5. Let's see. Atmosphere, it was in DC, so I'll give that a 1. And images, I don't have any right now, but if I were to take one, I could add one in the future. So I'm going to go ahead and save that review. And now I've saved the review, I can view everything in full detail. I can see it on my map here, and if I go back to my home screen, I can see that the DC bin is added, which is not as the DC library, and I can continue to add pins to my own satisfaction. Hopefully, one day I can have the entire plaza filled out. So that was my user story. There were several other use cases for the app, but I'm going to get into the design process. Okay, so the design process. So basically, before actually getting into the coding of this app, we had to ask ourselves a bunch of questions and try and figure out what we're actually building. So 3 main questions we asked ourselves were, who's going to use our app and what are their goals? This app is marketed towards foodies, and we want them to keep a log of everywhere they've eaten. And we want this to be done easily. How do we add value to the foodies using our app? We want it to feel a bit rewarding, so the map view adds a bit of a completionist aspect to the app, as well as the looking back at previous reviews adds nostalgia and constraints. We had to design one fluid UI that works on both Android and iOS. So we had to account for things like different interactions, like Android having physical back buttons and different headers in iOS and Android, as well as trying to make the review screen with several inputs as simple to use as possible without intimidating users with the metrics and tags and all that stuff we have. So those were the high-level sort of questions that we thought about, and then now when it gets into the actual design process, we use an agile development process starting with Pivotal. Pivotal Tracker is similar to Jira, and we wrote a ton of user stories from the very beginning. Things such as a user, I would like to add a location to my review. As a user, I would like to see my review on a map. Things like that, so that we had an idea of everything. This was great for thinking about all the possible features we can have, but one of the challenges was scoping out what features we can do within 8 months' time. And in addition to that, we needed to know how scalable the features would be, how we should engineer it, should be able to handle thousands of users or just hundreds. And it also helps for role assignments so that everyone can work at max efficiency and know exactly what they're working on. And then next, after Pivotal Tracker, we would design our features using Figma. And Figma was really nice to use because it let us quickly come up with prototypes that everyone could see and then instantly give feedback on. There were comments that you can add in Figma. If you thought any part of the UI looked weird, you can add a comment. I could change it. So this helped with our iterative design process. And if you see that image on the left, we had maybe like 10 different pages of compositions of those sorts of interaction screens. So we thought about all the interactions before actually deving them. Then next, we're getting to Flutter, which is the front-end framework we're using. Flutter's a great framework. If you're not familiar with it, it's most similar to React Native. But I would say that the main difference is that React Native forces you to use third-party components. So React Native, if you wanted to get started with an app, you would have to download a React Native app bar, React Native sidebar on GitHub, something that someone else made. But Flutter natively compiles to Apple Cupertino widgets and Android Material widgets. All you have to do is write one line of code and it'll look different but native to each specific platform. So Flutter was great in that regard, but it was in its early stages of development. We started when it was in 0 point something. We saw it get to version 1.0 release. So that meant we saw a lot of bugs along the way. There was a lack of documentation and lack of support, and we saw live GitHub threads as we were developing. That was Flutter, and now going to Firebase. Firebase was probably the easiest backend we could have went with. It helped us focus on the front end because with Firebase, we didn't need to write any server-side backend code. All we did was we used APIs to write and delete from the database, and it hooked in very nicely with Flutter because of the Google SDK. And then after we made it down to the bottom of the stack, our designs and interactions are never perfect. It's an iterative design process, so we just go back to the top and continue down over and over until we're satisfied. So now I'll let Matthew take the stage.
So let's talk more about the business model of our entire Audacious app. Something that's very important is being able to gain revenue as well as adding additional incentive into the app so that we can maintain users, gain new users, and importantly, host promotions that we're getting from our business partners. So these kinds of incentives that I'm talking about are along the lines of something
called the Restaurant of the Week or the Badge Incentive. So the idea behind the Restaurant of the Week is so that once a week, people that are partnered with us, restaurants in the area that are partnered with us, will promote themselves as the Restaurant of the Week to apply a promotion or just for the sake of exploring a new place to go to, because that is one of the big parts of the app, explore new places that you haven't been to. So when this Laziz Restaurant of the Week pops up, you can make sure to grab your 10% discount featured by them and head over to Laziz and write your review on Laziz. The badges work similarly. They could have promotions underlying. If you were to earn a badge, then you'd be able to say, I'm a badge holder of Laziz, and that means, you know, I get the 10% off that is agreed upon in a day shift. So the badges could be a number of different achievements that apply a fun part to the app, just for users who are more into bragging rights, or just for the sake of adding additional promotion. So an overall view of the business model that we're proposing is that we are going to give advertising and promotional deals to our business partners like restaurants, which can include Restaurant of the Week or badges. And in return, we just ask for a percentage of revenue from the promotions that we host. So if we're hosting a promotion, someone takes it, we would expect a percentage of revenue for hosting it, as well as trademark permissions for everywhere we are. You know, we need to incorporate their trademark into our app, so we don't need permissions. And of course, some kind of legal document stating that we're liable for too much, but something legally stating this partnership. We also plan to have information like analytics based on what we can provide anonymously from our users, anonymously to the establishments to make sure that they can get better market data and get better information about our users anonymously, what we're willing to give them, and that would obviously cost them some, but it would, I think, be very important for establishments, and it's been something that we talked about with them, and they seem to be very interested in it. If you're wondering, the way we plan to kind of implement this model is through some kind of website console where a restaurant could come and sign up and maybe view some of their analytics. That will also help us reach out into a more massive image, because if we have some kind of website, we're able to get new restaurants partnerships with us without having to explicitly walk there. They can sign up to be a partner. But in the present, since we don't have a website like this set up, we have manually walked up to businesses and asked them, hey, do you want to see our app? Do you want to work with us? These are the promotions, you know, Restaurant of the Week, badges, so on. So franchises like East Side Mario's and Fat Bastard Burrito were something that we tried to work with, but we found that it is a little bit more difficult because when you walk in, you are greeted by the franchise owner, which, as much as we wanted to get what we can do for them and what they can do for us, they were actually unable to get stuff like trademark permissions, so they would have to push us into contacting head office, which is great, it's just a lot slower. So getting that information of what we can do for mutual exchange is a bit more slow. On the other hand, something like Wilf's, which if you're not familiar, is the privately run bar in Laurier campus. Something like Wilf's would be privately run, and what we did do with Wilf's is actually we were able to strike a deal with them within weeks because of the fact that it's privately owned. They gave us permissions for their trademark, and they're going to be giving us advertisements and in-store posters and advertisements within their upcoming menus the next time they print. So those are the kinds of deals that we've been working with. This is kind of like what we're aiming for with something like that website console I talked about. It would be great to start pushing to more like national or international borders, because our app truly doesn't have geographical limits. It's just what we can do to partner with people around us. So another huge part, obviously, of the business is gaining users, because what's the point of all this data? What's the point of advertising in the app if we don't have users, right? So it's definitely very important that we gain users to have more effective advertising. And some of the things we've done just to do that are something like making a Facebook post, as you can see on the right, or making our website, as you can see on the left there. And in the future, we plan on posting ads on Facebook, except right now it's business expense, and we're just waiting to promote ourselves. So yeah, so we'd like to buy some ad space on Facebook to gain more users. And of course, today, demo day, we're hoping that, you know, if you haven't already, download the app, and we're trying to get users even out there. So it would be great if you guys could support. But anyways, that's our presentation for today. I definitely encourage you guys to download the app. It's on Android, and if you have an iPhone, then stay tuned because it will be coming soon. You can follow us at the website. And so yeah, I'll open the floor to any questions.
So now that we're at the end of the road course-wise, you started this from the very beginning with Flutter, a very, very new thing, very, very out, fresh off the pipeline. Looking back, would you do it again, or would you have gone with something that was more established, or did you feel that it was rewarding to be ahead of the curve?
I think that Flutter was good given our time limit. In 8 months, it was easy to prototype and work with, but usually when it comes to like hybrid frameworks usually when it comes to hybrid development frameworks, they're not the best for long-term solutions. I feel like if we dedicated time to build a native Android app or a native iOS app, it would be better long-term solution. Just Flutter there were a lot of hacky solutions we ran into, and I think that if we did grow and we had a lot of users, we wouldn't have the support documentation we needed to remedy those errors.
Right.
Is it really obvious though, right? Your hacky solutions.
No,
it's obvious to us.
They aren't super hacky per se, but they're just not ideal. Like, for example, like you were saying, the live GitHub issues that we would see on bugs that we would have just meant that, you know, we couldn't use this widget, which was exactly what we wanted. We had to do something else, which obviously a little bit more lines of code. We didn't want to do that, but we had to.
Does Flutter allow you to do, so like if I'm using React Native, for example, I can inject native code into a React Native app. Does Flutter allow the same functionality?
We haven't personally done it. I'm not 100% sure, but I think so.
Yeah, curious. Flutter doesn't support desktop, eh?
No.
So did you think about plans for like a more web-based client or a native desktop client or some other clients as well?
Like with that web console for analytics we're talking about, we would have had to build something for the web, for at least the business end of things, right? Yeah. We haven't thought about it for, we haven't thought about building a web client for the users and their journaling experiences, but it could be something that we do in the future. Maybe if we were to transition to React Native, it might be easy to have React Native and an iOS app and a React website.
I've got a few other questions. I've got lots of questions.
Sure.
Yeah, I'm not going to ask you about analytics. We're talking about that earlier. I want to talk about users though, like deployments. How many people are using it currently? Do you have numbers?
I don't know if you want a fresh off the box number, but
sure.
I'm pretty sure
whatever you've got is fine. I'm just curious.
40 this morning. We're loading the page. Okay, it doesn't update immediately. So it's been, before today started, demo day, we had 33, and we've gotten a number of downloads out there. So we want to say that we're somewhere around maybe 40 or 45, I'm not sure. Unfortunately, it doesn't update.
No, that's okay. I'm just sort of curious how many installations you've got, right? How that's gone, how you sort of stage the deployment, if you ran it.
So that's the number, and it's mostly spread out in Canada. But there's also some in the States because we have a group member in the States. And then there's like some weird ones across the world. It's like some people. It always happens.
So the way we staged the deployment, I guess, was we have separate branches for release, and we initially launched, was it like 2 weeks ago, the 1.0?
Yeah, I think so.
It was about 2 weeks ago, the 1.0, and then prior to this presentation on demo day, we released a new 1.1 patch with like a ton of polished features. We had plans to just, I guess, keep releasing minor versions.
I did want to ask about your development. I don't want to say processes. I'm not concerned about the formality of it, but you mentioned sort of agile. I'm curious how you actually went through all your feature selection, your iterations, and so on. Because you talked about sort of crafting user stories, doing designs, and then kind of walking through them and reviewing designs. I'm curious, what your criteria was, for instance, like what your selection criteria was, how you determined what you kept, what you threw away, what you revised? Like, how did you sort of handle that?
Yeah, so I mean, it was definitely internal within the group. Only at some times would we get feedback from people around us, you know, friends or family. But the general process was kind of like a role situation. So me personally, I would have like kind of a final oversight on each merge request going into client develop. And so I'd be able to say like, you know, this story wasn't followed, or maybe this just feels weird. So I would send it back to the person who developed it, or I would sometimes jump in because, you know, students. So we just jump in when we have time, help out, and then sometimes that would result in the merge request sitting there for just like, you know, a week if we have to reiterate a design. But that's essentially how it went. We went into Pivotal Tracker a bit. I think he explained it well, but essentially Pivotal Tracker is similar to Jira if you've seen Jira.
Yeah,
so that's exactly what it may have looked like if we had it on the screen. So that's really good.
Pivotal Tracker was useful in sort of scrapping features and creating alternates. If we saw that we couldn't develop a feature within that sprint, sometimes I would come up with alternate designs that are a bit easier to engineer.
Definitely.
Yeah.
I'm just kind of curious about how you moved from, like Figma looks like a mock-up tool, is that a fair way of describing it?
Yeah.
Like, does it produce stuff that you can then
Like import into the
Flutter or whatever?
Yeah, so it actually doesn't have, it does for the web. You can export CSS and those sorts of assets if you were to build a website, but for like Flutter or mobile development, it doesn't. So in Figma, it was more of a set of guidelines to follow rather than strict things like I want the padding to be exactly 30 pixels on the device. It's just more of what the app should look like.
Maybe I'll start to ask questions.
Yeah, question.
I'm just curious. So you got Wolves, right?
Oh yeah.
Did Balmer?
Well, Balmer's gone.
What Balmer? Yeah, there's no Balmer.
You may have missed the article, but they're gone. That would have been hugely ideal, you know?
Right. Yeah.
We're stretching into another campus. It's the strangest thing, but it would.
They have the business students, right? So we can work with that.
Why not?
Sure.
What do you think, throughout your development process, and we can talk maybe early on, what did you encounter? I'm not talking about like technologically, I'm talking about process-wise. What did you encounter that was difficult and that made you guys like stop and think, okay, wait, we have to go back and like do this differently? Like, did you guys make mistakes early on and learn from stuff? I mean, like,
yes, so many things have changed week by week. Even in the second term, you guys may have noticed every week we kind of came in with like, so remember that thing we said? All right, new thing. But essentially, especially in the beginning, the biggest issue was scoping the project, thinking you could do something this simple so quickly. Total lie. Like, we thought, hey, we could do this in like 2 to 3 months, spend the second term marketing the app. So naive, especially being students, having, you know, 100% workload, 20% associated to this class. You know, you're just not going to be able to do that, especially even if you put more effort into the class. So non-technically, that was probably the biggest issue, was every time we did something, we wanted to make sure, you know, can we finish this for the next deadline, especially with the course? Can we finish this for the MVP of the next deadline? So yeah, definitely a lot of iterations along those lines. I can't think of any off the top of my head, but you saw them last time. Yeah, the profile page, for example, 2 weeks ago got cut off.
No, you guys were definitely the most agile out of all of them, because there were definitely features that were coming and going. Like something would disappear and a few weeks later be back, and yeah, there was a lot of that for sure.
So you're the largest team, of course, right?
I think that much.
They also seem to like work, like be well organized and everything. Like, was that 1 or 2 of you kind of driving that? Like, I saw your footprint all over, obviously, Pivotal Tracker. Right?
Yeah, I tried to make sure that I was in charge of the Pivotal Tracker. Like, of course, anybody who was working and they found a bug or something that I didn't find, or that I didn't track myself, like go ahead and track it in. But it was definitely, yeah, it was a lot of responsibility to make sure things didn't overlap. And I was setting up a lot of pivotal tracker. He was mainly the designer.
Yeah, so I was a developer in the first 4 months of the term, but then I decided in the second half that I would step up and dedicate my entire time to design and product design features and all that stuff. And I found that allowed, I guess, more freedom for the front-end developers, so there wasn't as much like overlap between what we were coding.
Yeah, that was another big thing.
Also, I think with the designs, the designs had to be done before the front-end developers could actually code, right? So there was always the pressure of having to have designs done before.
Yeah. So yeah, it was difficult, but yeah, that's kind of how it went down.
Look good from the outside. I think we should probably move on for the next week. So thanks a lot.
That was like a condition to clap at the same time.
Yes.
Did you want to debrief what Pastor said? Yeah.
Well, guys, thanks.
Thank you. There's an
Sure. Okay. No, I wasn't sure if you were from what I thought you were going to do, but I'll just file this in and then I'll talk about it.
It's kind of like branding.
Yeah. Okay. Sounds good. Thanks.
Alrighty. Okay.
So, is it elevated on stream? How
This is Jeff. Yeah, let's see all our referees.
Okay, so Jeff is here. I don't see Jacques.
No Jacques.
Did you guys see Jacques?
We haven't seen Jacques. He said he was going to show up just before I started. Yeah.
I can look and see if people are watching on the stream. Maybe he sent me an email, I don't know.
Oh, if not, then we'll just
I'll write comments for Tim.
Thank you.
Okay, well, I will guess that Jacques is still in the car.
So it's just like.
Yeah. That's a pity.
So there'll be videos, right?
Yes.
So, we are Charles Zinn, Jim Zhang, and Dimitri Clear, and we are Team Address Team. And we made a mobile game also called Address Team. This is so this is the general outline of our presentation. And we'll start with why did we make a mobile game called Address Team? So we, in general, are fans of strategy games, in particular real-time strategy games like StarCraft or Command & Conquer. And we like them because not only are they fun, but they're fun because of their deep strategic aspect. Figuring out the correct strategy to outsmart your opponent is interesting. They have a problem though. You need to actually sit down at a computer in order to play them. And sometimes, depending on what game exactly you're playing, the match can take quite a while. Mobile games obviously don't have many of these problems. They are quick and easy to play, and because they're on mobile, you can play them anywhere. So we thought, can we have the best of both worlds? Can we take the deep strategic part of real-time strategy games and combine it with the easy-to-play part of mobile games? And also, while we're doing this, can we design a game that an AI could play easily enough that we can use the AI to check if the game is balanced, rather than relying on user complaints about lack of balance? So this demonstrates where we want to be in the deep strategy commitment space. This is our logo for clarity. We want to be the deep strategy, low commitment game. So what we actually built, the game itself, gameplay is as follows. You select 3 books of spells. Each turn, it's a simultaneous turn-based game. You cast up to 3 spells from your spell books. And cast up to 3 spells. You try to drop the opponent's health to 0, and the opponent tries to do the exact same to you. At the end, you get to see exactly what you get a replay of the game. A key aspect that will show up several times is that you don't get to see what books the opponent chose. So the results of our game were good. We released about 2 weeks ago, and we got a 4.9 out of 5 on the Google Play Store. We got over 300 users. We got over 1,000 games played across those users, and we got, most relevant to our design goals, an average length of about 3 minutes per game, showing that we actually met our easy-to-play requirement. These are testimonials from our users, and these are testimonials from users that we don't know. These are random internet people. So not only is this nice because they say our game is nice, but it's nice because they, without being told what our design goals are, confirm that we met them. They say things like, I like playing short rounds in multiplayer as a coffee break activity, so that's the low commitment. They also say things like, I love the endless possibilities of simple rules. The multiple combinations of decks makes for tons of fun. So we met the deep strategy requirement as well. These are our productivity metrics, and long story short, we worked a lot on it. Most interesting is this line right here, that there were at least 2 full versions of this game that, like fully different versions of this game that we discarded entirely. We iterated through a lot of possibilities of design, because making a game is hard, making a fun game is really hard. So now Jim will discuss the presentation.
Thank you, Dimitri. So I will talk about how we made this game called Dress the Dead. And first of all, I want to talk about the thought we put into designing the game itself. And we identified 5 core principles as important for the game. First, we wanted to make our players make interesting decisions. And we did this by identifying this triangle, which we believe to be a core essence of many strategy games, and many kinds of games in general. Every one of our spells falls into one of these 3 general categories of attack, defense, and economy. And in this way, there's no one best spell that simply dominates everything. You always have to be thinking about the trade-offs that you're making. Second is that we want some amount of hidden information that one player knows about, but the other doesn't. This is mainly to add excitement. We want to hide some of what each player can see, so that there's these mind games that go on where you try to peer into your enemy's mind. And this, we imported this from kind of from games like poker. So third, although our game is turn-based, both players take their turns at the same time. And this is different from traditional turn-based games like chess or Hearthstone, where half the time you aren't actually thinking deeply. You're waiting for the other player to make their move and to finish their 20-card combo. This simultaneous turns aspect means that both players in our game continue to think, and keeps the action high. Fourth, we didn't want any randomness in our game. Previously, we mentioned that we had about 5,000 lines of prototypes that we discarded. A previous game prototype had, instead of spells, it was 2 armies, and the armies randomly attacked each other. And we found that this, even though it wasn't like, because of central limit theorem, it's like not mathematically super random, but it felt very random, and we felt that this greatly diminished the value of victories. We also felt that the other aspects, hidden information and simultaneous turns, provides enough unpredictability. And this unpredictability comes strictly from your opponent. And finally, we wanted to make a game that we could write an AI for. And this came in handy in several ways. One of the things our users requested a lot was they wanted to play offline. So we have an offline versus AI mode on the phone app where this AI runs. Second, we run the AI ourselves to test game balance when we adjust the rules. The 7 books and 4 spells per book took quite a bit of effort to come up with, and using this AI against itself provided a quick way to check whether any one spell was particularly overpowered. And finally, we use it on the server side. So what we do is, if there's one player who's online in our game and they're waiting for someone to play with, then after a certain amount of time, we'll actually match them with an AI and say, here's another player, have fun with them. And so there's an interesting story from that actually, where one of the players from our subreddit said that they had a long, interesting battle that let us both max out 2 books. So they had a long, fun game, and we looked at the logs after, and they were actually playing not against another person, but against this AI. Now I'll talk about how we organized the code for this game. And essentially it's split into client-server and shared bit in the middle. The very first thing we wrote was the core game logic. So we defined data structures for what is a player, what is a book, what is a spell. And we combined all that into what we call a game state. So our game state is modeled as a state machine. This state machine takes the list of both players' moves, and using a simulate function, it can update itself. Another thing is that we don't want to be sending this entire game state to the players when we on their phones. Otherwise, they can see information if they look into the packets that they're not supposed to see. So we have a concept of a game view, which is like a state with all the information that you're not actually supposed to see stripped out. So that's game logic. Our client, the client that runs on our phones and on laptops, we made this using the Godot game engine. So this is an open source game engine, kind of like an open source Unity. And we used a Godot module called GD Native to interface with our native code that we run. So this, like C++ game logic in the center, it's the thing that's running on the phones, on the laptops, everywhere. We wrote our server in C++, and we store our data in a Postgres database. And this server also uses the same game logic. And finally, we wrote an AI based on this game logic. And as mentioned previously, this AI is used in a couple different places. It's used on the client for offline games. It's used on the server to provide simulated players for when we don't have enough. And we use it ourselves to kind of test the game. So now Charles will talk in depth about how the game's AI works.
Cool. So Drestia is an interesting game for writing artificial intelligence because it differs from a game like chess in a few different ways. First of all, it has imperfect information, so you don't know the exact state of the game. So for example, in Drestia, you don't know exactly which books your opponent has or which spells they've unlocked until they've cast that. And so we read some papers about adapting Monte Carlo research for games with imperfect information and found the concept of determinizations, which is where you assume that there is some fixed state of the world and then treat it as perfect information game. And then on each iteration of your algorithm, you choose a different state of the world that it could be in. And the effect of this is that in the initial part of the game, where you're highly uncertain about what your opponent's hidden information is, you play very safely. You place moves that are good against a broad range of possibilities. And then later, once you have seen what your opponent has, and you're more certain about what their abilities are, then you can do more specific targeted strategies because you're not so uncertain. The other difference between a game like chess and Drestia is that in Drestia, turns are simultaneous. And if you think of a game like rock, paper, scissors, which is another simultaneous turn game, if you model as a tree, this is not really the right model. Because it looks in this model like player 2 can always choose the right move. And so if you're trying to evaluate this, you would say, oh, well, player 1 always loses this game. But that's not how it works in real life. In real life, player 2 can't distinguish between these nodes. And this ties back to the concept of game view, which we discussed earlier. So by basing the player's choice only on the game view, or a hash of the game view, we ensure that the player is not unfairly making distinctions between states of the world they can't actually distinguish between. An equivalent way of modeling this, and is perhaps conceptually easier, is as a matrix, where each turn of the game is a matrix with one player's choice on one axis and another player's choice on the other axis. And then on each step, you would choose one of these squares based on each player's action, and then send to the child game state. And so that brings me to how we handle this state and how we solve this part of the game. So we use an algorithm called counterfactual regret minimization, which is a method of iteratively finding a Nash equilibrium, a mixed Nash equilibrium, for one of these matrix games. Briefly, how the algorithm works is each player keeps track of how much they regret not doing some action in the past, and this is accumulated over many simulations. So on one step of the simulation, you choose an action for each player, and then figure out what they would rather have done in this counterfactual situation where the opponent has made this action. So for example, if player 1 plays rock, and player 2 plays paper, and then you rock, paper, scissors, player 1 regrets not playing scissors, because then they would have won. And they also regret to some degree not playing paper, because then they would have at least tied and scored 0 points rather than negative 1 points. So these are accumulated into your regrets, and you repeat this many times. And as I mentioned earlier, to deal with hidden information, we use determinizations. And over time, the regrets will fluctuate around different values, but the average strategy selected will converge to a Nash equilibrium. And this ensures that our AI is choosing a balanced policy that isn't exploitable. So if there wasn't anything we would do differently in hindsight, it would be kind of a failed learning experience. So there's a few things we would possibly do differently if we were to do this sort of project again. First of all, making a game was a lot more work than we expected. We had all experimented with making games on our own before, and so we thought we had a good idea of how much time we should allocate and how we should plan our timelines. But polishing the game and doing the UI and shipping it to the App Store all took a lot more work than was originally expected. And that resulted in us only releasing the game to the general public 2 weeks before Symposium Day. And while we still got good results in that time, we think we could have gotten a lot better results if we had done better planning and had pivoted less and had that better timeline from the beginning. Also, writing everything in C++ possibly added a lot more complexity than it removed. So it let us remove complexity because we were able to write the game rules once, and we were always assured that the same game rules were running on the client and the server, and those were always in sync, and we only had to update one thing when we wanted to make a change. But the downside was we had a wrapper layer which was complex because we had to unify Godot's world of types with C++'s world of types, and they have different ideas about how types would work and how memory management would work. It also meant we had to write the server in C++, and we missed out a lot of high-level libraries that are available in other languages that are not as developed for C++. So that is Adrestia. It is available for download at our link, Android, Mac, and Linux.
You can also get it at the Google Play Store.
It's also on the Google Play Store. And we'll take questions now.
I'll start with one. So, I'd actually like to dig into a little bit more about why you chose for no randomness in the game. Because even games in which, say, winning and losing is mostly determined by player actions, there are critical hits or something like that, or missed chances for attacks or something like that, which necessarily have some random element. And while I can see how you don't want it to feel like winning or losing is random, does not having a random element mean more or less that the game is rather predictable?
I think that in some sense we were adjusting away from this previous iteration where we had too much randomness. But also I think that because we have hidden information in simultaneous turns, there is still this uncertainty. And you can still in some sense get lucky even though there's no randomness. If, say, you happen to choose the one slot in the turn where your opponent didn't have a shield, and that's where you put your powerful attack, and you happen to get through. So you can still get that feeling of being lucky, while still sort of believing that, okay, I chose that. Everything was by design, and there's all my choices, my opponent's choices that determine this result.
But would you consider having things like attacks that have a chance to miss and critical hits and that sort of thing? Do you think that would improve the game, or?
No.
I think that it's not a bad idea in general, but I think with our game, it wouldn't fit with the rest of the design where everything is
It also helps the AI process all the turns far better when it's a fully deterministic state machine, and it allows us to leverage the advantages of the AI a lot better because the AI is not trained. It executes at runtime, so anything that makes the AI's job more complex, makes the AI dumber, because we can only allow it so many cycles, especially on a mobile phone. Additionally, part of the pushback against randomness was from our users. That earlier version of the game we pitched to users even before we made it, and the resounding comment from everyone, and we thought we were better than them, we were not, was no randomness, do not put randomness in. Randomness is the big problem with your model. Take it all away. We heard that from more than one person.
Okay. Ignored it to our parent.
Yes. So I'm curious, so you made a comment early on about there's at least 2 versions worth of game that were discarded. I'm really curious what you discarded, why you discarded it. Was it features? Was it technical issues? What was sort of the motivation? Why did you discard it?
So the previous 2 versions of the game, one of them was the 2 armies kind of scenario that I mentioned, where each army attacks the other army randomly. And we felt that simply the main idea for the game was irredeemably bad. There might have been some things we could have done to incrementally make that fun, but it required a revolutionary change to kind of push us to this new local maximum. And that came, I believe, to Charles in his sleep, because one day he just woke up and said, what if we did magic battles, wizard spells? And we all loved it, and so here we are instead.
Well, that's great, because you have to be brave sometimes, right? In doing this sort of.
You want to avoid the sunk cost fallacy of we're so far along with this one thing, and you just working really hard on something that isn't going to pan out.
The other version, which was quite a bit different, it was similar to this, but still quite a bit different, was also magic spells, but we had a bunch of spells. So it wasn't clear here because we didn't give a full demo of the game. But the spells in the books are organized in a very particular way. Each book, in our conception, has a sort of personality. For instance, the Book of Bloodlust we thought of as the Berserker, who always attacks. Its first spell is attack. Its second spell is attack, but it also makes your attack stronger. It's just attack, attack, attack. Every book has this sort of person behind it that allocates allocates spells to it. Also, there are 4 spells in every book. The spells cost 1, 2, 3, 4, 1. It's all very rigid, and that lended itself well to creativity. The earlier version did not have any of this. There were an indeterminate number of spells with an indeterminate cost, with indeterminate effects. And it was all over the place, and you couldn't figure out what strategy to use.
So, from a design perspective, how do you balance then the need to keep things in a rigid, 4 spells per book with these certain specific costs? I mean, it's got to be difficult to sort of do that where you have a fairly rigid structure, but you still want the game to feel fluid and creative, and not like every spell of level 2 from every book is going to feel the same, right? So, do you understand what I mean by the question? So, how did you balance that, or how did you test it? How did you sort of determine the right balance, I guess, between books?
I think actually constraining ourselves led to more creativity. When we were trying to optimize all these different values, it was kind of hard to be creative within that space. It was just such a huge space to explore.
Yeah.
And once we constrained it, I think we were able to be more creative and figure out, okay, in our remaining dimensions of variability, how can we differentiate each book and make it feel interesting? And so it was like a smaller space and therefore easier to optimize with it. And it makes sense.
But how much room is there for expansion in the future? And I use the word expansion as in like expansion pack in this case, because generally speaking, to keep games fresh and to keep people playing them, updates are released that have new features, new characters, new types of something. So how well does that work for your game?
Yeah, so our users have actually asked for so many new features that we will be, continuing to work on for the next, few months. One large thing is a single-player campaign where you kind of have a list of chapters, you have puzzles to solve, using our game mechanics in each chapter, and you kind of advance the story along. I feel like that would be a lot of work, but is very exciting. Another thing is cosmetic upgrades for your avatar. Right now, everyone's a featureless circle because programmers don't do art. But adding little hats, little book trinkets for that to customize your character in game would I think be cool, and also adds a monetization kind of route.
This is the monetization route taken by a lot of strategy games these days, like Dota or League of Legends or Fortnite, where you buy things that don't change the gameplay. They don't make you stronger. It's not like a pay to win, but they add a sense of personalization to the game.
If I can turn that question more technical, if you wanted to introduce a new spell book, have you estimated sort of how much more difficult that would make things in terms of implementation and the AI and so on?
Sure. Not much, in short. So, as mentioned, we use the AI to balance, and often the AI, and occasionally users, because the AI is not perfect, will find something that's not balanced. So fairly early on in the development process, certain architectural decisions were made that made it very easy to update the rules and extremely easy to update the numerical values of the spells. So if you saw our poster, we had Python as a logo on our poster, even though Python didn't show up in the architectural diagram that we showed. That Python is used to generate the JSON rules that our game uses. And essentially, this mechanism means that whenever our AI finds something, we can correct it very easily. But this can be extended to introducing an entirely new book. It would be more than just changing the numbers of the existing numbers, but it would be much more. And as an example of exactly how fluid we've gotten it, earlier today at the symposium, the AI was demolishing people with a spell called Harm, and that made things not fun because people just got annihilated by the AI. So we issued a rules change just this morning that made Harm less powerful. And this didn't require anyone to download a new version of the app. It didn't require us to rebuild anything.
It took about 3 minutes.
Yeah.
Okay, but part of my question was like if you added an 8th spell, it is 7 that you have, correct?
Yeah. So
if you add an 8th spell group, that doesn't double the amount of time it takes for the AI to decide what to do.
No. it results in possibly some less accuracy early on when it's in that state of uncertainty, because it has to simulate through a broader range of books, and so spending a bit less time simulating each book. But I mean, very early on, you only want that broad conception of like all the things that are available, and so it wouldn't significantly affect the performance of the AI.
Okay. Quick question. You mentioned earlier about going through logs of a game the user played. You actually collect data from your users, like you.
Yeah. So for the multiplayer games, those are all stored in the database as they're being used up to information. And then all those games are just in the database waiting to be.
Oh, I see. So it's not the single player offline stuff that you're collecting. It's the.
We initially were not connecting the single player games, and then later we realized that we wanted to find out at least how often people were playing, and so we had the client, just when the user connects, just upload the offline game data.
Okay.
So that is still available for analysis and for our tracking.
But thankfully, we avoid all sorts of weird privacy concerns by not tracking any actual user data. The users are only known to us by their avatar name, as well as randomized text to allow people to have different avatar names.
And it's in very fine print at the bottom of the screen.
So I have a couple of questions. From what I heard, I heard you had 3 requirements. You wanted a strategy game, you wanted the turns in some sense, or the rounds to be fast and casual, and you implicitly wanted your game to be simple enough that your UI could work on mobile. Those are the 3 requirements I've heard. Did you have other requirements?
The other requirement would have been we wanted the AI to be able to play the game so well that it could be used for balance. That was always a guiding principle, although it obviously doesn't show up so directly to users.
Yeah, these were, we had some of the constraints in our design goals originally were like, the combination of strategic depth and approachability of the whole game. And these were the other guiding principles that we developed along the way of satisfying those design requirements.
This would probably be the 3 main things.
Yeah.
Okay. Yep. Good. I tend to take a very player-centric position when I teach game design. And so, Capstone, which is going to be 2 weeks for my course, the biggest question I always ask is, what player experience did you design for your player?
So, again, we wanted the experience you have playing a strategy game where you're making complex strategic decisions and trying to predict what your opponent is doing and trying to outsmart them in that way. We wanted that to be sort of the high-level conceptual experience while still having, work on a phone and have a short game. And so it was identifying the this strategic trade-off was, I think, what we wanted that core experience to feel like. Or at least that's what we felt the core experience of a strategy game, a real-time strategy game was.
So in terms of more visceral, feely terms, I don't play StarCraft. I play Command and Conquer and Supreme Command, and things like that. So in Planetary Annihilation, which is like Supreme Command, you can do a thing where if the opponent doesn't notice that you're parking a weapons satellite over their base, when the satellite turns on, it will annihilate. And when I pull off this strategy, I'm like, ha, he didn't notice, I outsmarted them. But you have all the disadvantages of a strategy game with Planetary Annihilation. So we wanted to port that, ha, they didn't realize my strategy, but my strategy was better than theirs, onto mobile.
Can I ask another question about player stats? Since you track those kinds of things, do you see that users will play for a little bit and then come back sort of later in the day, or do they play for a longer session?
We had a few users who like marathon the game. We had one year, especially on our first few days, we played something like 50 games in a row, or at least over the course of the day. And then we proceeded to...
Could have been on a bus or something.
Yeah.
Why not?
Yeah, we've been noticing users continue to come back over the course of the week and play more games. So yeah, we don't have like the long-term user retention stats yet, but we're pretty happy with what we've been seeing so far.
Off the top of your head, and if you don't have this, that's okay. Do you know how many people play single player versus multiplayer?
So it's kind of hard to know because we weren't tracking single player in the when we first released the app.
And that's when most users were playing it, because by far the biggest uptick in play we had was on release.
So I don't know what those numbers are right now. From what people were commenting on our initial thread, it seems like a lot of people were going on and playing a bunch of single player, and they weren't during multiplayer. And so that'd be something to investigate, is why they were feeling like intimidated from the multiplayer. Now they weren't doing that more.
All right, thanks very much, guys. Great job. Yeah, so Elliot did join us. And Jacques is here. So everybody that you were hoping for is here.
Excellent. Thank you.
Thank you all.
Hold on.
Yeah, so for the referees, you know, there are words on those sheets, and those are meant to be suggestive words, not restrictive words. I want your professional, you know, you're chosen because of your professional expertise, and, you know, the feedback that you think is important for the students and the evaluation that you think is important is what's valuable.
Shall we execute our 5 online?